Good morning, everyone, or good day. We are about 5 minutes from the top of the hour, and so we'll begin in about 5 minutes.
Recording in progress. All right, good morning, everyone. Thank you for joining us again on our fourth and final day of the Exploration Science Forum and the European Lunar Symposium. We're happy to have you all, and we're starting the day off with a bang. We have 4 representatives from 3 different agencies here to share a little bit about the future exploration in each program. Unfortunately, we only have 15 minutes, so we're not going to hear everything from everybody, but we are going to get a taste of what's coming, and we'll have a little bit of time to ask questions. So I would like to introduce my, my co-chair. We have Claudia Poehler, who is from the University of Münster, and she's early career, and we're happy to have her. We wanted to make sure we had some international representation here this morning with our international agency panel. So I am going to take the first introduction, and then she'll join for a couple, and I'll be back at the end. I would like to say that we had announced that people could use the conference.io system for questions for this panel, but nobody has asked any questions there. So please use the chat window at this time for your questions, and we will use that and/or raised hands as we progress. So with that, I would like to introduce James Carpenter. He's the ESA Moon Utilization Manager. And I don't want to take any more of your time. James, are you available?
I am. I'm here. Can you see me and hear me?
We can.
Marvelous.
Thank you.
Okay, so I'm going to attempt to share my screen. I can work out how to do that with this.
At the bottom, the green arrow.
Ah, yeah, sorry. Right, there we go. Okay, so can I just check? Are you seeing something?
We are.
Marvelous. Good. Anyway, so thanks very much for having me this morning, this afternoon, this evening, wherever you are. Yeah, so my name is James Carpenter. I'm from the Directorate of Human and Robotic Exploration, the European Space Agency. I'd like in the next few minutes to give you a bit of an a view of what is happening currently within ESA, within our program, and some perspective on what perhaps is coming in the next years. So I know you heard from my boss earlier in the week, from Dave Parker. I know he gave you a great overview of the program and the plans. So what I hope he explained to you is that we are currently in, we have a program called the European Exploration Envelope Program, or E3P, which is becoming something new, which is called Terra Novae, or New Worlds. And at our last ministerial council meeting, when big budget decisions were made, at the end of 2019, we got approval to start a new program for lunar exploration. And in this program, we have a number of elements you can see here in the view chart. So the first of those is, if I remove this, okay, so the first of these is the Orion, or our contributions to Orion, so the European Service Module for Orion. We also have contributions to the Gateway, so it includes the international habitats and various other systems that are going on Gateway. And we're now beginning our first payload developments for the first utilization of Gateway for science. We're also contributing to missions with international partners going down to the lunar surface. So you see here Lunar 27. There are others, and I'll talk a bit about those in a few minutes. We've also started the development of some new activities. So the first of those is what we call the European Large Logistics Lander, which will be a lander capable of delivering around 1.5 tons of payload to the lunar surface for logistics and for science. We're also looking into a cislunar transfer vehicle to provide logistics support in cislunar space. And we're looking at developing a communications and navigation service around the moon, working with our partners in the telecommunications and navigation within ESA, and with commercial partners too. So putting all this together, it provides us with a package to provide sort of European science and technology at the lunar surface, but also provide contributions to participate in Artemis and programs with international partners. So what we want to achieve in all this, I don't have very long, but in summary, we want to understand what it means to live and work in the lunar environment. We would like to understand potential resources and establish how we might use them in a responsible way in the future. We'd like to establish the moon as a platform for sustained scientific research and utilization going into the future. We want to make sure we create roles for European industry and commercial opportunities for the European economy. We want to build international partnerships that enable exploration for the near term and the longer term, and learn lessons from what we do on the moon to prepare capabilities that we can take onwards for the exploration of Mars. So I'll go through a little bit about some of these things and what we're doing in this period of our program to respond to some of these things. So the first thing will be about preparing to live and work in that environment. So what we're doing now is we're starting to work to characterize the integrated environment. So that's radiation, plasma, dust, and those other things in the gateway environment and at the lunar surface. And what you see below here are two payloads. The first of those on the bottom left is, I guess, a very early CAD model of something called ERSA, which is the European Radiation Sensor Array, which will characterize the radiation environment outside Gateway. And we're also looking to characterize the radiation environment inside Gateway to understand what that means for the risk factors for human exploration. We're also working on things to go to the lunar surface. On the bottom right there, you see something, the heart of an instrument called the exosphere mass spectrometer, which will characterize the exosphere at the lunar surface as part of a collaboration with NASA on the Commercial Lunar Payload Services Program, and I'll talk more about that in a moment too. So we're looking to characterize those environments. We want to determine the environmental impacts of human activity, how we change the environment. We want to measure the effects of the environment using ground-based research facilities at Gateway and at the lunar surface. And we want to learn how to mitigate the environmental risk factors for technology, biology, human health, and performance. So we've started some serious work on that. The second part, maybe to talk about our ESA contributions to what I've written here, you can't see, is to an international program or international campaign of lunar polar prospecting to look for ice and other potential resources at the lunar poles. Now, this is pretty exciting. What you see internationally right now is there are missions from all over the world going to the lunar poles, in particular the South Pole, to map really the regional distribution and properties of water, ice, and other volatiles there, both for science and as a potential resource in the future. And we're contributing now to a number of missions with international partners. So you heard earlier in the week about Prospect. I think you've probably heard about the EMS as well. So Prospect, you see here, is a package to drill into the subsurface, extract samples, and then analyze those to look for water ice, its origins, its evolution, its properties, and other volatiles that are in there too, both for science and also for exploration for resources and understanding them. So we're preparing, we're building the Prospect for the Lunar 27 mission as a partnership with Roscosmos. We're now preparing a second build of the complete Prospect system as a cooperation with NASA for a commercial delivery, which we're expecting circa 2024. We're working on EMS, which is this bit of the subset of Prospect, which is a small mass spectrometer. And we're developing that now both for a precursor mission as a partnership with Goddard on the PITMS instrument for Eclipse delivery intended on something at the end of this year with Astrobotic. And also an evolution of that instrument we're looking to fly now with JAXA as well on their Lupex rover. And so with these, we're contributing to a number of different missions to understand and explore the polar regions for science and exploration. And on the right-hand side of this image, you see the flight hardware that's been delivered now to the US for integration with the Astrobotic lander for this first delivery of EMS to the surface of the moon with PITMS. And the drill bit you see there, by the way, that's the drilling and sampling mechanism on the end of the Prospect drill, which will go a meter beneath the surface. And also now, so that's, if you like, the first phase of exploration like this is to explore the distribution of volatiles around the regions in the polar regions of the moon. And then the next stage would be to integrate that into a geological model of where we think resources would be and to go and explore those in more detail. And for that, we have a pre-phase A mission study ongoing with the European industry to look into a polar explorer mission to go and explore a resource deposit. Second thing we're doing is we're preparing in situ resource utilization. So for that, we have a number of activities going on in ground-based research into ISRU processes. And we're also working on an in situ resource utilization demonstration mission concept for a decision in 2022, which is when our next ministerial council is to decide the future program. On the left-hand side of this image, you see the example, I think it's quite an old picture now, most of you have seen this before, of where we've taken a regolith simulant and we've performed a reduction process on it, and on the right side it's shiny because it's mostly metallic. On the other side, we've taken all the oxygen out of those samples. So credit Beth Lomax with doing the research that led to that image. And on the right-hand side is the outcome of one of our early studies into this ISRU demonstration payload, to take one of these processes and to demonstrate it on the surface of the moon to produce oxygen from lunar minerals. And then we want to prepare the surface of the moon as a platform for future research, for future exploration. So to do that, we want to provide early science on the surface with partner-led missions from the early 2020, from now. So on the bottom left, you see like the first example of this, which is a lunar laser reflector being developed by INFN in Italy, which we're contributing to a NASA-led commercial lunar payload services delivery in 2023. And we're developing that now to flight. We're also looking to prepare science deliveries from the mid-2020s with international partners, or that could be with a commercial delivery from ESA. We're looking to contribute to international lunar sample return, and so we're developing the capabilities in Europe for that as contributions to that, and also how you might contribute to that through Artemis as a whole and our contributions to Artemis. And we're looking to prepare research missions and infrastructure that we could develop in Europe as part of an international campaign of lunar exploration for the late 2020s onwards. And so for that, we have topical teams, or scientific topical teams that are in place, and many of you are here now, and thank you for everything that you're doing to support us. So topical teams are defining what are the science goals, what are the objectives you want to achieve with that. In parallel, we're running a number of phase 0 and pre-phase A studies internally at ESA and with industry on missions and on payloads that could deliver on this science. We're looking specifically at polar exploration, at geosciences on the moon, and astrophysics, in particular looking at from the lunar far side, looking at long wavelength radio, and life sciences, how we might use the lunar surface as a location to understand the effects of different environmental risk factors on different kinds of biology. And on the bottom there, you see some examples of just some early catalogs and some of our internal studies looking at some early examples of what these might be, and their delivery with the Large Logistics Lander that we've started development of now.
James,
and then as we look forward, and as we look forward to the future program, so at the end of this programmatic period, which will end at the end of next year, we will go into the Ministerial Council of 2022, preparing it to request a new program. And while that program proposal is in preparation now, some of the things that are likely to be in, or we're considering going in there, would include developments to flight of payloads for partner missions, payloads for potential ESA-managed commercial payload deliveries, and payloads for the first EL3 mission, which would include science and technology from Europe, alongside potentially cargo for Artemis or other contributions to lunar deliveries. We would be looking at starting phase A and B1 and technology developments for candidate lunar missions and for candidate lunar payloads for later missions, and looking at starting phase 0 and pre-phase A studies for very new and novel mission ideas or research facilities for the surface of the moon, and for novel lunar payloads. And while we have a lot of activities running now, we are currently preparing payload and mission selection processes. So we've created in the last years a lot of options, and now we have to work with our member states and our stakeholders to define on how we're going to narrow that down to decide the things that we are going to do. And so in the next months, I hope you're going to see from us some information, some communication on the processes that will be applied to take decisions on what we fly and what we develop, and how you can be involved in supporting, responding to those opportunities. And that's everything from me. Thanks very much.
Wonderful. Thank you. That was a great overview, and you got a lot in the time we had. Oh, great. We have a question. This is from Mahesh Anand. Great presentation, James. If all currently US ESA-backed lunar missions comes to fruition by 2025, then do you expect the next phase of ESA-backed lunar missions to be sample return from polar regions for developing a better understanding of lunar resources?
So we're investigating a number of different mission types. I would say that we had actually ruled out for the time being an ESA-only sample return mission. I think the emphasis from ESA would be to work on contributing to Artemis so that we can participate in a deep way in the Artemis program and provide benefit for the European science community in terms of samples by cooperating with the US on that sample return from Artemis. Space resources and understanding space resources is going to be part of what we do in the coming phases. Alongside pure science, I mean, we're going to have a mixed portfolio. Space resources is definitely going to be in there, and I think it's going to be a growing topic internationally in the coming years. And I think I hope that Europe will play a substantial role in what's to come. I hope that answers your question, Mahesh.
Okay, great. And I have one question. Did I hear correctly, and if I'm wrong, I apologize, that there is a partnership with ESA for PRISM? That's the next PRISM call that's coming out of the US, or am I mixing that up with something else?
So, I mean, I'm perhaps referring to the PRISM call specifically. I think I would defer comment on that to NASA colleagues who are running that.
Okay.
But we are
no,
working
I know
on,
it's a NASA. I know it's a NASA program.
Yeah.
I thought
So,
there was a European element to it.
So there are two payloads that we are working with NASA to potentially fly as part of CLIPS deliveries. One of those would be a laser retroreflector.
Yeah.
And the other is the full prospect package as a contribution to this broader campaign of lunar polar exploration to understand the volatiles in the lunar polar region.
Okay. Okay, wonderful. Well, keep an eye on the chat if you could. There's nothing else right now. Oh, and Ryan Watkins, just to clarify, what I was confused with is it's Canada. So apologies, James, for putting you on the spot. Okay, so I'm going to hand it over to Claudia to introduce our next speaker.
Yes, thank you. So thanks for this great overview of ESA activities. We're now moving over with Sarah Noble, SSERVI program scientist, talking about NASA lunar science. Go ahead, we see your slides and
Great,
we can
hear
hear you.
Can you hear me? Excellent.
Yes.
Great. Okay, so I'm here today representing both PSD and SEO, so get the full SMD experience. And I just want to start out by saying, you know, it's a really great time to be a lunar scientist. We've seen all this great science the last few days. There's a lot going on. We've got still LRO and Themis Artemis up there going strong. Lunar Trailblazer and LunaMap. Lunar Trailblazer just passed their CDR. Congratulations, it's fantastic. LunaMap actually just got integrated onto Artemis 1, so it's actually in place and ready to go. We've got CLIPS and Viper. You've heard from folks from both of those this week. And ANGSA and Chip also talked earlier this week. So you can see that we've got a lot going on all fronts right now. I wanted to show some pictures that some of the ANGSA folks sent of them getting back in the lab. It's so fabulous to see people back in the lab working again. I know it's been a really hard year for a lot of people for a lot of reasons. It's great to see people getting back in the lab, getting back out into the field, and getting back to some sort of new normal, at least again. We keep getting questions about the relationship between PSD and SEO. That is the Planetary Science Division and the Exploration Science Strategy and Integration Office for the students in the room, and how they fit together, right? And so I thought I would go over this again. I feel like we've done this a few times, but you know, it doesn't hurt to go over it again, right? And so this is the basic org chart of the Science Mission Directorate. It's divided into 5 divisions: of planetary science, astrophysics, helio, earth science, and we just added the biological and physical sciences. They used to sit up in HEO, but they have now joined us down in SMD. They've been part of our group now for about a year. Those are our divisions. SEO is a separate office. It sits under SMD, but not under PSD. So it's its own office. It's not a division. It's a separate office. The confusing part comes in the budget. So while the LDEP budget, the Lunar Discovery and Exploration Program budget, is part of the planetary science appropriation to NASA. So if you see the spreadsheets of budgets that come out of OMB, that come out of Congress, you will see LDEP listed under the Planetary Science Division. But that budget is actually executed by the SEO office and not by planetary science. So that's, I think, where some of the confusion comes in for folks. I sit in both offices, and so if you ever have questions and you need to figure out where something sits, you can always come to me. I'm always here to sort of field the interface between those two groups. I also wanted to show the org chart for the SEO office. We're a pretty small group of intrepid, lunatics up here, led by Joel Kearns. He is the Deputy Associate Administrator for Exploration, pronounced that DAX. He is currently looking for a deputy for an associate DAX. Those applications are due August 3rd. So if anybody out there is interested in joining our merry band of lunatics, please do. Please come join us. We are happy to have some help, more help in our office. I also wanted to point out that just since the pandemic happened, we have actually added a couple of new faces that are, I think, very familiar to this community. Both Deborah Needham and Ryan Watkins have joined us. So we've got, now we are expanding a little bit, but we're still a pretty small office. Nimble keeps us on our toes. A little bit of clarification about who does what. Now, to be clear, these are not comprehensive lists, but if you are wondering where things fall, right now, under PSD, we've got the Viper rover, the Lunar Trailblazer and LunaMap, our simplex missions, and most of our lunar RNA, like SSERVI, as well as LDAP, ANXA, those are being managed by PSD. Under SEO, we've got the LRO mission. It used to be under PSD. It's been moved. It's now under LEO. It's now under SEO. We've got all of our CLIPS payloads, and including NPLP and LCIP, as well as the new PRISM payloads. Any gateway science payloads, Artemis science payloads, anything that sort of is cross-directorate across SMD or cross-divisional across SMD or cross-directorate between SMD and other parts of NASA. That sort of integration coordination largely happens under SEO. Speaking of CLIPS, we keep showing this versions of this slide. I think it's really incredible to me. We haven't soft landed something on the moon since like 1972, and just in the next 3-ish years or so, look at what we are going to be able to accomplish because of the CLIPS program. It's really pretty amazing, and I think we saw the talks earlier this week from the PRISM payloads, and I think that really starts to show the capabilities of this and what we can really do with CLIPS as we move forward and they become more capable, and we figure out how to use this program. Just a couple of quick comments on the SSERVI senior review. Most of you know that we are going through a senior review. It's the first time that SSERVI has done that in their history. So it's been a while. It's a good time to take stock of what we're doing and how we could do it better. Thank you all I know many of the teams have contributed lots of time and effort into this, getting documents to the panel. That panel will meet in late August. The report is due before Thanksgiving. And we are working on communicating with the decadal to make sure that at least they're getting the high-level findings on the timeline that they need them. And of course, those results will then feed into CAN 4. So we're hoping for a bigger and better CAN 4. Some updates on the Lunar Surface Science Workshop schedule, and this has been flashing in between, so hopefully you've seen it a few times this week. But just to look again at what we have done, I think these have been, for me, a really great way to stay connected with the community over the last year. Jake and I have really used the information that we have collected in a lot of these discussions in order to sort of build forward as we are planning for Artemis. We recently updated the website, so and most of the reports from the previous sessions, I think all of them are up there now. So please go and take a look at them if you are interested in those topics. We did take a break over the summer. I think we all kind of needed that, but we've got some sessions coming up soon. We've got one in August, the physical sciences with our BPS colleagues, and then a couple new ones. We are planning one in September, looking at science with robotic arms. And that will be sort of a two-part thing where we'll give you some information on the 9th and ask you to go off and think about it, and we'll come back on the 30th for a second discussion. And then in November, we'd like to talk about future CLIPS landing sites. As we figure out how CLIPS works and what the capabilities are and what they could be, we do want to hear from the community about where you would like to go and what you would like to do with these opportunities. And we're also working with heliophysics to get a heliophysics focused one together. That keeps moving around. I think it's likely to be in the fall, but it may get bumped. I'm not quite sure. So keep your eye out for that. We will be sure to let you know. Upcoming calls. I know this is what you're all looking for. I know you all want to participate. We are happy to have you participate. And these are some of our opportunities. SSERVI CAN 4, I think that's probably the one this crowd is most interested in. We are working to release that draft can. Like, as I said, early next year, we want to be able to incorporate the results from that senior review into it. The final can will then be released in the spring, and then proposals due 90 days after that. That is the timeline that we are looking at. Prism 2, that draft is out now. We do expect the final to come out hopefully next month. And the locations for those next two CLIPS landers have been announced, right? That is the South Pole and the Gruithuisen Dome. So some exciting science that we can accomplish there. Let's see, LDAP 21. I wanted to point this out mostly because LDAP is going dual anonymous this year. And so even though December 1st seems like it's a long way away, it may take you a little extra time to get your proposals together to make sure that they are in the proper format for dual anonymous. So just a heads up. Please pay attention to that and don't get caught off guard. And then the Viper COI call, we got step 1s in. If you didn't get your step 1 in, I'm sorry, they were mandatory. It's too late now. But we got a great response for the Viper COI call. I'm really happy to see how excited the community is about that. Looking forward to getting those COIs on board and joining the team. We're still considering a participating scientist program for PRISM. Decision hasn't been made yet, but we do like to do participating scientist programs where they are appropriate to sort of expand our pool of scientists involved in missions. And we think that, by the time these PRISM payloads are sort of real meaty science, and it may be time to start spin up a participating scientist program for that, but we are still debating, so no promises on that yet. And then, of course, the Artemis science team and instrument calls for Artemis. I know that this is something that everybody is excited about and interested in. We don't yet have a timeline for that, but believe me when I tell you, we are working hard to get there. Speaking of Artemis, the Artemis Science Definition Report is out now. It's available. As I said, we're working on planning for commuted science teams. We got some great input in February from the LSSW. We've gotten some great input from the ANCSA folks and from the discussions we've had this week. We are getting a lot of really good input about how to do that and how to put that together, which we are all taking in and working on. In the interim, thanks. In the interim, we've found that we need a sort of more rapid response team to make sure that we are addressing the questions from across the Artemis planning, the engineers. Just to make sure that the architecture that we're building is actually going to be capable of doing the science that we want to do. So in response to that, we've put together what we're calling the Contamination and Research Integrity Rapid Response Team, or CARI. This is a slide. This is something I announced at the LSSW, but for those who didn't see it, I just wanted to mention it again, that we've put together this team and they are awesome and working hard to make sure that when the engineers have questions that need science input, that they are getting the science input they need. So really appreciate all of the work that those guys are putting in. The science team itself. So as I said, we are working on this. We are trying to think about how to go about doing it. We're thinking about this in sort of 2 phases. So there'll be this initial sortie phase, very similar to Apollo, short duration standalone, and then a base camp build up where you're going back to the same place repeatedly. And that's a different way of thinking about things. And setting that aside for now, as we think about the sortie phase, we do expect to have a call for hardware based on what was in that SDT report. No timeline yet for that call, but we are working on it. And then for the geologists, for the science backroom, or whatever you want to refer to them as, we also expect to have a call. We'll probably have a call for a team, a small core team. That will be supplemented by some NASA internal folks, as well as a participating scientist program as we get closer to launch. And so that's sort of the way that we are thinking about putting that team together. And I just wanted, I know I'm about out of time here, and I just wanted to like throw in this last slide. I know we've talked a lot about the moon today and all week, honestly, but it's a great time to be a small body scientist too. And I know SSERVI covers the small bodies as well. And I just wanted to remind everybody that we've got a lot going on out there as well between OSIRIS-REx, Lucy and DART launching this year, Psyche getting ready for launch next year, MMX, NEO Surveyor. There's a lot happening in that world too, and I didn't want you guys to feel left out. And that's it. I'm gonna stop there.
Well, thank you. Excellent. We would have time for a question or two, maybe. If there's anyone, just write it in the chat.
Or feel free to raise your hand in Zoom. Okay, well, it seems you guys have, oh, here we go. Claudia, do you want to read Parvati's question?
Oh yeah. Do SEO, HEO have plans on how they will interfere with mission equity, recent RFI, e.g. a themed SSW? Sorry.
Interface, not interface.
Interface, yeah. Interface with
Oh,
the
I'm
mission
so
equity.
sorry.
That's okay, no worries. The recent RFI.
We haven't talked about that, but a themed LSSW is not a bad idea. We might take that back to the group and think about it.
Okay. And lots of thanks. So I guess we'll move on. Go ahead, Claudia.
All right.
Thanks, Sarah.
Well, thank you. Right, when we move on, our next speaker is going to be Julie Robinson. And Julie is the Manager of Science, Technology and Utilization Office within the NASA HEOMD System Integration Organization. And she's going to talk to us about the Artemis and HEO. So please feel free to share your screen. And we can see it. But we do not hear
Julie,
you.
we're not hearing you, although I do see your microphone is unmuted. We're still not hearing you. You might want to check the microphone is selected within Zoom by clicking on the pop-up icon next to your microphone at the bottom and reselecting your microphone.
Did she log out or just stop sharing, Ricky?
I still see her, well, she might be rejoining.
Okay, we'll just give it 1 minute, and if we have to, we'll, Masaki, while we wait, are you available to jump in if we have some technical challenges?
Yes, I can do that.
Okay, thank you. Stand by, please.
Yes.
Okay, do you see her, Ricky? Because if not, I think we'll just go ahead and move on and then catch her after
Okay, yeah, I
Masaki.
do not see her rejoining yet.
Okay,
Okay.
then I,
Okay.
Oh, wait. I
all
do see
right,
her
well
back.
then, you what? Sorry, Ricky?
I do see her again. Julie,
Okay,
can
here she
we
goes.
give you an audio check again? We see your slides, but I still do not hear any audio coming from you.
All right, Julie, Masaki's available to go. How about we jump to him and you and Ricky work out the microphone issue over the next.
Julie, I'll send you a telephone.
The ISAS organization within JAXA. And so, oh, he's showing us a very cool video. Masaki, please go ahead and thank you for being here so late in Japan.
Well, my pleasure. Thank you. So including the subsurface material that was excavated by this impact experiment and sampled during this second touchdown, HAVS-2 has brought the samples back from Ryugu, and the landing spot was in Australia. So this is where the capsule landed, and we, the team, went all the way to this place so that we can recover the capsule under the COVID-19 pandemic. And it wasn't just the COVID-19, but it was also the weather. The weather, it was heavy rain until the noon the day before, and then the sky cleared up, but still gusty wind. And then every condition turned out to be rather favorable. And that's why we got this very nice movie of the fireball created by the capsule. If you were, and you would have watched this if you were standing in Cooper Pedy, 400 kilometers north of the landing site. So we spotted this fireball, and we got the beacon. We received the beacon signal from the capsule and managed to localize the landing spot. So we picked up the capsule, brought it back to Japan, and when we opened the capsule, we confirmed that it was a big catch. The total amount of samples from Ryugu was 5.4 grams, which is 50 times the minimal requirement. And the creation activity is going on rather smoothly. We've done the initial creation already. And now we are in the initial analysis phase. And starting next summer, the samples will be available for the international communities. And also the comparative sample analysis study with NASA OSIRIS-REx is really something we are looking forward to. Well, Hayabusa 2 has been really successful, and it's a really popular mission among the journalists. And one of the questions we quite often receive is, why don't you fly Hayabusa 3? And our answer is, of course, yes, we are preparing MMX Phobos sample return mission. And actually, we are really moving full steam towards the launch in 2024, and the sample will be returned in 2029. We are getting a big support from the government. So I think we're really getting, running towards the launch in 2024. In MMX, we will be landing on the surface of Phobos for like a few hours. And during that landing interval, we will operate our samplers. One is the core sampler, C sampler from JAXA, that will get the sample from subsurface. And the other sampler is coming from US. It's a pneumatic sampler, which collects the sample from the surface. So by having these two sampling mechanism with a different way of working, we'll make sure that we get some samples from Phobos for sure, because that's what we really care about. DLR and CNES has provided mascot for Hayabusa 2 mission. And now for MMX, CNES and DLR will be providing this nice rover so that we can have a nice reconnaissance mission first, and then we can select the landing site, the best landing site on Phobos, hopefully. So this MMX is really a full-scale international collaboration. So MMX, it's a round trip to Mars, and we'll be landing on and sampling from the surface of Phobos. That possibly includes samples from Mars, because impact event on ancient Mars could have brought samples to the surface of Phobos. So MMX has a flavor of Mars exploration as well. So now I talked about JAXA's, the first step of JAXA's Mars exploration. What about lunar exploration? Well, recently there has been some interesting move within our system. So that's something I want to share with you. In Japan, we realized that a variety of interesting future activities on the lunar surface. But then a question that was raised by one of the committee members was that, who will pave the path? Another solution would be CLIPS, as we have just heard from the previous presentation. But the JAXA solution was a bit different. It wasn't our proposal, but JAXA was requested by a governmental level committee to set up a program that will produce top-class science results from activities on the lunar surface. And by doing so, we are asked to pave the path so that future activities will have a smoother way of moving forward. So this program that will go for the top-class science result will continue to 2030s. A precursor phase until 2030 is expected, and the main phase that will be developed in 2030s. We can assume of involving a pressurized manned rover that JAXA and Toyota are developing now. Well, it sounds like a good opportunity, but there are two sort of constraints, or two expectations on us. It has to be a top-class science that we produce. Well, I think that's fair enough. And the program also has to pave the path so that a variety of those people who are interested in lunar activities will be able to participate in the fully fledged lunar surface activity beyond this program. So it's a heavy expectation, but on the other hand, it's giving us a nice opportunity for science. And besides, we have no choice. We have to say no anyway. So that's where we are now. And this is really a recent movement happening in this country. So then what are those big topics that will produce top-class science by having activities on the lunar surface? We have picked up 3 topics. First one is the low-frequency radio telescope on the far side, and that will probe into the dark age of the universe when the first star was not born yet. And the second theme is returning samples from the key impact craters so that we can date the early history of the solar system. And by doing so, we can learn how dynamically our solar system formed and what was the heavy lake bombardment was like. And the third theme is the lunar seismometer network. By having this network, we can learn about the internal structure of the moon and learn about the initial evolution phase of a rocky planet. So it's not clear yet whether we can really pursue all of these 3 themes. It could be just one of them, it could be 2 of them, it could be all of them. So everything is just ramping up now, and scientists are excited, but feeling the pressure at the same time. But I think, again, that's fair enough. And yeah, again, this isn't something we proposed. This is really coming from above. And yeah, we have to live up to the expectation. So that's where we are now in terms of JAXA lunar exploration. That's all I have to say. Thank you.
Thank you very much. That's quite a comprehensive program that you guys have been working on and are expanding to. For your lunar science program that is very new, so maybe you don't have an answer to this, but I understand that the program will go for the next, say, 9 or 10 years, but do you have any idea how long it will take to stand up and start making opportunities available for your community?
Well, it's really starting now, but it's something I didn't touch on today is that we have a project by the name SLIM. That's a small scale pinpoint landing project. And I think it's almost mandatory that we should think about how to utilize that technology we are gaining from the SLIM project. So the next 10 years will be like having small pinpoint lander on the surface. That will be the precursor to the full-scale exploration in 2030s. So eventually we will come up with the concrete pictures of what those precursor missions will be. And then I think there will be opportunities for international collaboration. And besides, if you look at these 3 themes, it's something that almost everybody will think about. And I'll be shocked if there is no international collaboration when we perform the full-scale mission in 2030s.
That's wonderful. Okay, so we're open to additional questions for Masaki. If anyone wants to raise their hand or put a question in the Q&A, we'll give it just 1 second. We have something from Mahesh Anand. It says, not quite a question, but a comment to just congratulate JAXA for such a bold approach. So.
Well, again, it's coming down from above for the lunar part. So yeah, we'll see if we can, make up to the expectation. Yeah, thank you. Thank you for the encouragement.
Okay, any other comments or questions? Okay, well,
thank you.
Thank you very much. And if you could just monitor the chat, sometimes questions come in a moment or 2 after. And then Ricky, I'll check with you. Are we set with Julie?
I'm going to test. Can you hear me this time?
We can.
Okay, wonderful. Let me share my screen.
Okay.
Sorry about that. You do this hundreds of times a day, and then you never know exactly what is going to go wrong.
It happens to us all the time, but thank you for working it out and being back with us.
And can you see the charts now?
We can. They're in kind of the working mode, not the presentation mode.
Okay, let me see if I can get that changed.
And we lost the screen share.
And now do you see it?
We do not.
No, the screen share stopped.
Try
Okay.
sharing again.
Let me try that again. I can't win today.
You know, we can always just do it in this format. We can see this format. So if it's just not going to presenter mode, I would say you could close that format back. Yep. And just go for it.
That's okay to work with that way?
Yeah.
Okay.
It's very nice and visible. It's
As long as it's visible, we'll go with that then. Sorry about that, everyone. I have no idea why this has changed. So I'm really pleased to give you a little bit of an overview and really to tell you about how HEO is connecting to everything that Sarah talked to you about. And in terms of the way that we're coordinating our two mission directorates to work together on Artemis human missions. And so, you know, just a quick recap of where we're headed for our early missions. You know, we've got LRO data coming in, helping us plan those human missions. Artemis 1 will be the first spacecraft to the lunar vicinity in the 21st century. Artemis 2 will be the first crewed mission to orbit in the 21st century and with a rendezvous in deep space. Then we'll start having the gateway elements going into orbit with the launch of the power and propulsion element and the HALO, the habitation and logistics outpost. And then you'll start seeing our early deep space missions coming in, Artemis 3 through 5 being crewed missions with cislunar buildup and the initial crew demonstration. On the surface of the moon, you see those early South Pole robotic landings, Viper coming in and giving us really incredible data for helping with our plans, the uncrewed HLS demonstration mission, and then the first crewed landing. Over the longer term, we'll shift, as you heard Sarah say, from a set of sortie missions as we start being able to construct and build infrastructure to a base camp mode. And that is really a 3-mission directorate cooperative effect or effort with long-term surface access that's enabled by gateway and enabled by an infrastructure on the surface to allow extended duration studies and uncrewed activities. So the idea is not that we explore the moon only when the crew's there, but that we have a sustained and extensive exploration program on the surface of the moon. So what we're doing in HEO to set up that possibility is, first of all, we needed to construct an organization to interface with SEO, with SMD, as we put all of these plans together, because we need really close coordination between the architecture and the science objectives. And so about a year and a half ago, I was asked to stand up an office. We call it Science and Technology Utilization. And our objective is not to do the science and technology utilization, but to integrate the science and technology goals from the other mission directorates, from SMD and STMD, and our international partners, and develop that into a set of HEO utilization goals, objectives, and requirements for Artemis missions so that we can successfully conduct these human missions. We're also responsible for the cross-platform research strategy to prepare for human missions to Mars, meaning how we're using ISS, how we'll use commercial LEO, how we'll use Artemis in a way that is gradually advancing our overall human exploration capability. And what that office looks like, it's a very small group, and we are literally speaking with Sarah probably every day. It's myself as the acting manager. Jake Bleacher, who I know you all know well, continues as our chief exploration scientist. We have an STMD integration lead. Dion Hernandez-Lugo is just stepping into that position for a rotation. Betty Siegel, some of you know, and Mike Wade is our human systems integrator. We also have a multi-center support team that's helping do the early analyses that we need to do that understand the moon and understand curation and all of those different things so that we can be sure we're providing the right requirements input into the engineering requirements. as part of our multi-directorate responsibility, we also now have the responsibility for the HEO contributions and interactions on SSERVI. So Greg and Christina and our office are working together very closely. And we also have the coordination with the Office of Planetary Protection, which we also do jointly with our SMD and STMD colleagues. One of the most important things we've done over the last 6 months is set up a working group that can help us bring the really large engineering organization that it takes in HEO to prepare to do these missions and to build the kind of hardware that we're talking about, and bring those programs together with our science and utilization colleagues, both in SMD, STMD, and even in HEOMD, where we have things like the Human Research Program. So we set that up in something we call the USIG, the Utilization Coordination and Integration Group. And HEO's using a systems engineering enterprise level strategy. So our office is working at the mission directorate level, not at the division level. And so we have all of those implementing divisions involved so that we can really put together the best possible plans. Now, what we do is we take the science inputs that come from SMD, we take the technology inputs that come from STMD, and we integrate those together into a set of requirements that HEO believes it can meet. And so this is just a reminder that, this is the chart that SMD has shown in the past. Just a reminder that we don't write new science objectives. You shouldn't be looking for calls from HEOMD. Those calls are going to come from SMD. And then they'll be passed to us and they'll trace to the community document. So we're doing a lot of work with the Artemis 3 SDT report, for example, and figuring out which of those components need to belong in which HEO documents and requirements along the way. Another thing that we're doing is working to define the long-term capabilities that are needed across the lunar architecture, especially as we head towards that base camp. And I wanted to give you a little insight into some of those things that we're working on together with our SMD colleagues. So model traverse approaches, the end-to-end sampling strategy, the integrated planetary protection strategy, not to protect the moon, but to make sure we're doing the forward work we would need for future human missions to Mars and using Artemis as a test bed for that. Extended missions also as test beds for Mars. So rather than just doing short missions on the moon forever, actually planning to do missions that have durations and modalities that look a lot like that first crewed mission to Mars. That's an important utilization need for Artemis at the longer term, not in the near term. Integrated crew research approaches, robotic utilization of HEO assets, the integrated instrumentation strategy, and PSR operations. Those were sort of our top 8 list of the most urgent integrated capabilities that we needed to define. And just to sort of give you just a quick window into those, as we work on model traverse approaches, we're looking at all the different elements that may be in the architecture and how do we define the right requirements for those, from suits to the LTV to future pressurized rovers. What are the requirements we need so those can work together and provide the best possible access to the places that scientists are interested in going? And of course, we use the community documents and we work with our SMD colleagues on defining those places and then figuring out how those would work in the missions and the capabilities over the long term. Similarly, Sarah mentioned the carry team providing inputs to us. What we need to do on the HEO side is figure out something incredibly challenging, which is how to take a sample that's frozen and from a PSR and get it back home. And that requires leveraging across multiple programs, multiple locations. That's a pretty complex integration activity that HEO has to do. And so we're working together on those concept of operations, on those requirements, and then on what would need to be built in order to enable that. That's something that's very challenging that we're working on very hard because we know how important being able to actually see those volatiles with laboratory facilities on Earth intact as close to as possible to the way that they were on the moon, how important of a scientific contribution that would be. And we're looking in great detail at the robotic science use cases for HEO assets. So the vision in HEO is that not only is the pressurized rover transportation for the week when the crew is on the surface in these early missions, but that also we would be able to use these assets during the rest of the year, at least during the seasons when there's good light available to keep things charged up. And so things that you've heard about, like the robotic arm studies that are going on, are and the LSSW workshop that we're talking about having are to help us define these kinds of requirements so that LTV, when we go out and get ready to start having that designed and procured and competed, that it will have the right interface points so that a future science arm could be attached to that and do something outstanding. So just to kind of summarize what I talked about quite briefly, we're really standing up from scratch a great way to work together for many decades of lunar exploration and sustained lunar activities. So the first thing we had to do was kind of set up these HEOMD, SMD coordination processes. We're just standing up a number of those, and they include things like the USEG I talked about, even the federated board, which has the DAAs from the 3 mission directorates meeting every week to be sure that they're in sync on the different things that are happening in the strategy and the architecture. Then the next thing we're working on is this HEO 006 utilization plan with our strategic utilization goals and objectives and the utilization capabilities. We're trying to get that baseline by the end of September. So we've been working very hard to get the first draft of that out and reviewed by the HEO community and the SMD community as an interpreter of the different community documents that they're working from. We're also starting international utilization discussions. In the same way, HEO will not be leading the science discussions. The disciplines and the experts that you work with all along will be leading those science discussions, but HEO will be coordinating them with the contributions to the human spaceflight architecture that you also hear our partners talking about, so that we're sure that we have utilization and the development of the system and the architecture and the crewed missions all synchronized together between our agencies. We have a draft out now of the utilization requirements for the first crewed landing based on the Artemis 3 SDT and on SMD's need to select the science in the future. So they will be selecting that final science, but we framed out the overall capabilities that they'll be able to use. And we're making sure that all 3 mission directorates agree on the overall strategic plan for utilization that we're putting in place. Then our forward work into next year is to make sure we've got good phasing of all these utilization capabilities and that we've got an overall agreement on that plan that can be flexible as, of course, missions will change, timelines will change, and so that we can really move toward a sustained planning and collaboration approach for utilization of the moon. So I'm happy to take any questions that you have.
Thank you,
Thank
Julie. Go ahead, Claudia. Sorry.
Yes, thank you. That was excellent. We have now time for some questions if you want to raise your hand or write some in the chat.
Oh,
there's
yep.
Clive Neal.
Clive's got his hand up.
Yes.
Yeah, hi Julie. I came in late and I apologize for that, but that's a story of my life these days. Just a quick, you last couple of slides there, the term sustained came up. Can you give me your definition of sustained? Because I think my definition and yours may be different, and
yeah,
it leads to different expectations.
There are a lot of definitions of sustained out there. And I'm not going to say my personal definition is the official definition. I think the agency has been having conversations and has not settled on a definition of that. But in principle, for me as a scientist and as someone who's trying to enable science, the goal is to make sure that all of the utilization architecture and the human architecture contribute to the scientific exploration goals, and that it's not a one-off. It's not a mission here, a mission there, uncoordinated, but there's actually a long-term strategy. There's a buildup of capability, and that we keep providing access to new sites and are able to respond to discoveries and then do a full exploration over a period of decades. So
Excellent.
That's my personal definition.
Excellent. I hope that's the official one too. So I really like that one. So.
I'll try.
No pressure. Thank you.
All right. Well, we can watch the chat for just a few minutes, Julie, if you wouldn't mind, to see if any other questions come in, but we're kind of right on time. So I'd like to thank Claudia. I know we had a little bit of shifting during the session. I'd like to thank Julie for persevering and getting her system connected, but also James, Masaki, and Sarah. This is really informative. And please do ask questions in the chat or reach out to our various leadership in the various agencies directly if you would like. So with that, I will hand the baton over to Greg, who will take the next talk.
Great. Thanks, Christina. And thank you and Claudia both for your leadership at the last session, and to all of our speakers for the great perspectives. What an exciting time we're in. Isn't that the case? I have the pleasure right now of introducing Dr. Dave Draper. Dave is the Deputy Chief Scientist for NASA. He has a doctorate from the University of Oregon. I will note that we have we're very lucky, our community, to have a bona fide lunar scientist at his level in the agency. We've worked together for years, and getting that kind of representation is fantastic. He previously served as head of astromaterials at Johnson Space Center. And today he's going to address an issue that we spoke of at the SSERVI Executive Committee a month or so ago that I think that we all need to pay attention to for the future health of our field on predatory publishing. And I want to say at the outset that SSERVI plans to take a leading role in helping Dave find solutions to this problem. So Dave, please take it away.
All right. Thanks so much, Greg, for the introduction. Can you hear me?
Yes, I can.
Okay. Now we will try my very first screen share in Zoom. So here we go. Window, Chrome tab. No, it's not there. Okay. Let's see here.
Dave,
I'm
I can
sorry.
bring a presentation up if you need it.
Yeah, I think, Ricky, I think that might be the way to go because I don't want to burn time here. I think I'm going to come in under my 15 to leave a little time for Q&A, but if you wouldn't mind, because I'm struggling. I'm sorry.
Thanks, Ricky.
Thank you so much. All right, excellent. And it's a little bit expanded. There we go. All right, good enough. That'll do. Okay, very good. Thank you, sir. Let's go ahead and go to the next one. So first, thank you again, Greg, for that fine introduction, and thank you all for also for the invitation to come talk about this really important issue today. And that is one that I think many of us are familiar with, and we've probably all gotten emails like the ones I've got on the screen here. If you're like me, you get a couple of them a week. Some of them are just so obviously bogus. Take this one in the upper left here. Not only is it kind of crazy sounding, but I mean, they got these funky characters instead in the font. I mean, the P's and the B's look weird. It just looks like classic spam. In the upper right, it's a little more legit looking, but still obviously not really legit because they're saying, hey, you send me something, I'm going to publish it. Just please pay me $2,000. Now, the one on the bottom looks a little more real. I mean, it name checks a bunch of, actual sciences here, biology and medical science and so forth. Problem is, this email was received by a planetary scientist who has zero background in this area. Next, please. Now, I think many of us, when we get these things, we might roll our eyes, throw it in the recycle bin and have done with it. But I'm here to tell you that this problem is way worse than we think. And it is something that we as a community must get our hands on, and not just the planetary science community or this NASA family of sciences, but all of science as a frankly, a global enterprise. Now, I know many people have been thinking about this for a while, and you're probably familiar with a couple of lists that have been kept over the years of journals that engage in some of these practices. But there are many problems with lists, not the least of which is that they are obsolete as soon as you pick your pen up off the paper. Now, a couple of years ago, a group of scientists got together and hammered out a consensus definition and listed some features of predatory journals. And it's our position at the Office of the Chief Scientist that we all adopt this approach rather than try to keep a list. And I'm just going to read this out here. These are the features. Predatory journals and publishers are entities that prioritize self-interest at the expense of scholarship, characterized by false or misleading information, deviation from best editorial and publication practices, lack of transparency, and the use of aggressive and indiscriminate solicitation practices. Next, please. This is a handy thing we can always just keep in our back pocket, and we don't need to worry about, is it on a list? We can just apply that definition, ask ourselves, what do we think about this particular journal? In the next couple of slides, I'm going to share a few charts from a presentation that I saw a couple of months ago now, put on by the Government University Industry Research Roundtable, GWIR, by a group known as the Inter-Academy Partnership, nonprofit group. And they are in the middle of a study right now, and they were reporting out on what they had learned thus far. At the time of their presentation, they'd had over 1,800 responses worldwide to their survey. It was designed to try to get people to be forthcoming. Next, please. And there's some very disturbing things that came out of this. First of all, at least 25% of the respondents admitted to either having published in one of these journals or somehow participated in this stuff. And this is the big thing. This is no longer a case of maybe a gullible scientist, becoming fooled, being taken in by some ruse. Unfortunately, we have moved into a phase where scientists are knowingly going to these predatory journals. And here are some quotations that came from some of this stuff. You got to publish to stay in the race, publish or perish. Oh, I feel guilty to send my students' paper to this, but they got to get it out. I need stuff for my CV. Boy, the lead author on my paper is friends with someone who's an editor of one of these journals. It must be okay. This is a dangerous and slippery slope that we're already sliding down in a big way. Next, please. A number of conclusions here. This is really permeating all of our global communities. It's becoming difficult to distinguish between, unethical practices. These guys are really good at making it look fuzzy. As is always the case, the bad guys are always a couple steps in front of the good guys. The thing I've got boxed here is the main thing we can do, and why I'm here today, is to raise awareness of this problem and get everybody to understand just how bad the situation is so that we can guard against it. Next, please. A couple of the root causes here. I mentioned one before, publish or perish. This is a metric that is used in academia and also in non-academic science circles. Another issue is one we've all known about for a while, and that is that the business of science publication is a business. It is for profit. And of course, these predatory journals, that's all they want. They just want our money. They don't care about anything else. So this is why we got to get this problem fixed. I mean, unfortunately, these predators are going to go off and prey on some other group to try to get their money. I'm sorry for those people, but we got to get our own situation in hand right now today. Next, please. But wait, there's more. It's not just the predatory journals. This is something that just came out a couple of weeks ago in Science. This is another study now on science practices sort of writ large. And this is another study that was designed very overtly to maximize anonymity, again, to try to encourage candor in the responses. And what they found from this study of Dutch scientists is that half of them, more than half, admitted to regularly engaging in questionable research practices, hiding flaws in their research design, selectively citing literature and data. 1 in 12, 8%, admitted to outright fraud, making up data, falsifying results. It doesn't get any worse than that, folks, in our business, does it? Next, please. So this is our red alert. These emails aren't funny anymore. And this is the clarion call I'm trying to issue to everybody. We got to stop this. If this sort of thing metastasizes, we're going to see an explosion of the publication of spurious results, outright pseudoscience. And, someone's going to try to confer validity on these results. Behold, we got it published. This is a thing we dare not let happen. Now, if I had put this slide up a couple of years ago, especially with this big, bold bottom line point here, I'd be getting a lot of eye rolls. I don't think that's the case anymore because we have seen the consequences when as we've seen, credible science is not just disregarded, it's outright ridiculed and mocked. Policy that governments set must be based on rigor and integrity when it comes to scientific information and everything else for that matter. And because these people are in it to make money, right? Where's that money coming from? It is coming from our grants largely. Where are those grants coming from? They're coming from the governments that are trying to get science done. We don't want our government funding dollars to go into the hands of these predators. We are living in a time when for years now, the very notion of expertise, the very idea that there are experts in something like us in what we do is under assault. It's under sustained assault. And this is something that if it is left unchecked, we are going to see the kind of things we've been living with for the past year and a half. The credibility of all science is under threat here, not just our own community. If this undertakes irreparable damage of the type that could very easily occur, we're going to see more and larger problems of the type we've been living with, potentially deadly consequences. I want to draw the analogy to two things we're living through right now, the pandemic and the climate emergency. The numbers I've been telling you about today are like the case counts in the pandemic. They are the tip of the iceberg. We know that this is the bare minimum badness of how this is. It's only going to be worse than what the numbers show. The second thing is about climate change. We've been thinking about and modeling the onset of changes to our climate for quite some time. And we've been thinking about it as we got to make some moves so our future isn't so bad. But guess what? We all know now it's here today. Same thing here, folks. This is a giant problem. It's happening now. Next, please. And so here's what we're doing at NASA. At the Office of the Chief Scientist, we're of course going to work with our agency leadership, our center chief scientists and research integrity officers. We're going to make sure they're all aware and getting this information into their organizations. I myself, plus my colleague, Dr. O.J. Tucker from the Goddard Space Flight Center, are serving on the Science Integrity Fast Track Action Committee that was stood up by presidential memo on the 27th of January. We're approaching scientific societies. We're coming to major conferences like today to raise awareness. We're going to make sure our citizen science teams and projects are up to speed on this. We're going to be adding an element to our training that we do for NASA scientists on the responsible conduct of research, working with other agencies through our connections on OSTP and others, and working with the science publishers themselves. So we got to re-examine this model of how science publishing happens. We got to get the money out of the equation because that's what these predators are after. And so in our office, we've actually been talking to the Nature group of publishers for about a year on this. Next, please. And my last slide, this is my call to action. We urge you, use that Nature definition of predatory journals and conferences. Watch the webinar from which I brought those slides. There's the link right there. It's about a 35-minute presentation followed by some Q&A, and the full set of slides is on that website. Read that science article. It will turn your head. Link is there as well. And most importantly, talk to your colleagues, especially mentor your earlier career colleagues. This is not okay to do this. Educate your leadership who may not be scientists themselves. We have to be on guard for this. Bring it up at your all hands meetings any way you can, okay? And I'll leave you with this great quotation from the amazing science and science fiction writer Isaac Asimov. He said these words in 1980. There is a cult of ignorance in the United States, and there always has been. The strain of anti-intellectualism has been a constant thread winding its way through our political and cultural life, nurtured by the false notion that democracy means that my ignorance is just as good as your knowledge. Does this sound familiar at all? So help us all out, folks. Let's get on board with this and let's squash this problem flat today. Thanks very much for your time and attention.
Dave, thank you so much for highlighting this. This is a serious problem, and I can say on behalf of our community here, and certainly on behalf of SSERVI, that we want to help with this. It's going to be for everyone's good. I want to point out that it seems like certain parts of the community, such as young researchers, who might be particularly vulnerable to this with such motivations to publish or perish in their careers. This is indeed a cancer on science that we need to eliminate soon. So we don't have a lot of time for questions, but I do have one here from Nick Schmer. Dave, can NASA or other funding agencies not allow spending of federal grant dollars on enlisted or known predatory journals? Just like you can't use grant money for a range of dubious reasons. I imagine the issue would be enforcement, but it would be a start, ?
Yeah, that's a great question, Nick. And one of the problematic things about lists that I obliquely referred to when I had that slide up is there are also legal issues that come up with lists. And there was a well-known one, a gentleman named Beal's list. You could Google that up. It was one of the first lists that someone tried to maintain, coming up on a decade ago now, maybe. And these folks took him to court. They ate him up with legal fees, and he eventually stood down and walked away from it because he couldn't afford it. So the government needs to be careful about what they do to not leave ourselves open to any kind of liability like that, which is why we really like this idea of using a definition instead of a list, because then no one's name is on some list. It's just everybody's judgment to apply these reasonable definitions and answer that question. I know we're out of time. There's a bunch of questions in chat. I'll get busy in there and start typing up some answers so that the program can continue on schedule.
Excellent, excellent. Thank you so much for calling our attention to this, Dave. Really appreciate it. So I'd like to turn the baton back over to Christina now for the Student Poster Awards. Christina,
thank you
please.
very much. I will start with a question to Ricky. Are you going to share, or would you prefer I do it?
I'll bring it right up.
Okay, thank you. Well, I will get started. Before I do, I have an announcement that I forgot to make, but I'll make it now. At the top of the hour, in whatever time zone you are in, 9 o'clock for Pacific time, Sarah Noble and Jake Bleacher, who works with Julie Robinson, she mentioned him in her presentation, they will be holding the final office hours for the meeting in the GatherTown conference room number 3. So please do make use of these times if you can, and or reach out to them individually. But this is a great opportunity for people to introduce themselves and ask questions and just talk about different programmatic elements. So thank you to all of our leadership in various groups that did hold office hours. We really do appreciate it, and you giving your time to make yourselves available. So now I have more thanks to give. First and number one is to the students that signed up for the poster competition. We had 32 students compete this year, which is fabulous. That is almost 3 times the number we had last year. So we are really excited about not only this competition, but the numbers of students that are able to participate in this conference and use this competition as a way to also gain exposure. So congratulations to everybody. There were some really amazing posters, and with competition like we had, we can only pick a subset, but when we do announce the winners, each winner will get a $1,000 travel award, and we will write to each winner and explain how they can use this funding and how we will work with them on the details later. Secondly, I would like to thank the judges. We needed more this year, and our teams stepped up and volunteered, and there might have been 1 or 2 people I had to volunteer for themselves, but I do thank everyone. It takes a little extra time, and without you, we couldn't have had such a great competition. So, Greg, did you want to do any of the award nominations?
Why don't you just go ahead, Christina?
Okay.
That's fine. Make it easy.
Okay.
Yeah.
Thanks. I'll do that then. Then we're going to go backwards, and we're going to start with 3rd place. When I announce your name, if you are on, could you please turn your camera on, and you're welcome to unmute for a moment. And then at the end, would all the winners please stay on? We'll grab a quick screen grab with a picture, and then we'll move on to transition to the sessions. So, okay, without further ado, Ricky, go ahead and introduce our third place winner. They're not advancing. Oh, there we go. Just a little delay. Oh. All right. Katerina Slavisinska, are you with us?
So I think she's in France at the moment, unfortunately.
Okay,
so.
No problem. Well, we congratulate her. I should add that the winners were all within a fraction of a point of each other. So really we had 4 top place winners, but we will write to Katerina and we will congratulate her. Okay, Ricky, if we can get to the next slide, if it'll move, we'll go ahead and introduce second place. Okay, Danny Waller from Johns Hopkins Applied Physics Laboratory. Danny, are you with us today? I see
Yes,
some
I am.
applause. Okay, well, wonderful. Congratulations on your poster, Investigation of Magnetic Fields Associated with Various Lunar Swirls Observed in the Far Ultraviolet.
Thank you so much.
You're welcome, and please stay on in just a moment. Okay, and so now what I need to tell you is we actually had a tie for first place. So we will just announce them in order of alphabet, no other order to be inferred. So Ricky, go ahead. All right, Ferris Almatok, are you with us? No. Oh, congratulations, Ferris, on your poster titled Utilizing Hexagonal Boron Nitride and Graphene Field Effect Transistors for Neutron Dosimetry. Thank you for being a part of this and congratulations.
Thank you.
You're welcome. Well done. Okay, and our final first, oh, I should say from the Georgia Institute of Technology, and go ahead. Ricky, we have Christopher Scholand. I'm sorry, the names this year are a little bit of a tongue twister for me, but with hybrid dust mitigation brush utilizing EDS and UV technologies, also from the Georgia Institute of Technology. Christopher?
Hi, thank you very much.
Wonderful. Well, congratulations. We're very excited. And as I said to our 3 award winners that are here, we will write to you. It might be next week, but I promise we'll get to you. It's been a long week. And we will let you know how to use the travel awards when we're all traveling again. So if I could get a big round of applause from everyone.
I'd like to add my congratulations to everyone as well. Fantastic job. We've been doing these poster awards now for what, 12 or 13 years. And some of the award winners are now in very prominent positions in the community. I would expect no less from all of you. And so huge congratulations. We're very, very proud of you. Thank you. And we'd like to do a group photo. If we could. Christina, are you still there? Or did you get, did you lose your internet perhaps? Uh-oh. I just got a message from her. She says she has the pinwheel of death, which which we've all experienced before. So anyway, let's see. We have Danny and Christopher and Ferris. Would you mind turning your camera on as well, if you could? Great. And Ricky, if you wouldn't mind, there we go. And was that it? I think on the on people who were here. I think so. Yeah. Okay. Yeah. Christina said she has to restart her computer. So why don't we go ahead and just get a picture like this, and we will we'll Photoshop her in. So,
Okay.
all right. All right.
So stand by on 3. 1, 2, 3. Perfect. Thank you.
Great, great. Huge congratulations to all of you. We're really proud of you, and we look forward to hearing more about your work at future forums and ELS meetings. So thanks so much for supporting this meeting and for doing your great posters, and congratulations. And like Christina said, we will be in touch with you, but please do use these awards. It's meant for for you getting out and experiencing more great science meetings. So congratulations. Okay, so we're just a little bit early now, and what I'd like to do is break, and the next sessions start at 8:35 Pacific time in about 10 minutes. So we'll look forward to seeing you then. Thanks so much.
Good morning, Jay.
Good morning.
We're so excited everyone's here. We're just getting all set up. So
kind of amazing. Let's see.
I just want to actually, does my timer look the right way or did I unmirror it?
No, it's definitely absolutely correct.
Perfect.
Yes.
I just want to make sure sometimes it's backwards. So I'm going to
let's count down to launch. It's very effective.
Well, yes, perfect. So for all of our speakers today, I'm going to stop the timer, but if you want to know where you are in your timing session, you'll see this bright green timer behind my head. And so it will help, and Jay will show you how it works during Jay's talk. But I just want to let everyone know you'll have your 10 minutes. So I'm going to figure out how to, like I said, get it to stop here in a second. And,
how it works.
To reset it, all you do is to reset it, you just stop your camera and start it again.
Oh, perfect. Well, then I will do that. Thank you. Oh, beautiful. Okay, so I'm going to leave my camera off while we introduce the session because we are here at 8:35 and we're so excited that we're here on Friday and everyone here is joining us for our session. My name is Sandlin Buxner. I'm at the Planetary Science Institute and I do a lot of work in education, public engagement, and outreach. Jay, would you like to introduce yourself?
Yes. Hello, I'm Jay Greer. I'm at the SSERVI TREX node at the Planetary Science Institute. I'm a lunar researcher, educator, outreach expert, and diversity and inclusion facilitator.
Wonderful. So we just want to let everyone know, again, we'll be introducing each of our speakers. Each person has about 8 minutes to do their formal presentation. We do have one pair near the end who have asked to do their presentations together. So we'll get to do those together. And after everyone has kind of 8 minutes to do their presentation, we'll take a couple questions. You are welcome to put questions in the chat, and we're asking, just like every other session, to put a Q in front of it so that we know it's a question and not just commenting or having a really great discussion. And either Jay or I will grab a question during that 2 minutes. And then we have a really nice time at the end that we can have for discussion. And so we'll grab more questions. Obviously, want to encourage lots of discussion. And so we do have some nice time at the end to be able to do that as well. I want to make sure before we get started here in a minute, if any of the speakers have any questions, we are asking if you're not speaking to keep your audio and video off. I'm going to leave my video on just so you can see the countdown, but I obviously will do that. But want to just give everyone 30 seconds to ask a question, either pop up or in the chat before we get started. And so just to make sure you're in the right place, we are the session Building Better Worlds, EDIA and Public Engagement. Okay, Greg, do you have anything before we get started?
No, I don't. I think you guys have it and are doing fabulous. So so thank you. All I can say is how much we support this great work, and I'm so glad that we're having a session focused on this.
Yeah, we're so excited too. So we're excited, and I'm so excited that my co-chair today is going to be our very first speaker. So I would like to introduce Jay Greer, talking about engaging key space exploration stakeholders in ethics, inclusion, and decolonization. So I'll get my timer going, and Jay's already started sharing the screen, so we should be good.
Thanks, Sandlin. Can you see the slides and can you see me? And is it all looking good? Do I sound good? Awesome. Got a nod from Sandlin. Okay. Thank you very much. It's great it's a huge honor to lead off this session. And it's also, again, a huge honor to be the chair of the SSERVI EDIA focus group. And I'm thrilled that this session exists, at the incredible support and participation in this session and throughout the week in EDIA issues. And another huge thanks to Greg, his team, and to everyone who's been involved in the focus group and in organizing this meeting for this incredible focus. I really appreciate it. And I think it's going to benefit our profession immensely, not to mention the whole world. Not that I want to change the world, but I do. And that's a little bit a part about what I'm talking about. In order to, obviously, we want to change some things in our profession. There's going to be a number of people in our audience right now who are experts at this far better than myself, as well as people who are new to these ideas. So part of what
I don't mean to interrupt you, but could you make your slides bigger so everyone can see?
Oh, sure.
Perfect. Thank you.
Thank you, Sandlin. Is that better?
Much better. Thank you.
Did that work? Okay, I apologize. I can't, anyway, thanks. Yeah, so some of what I'm talking about is to folks who already know what they're doing, and some of what I'm talking about is to folks who are going to be coming at this new. But what we all need to do is try to figure out how to have these conversations with anybody who would be identified as a key exploration stakeholder. And in a lot of ways, that's everyone, but in particular, the people who have the position, the power to make the kinds of decisions to have the change that we'd like to have. So let's see. I see I've got I love this countdown behind Sandlin. This is awesome. Okay, so presentation. What's all this then? In the style of Bill Botke there. What's all this then? As ethical scientists, our value structure intrinsically includes ideas of equity, inclusion, and diversity, because that's a lot of the ways that we do good science. The nature of how we process data, how we take data, how we attempt to get bias out of our data in the first place. And we, of course, have moral imperatives for compassion and just human interaction. This is a part of our mindsets. We need to build these things into our personal research and our work lives at small scales, as well as work to influence space policy at larger scales. And to do that, part of that is addressing stakeholders and how we go about doing that. So strategy 0 is just don't assume everybody understands how we're using the terms, right? Any of the terms that we use and we think are very basic in terms of doing EDIA are things that other people have encountered in other contexts, such as ethics, morals, or privilege. I had to look up these things when I was first starting to do, science ethics, because I had never taken an ethics course. So becoming, learning about ethics is finding the definition for ethics, which of course is defined with the word morals in it. And then you've got to look up morals in the way the dictionary works. Privilege is not an insult. It's a fact based on a position, the way society is currently structured. And a lot of people who are referred to as having privilege, the first time they hear this, they take it as an insult, instead of recognizing that the society has been structured to favor them and that this is just a fact. And that from privilege and from unconscious bias can grow acts of discrimination, which can build into systemic racism. And that is a sliding scale that we've seen much of. So how do we start to bring some of these values into our personal research lives? So the strategy number 1, and I apologize for my word heavy slides, but I actually need to see these today to keep myself on track. Shame and guilt are toxic and unproductive, so remove them from the discourse. Part of dealing with folks who have never, of course, grappled with some of these ideas before is, of course, a concept called white fragility, which absolutely exists, which is the first time that, in particular, white people, or perhaps it's people who are not disabled, or people who are cis or have heteronormative life, that they have not had to grapple with certain aspects of society or culture that in fact have been privileging them because they're privileged and haven't seen it. The point at which they realize that they have been participating in systems that have been hurting other people, of course they feel bad about it because they want to be nice people, they're good people, and they feel bad about it. But the fact is that is completely unproductive. And the amount of time that we, in particular, I'll say white people, we as white people spend in this guilt area or shame area, we're still centering ourselves, and we just have to stop that and move beyond that. So when you're having conversations with people, tell them to just shelve that. It's not going to go anywhere. And to take change, we have to decenter ourselves and look forward at the people who actually need to benefit from systemic change. So that's one thing to take off. So instead, challenge them to accept responsibility for what they are and are not going to do after they realize how their participation in systemic oppression has affected others. So the major barrier is that often the people in the best position to enact change, at least in the way we have things structured now, are the people who are least likely to see the need for it because the society has privileged them. And since they've always been the first ones in line, they don't, when things start to change to be equitable, they see that as things being taken away from them because they've never had to wait for their place in line before. Things haven't been fair. So everyone, and making people understand that this means everyone has equal opportunities, resources, and rights, and what that can look like. So strategy number 2 is simply responsibility, encouraging people to take responsibility for their own actions and requiring responsibility from the people who may be above them in terms of power structure or management structures. Strategy number 3 for our community is really learning. We're smart, we can research topics, and we can learn. And by research, I don't mean reinventing the wheel. What we need to do already exists. People have researched it, people have written it, particularly in terms of race, the Black community and other communities, the disabled community. They know what needs to change. It's out there. The research we need to do is just go get it, bring it in, put it in here, and then put it into action. So we can learn these things. These are entire fields of expertise unto themselves. So we should understand that just because, we're scientists doesn't mean that we, instantly know these things. It just pops into our head, kind of like, being born from the brain there. But other things we need to do is, learn best practices in science communication, learn who our representatives are, not just in terms of politically, but in terms of within our societies and structures, and who can advocate, who can't, who do we need to approach. And seek out any professional development. We always assume we have all the training that we need. We don't, get training, and encourage others to get that training as well. And in particular, so this is just a basic list of steps, and I've got less than 3 minutes. So just looking at some of the things we can do in our personal research environment, listening to the people, the marginalized groups in our subdiscipline who are in that environment, and boosting their voices up. Continually trying to decenter ourselves and put those people in the center. Another one is positioning ourselves as experts, and that can be hard when you're an early career person, but to the outside world, you are an absolute expert in astronomy and planetary science, and you know everything, and you can claim that and help the outside world. Engaging in conversations, join and initiate conversations yourself. Considering, the screen has turned red. Consider how algorithms, models, searches, and predictions are built on biased principles, how our very data collection itself is built on biased principles. And if you've used Google for any kind of searches in EDIA, you know how biased that is. Amplify voices of, as I said before, of people who've been overlooked, and hold our established institutions accountable. So I'm going to skip that slide and go to this one. So just people say, what do you mean when you say decolonization? And the answer is basically, I'm going to quote Lucianne Walkowitz on the bottom here, which is, I can't give you an example of what a decolonized Mars looks like, but it starts by having multidisciplinary conversations about the things that happen here on Earth. And the fact is that we don't exactly know what that looks like because we haven't brought the right people to the table to have those conversations. People are telling us, in particular, Indigenous communities are telling us what that is and what that looks like. Colonization has at its heart the idea that a planet belongs to us. And any changes, going there will make changes. Can we trust humanity to respect other worlds when we have not respected Earth? And so here are some particular policy basics, but I'm going to skip over these two, the list that I can certainly share with others about what that might look like. And I'm just going to skip straight to my end slide, which is me, so that if you can want to ask me further questions about some of this or the specific policy issues or where we're going, I would love to have these conversations, although there's half of the people on this list right now know more about this than I do. And I see one of the hands up, which is Veracis Fernandez, who I want to say immediately was part of, and I think actually an organizer, at the last ELS, what was it, 2 or 3 ELSs ago, in Manchester, had the Moon as a Contact Zone workshop. And I learned a ton there. So I wanted to call Vera out on that because it was fantastic. And 4, 3, 2, 1, I'm done.
Thank you, Jay. I do want to encourage people to put in comments and to put in questions in the chat. Just to stay on time, we are going to keep moving, but we're going to continue to get the questions. So Vera, we'll make sure to get the questions, and I will keep a list to make sure that we get there, but we'll stay on time and keep going. And so to this, I'm going to stop my video and introduce our next speaker, and then I'll start my video. And so our next speaker is Natalie Trevino. We'll be doing the inequity of the final frontier. So Natalie, if you want to share your screen.
Hello. I do not have any slides, so it's
Perfect.
just
Well, then
you're just going to see.
let me pin
my
you.
light.
Yeah, that'll be wonderful. Let me just pin you so that everyone will see you. Perfect. Okay. And I'll put my video back on and you'll see your timer. So again, I'll try and target 8 minutes, but we can do what Jay did too, and it'll be fun with lots of time for discussion at the end.
Yes. All right. Hello, everyone. My name is Dr. Natalie Trevino. I am a decolonial theorist who works on space exploration and looking at the ideas of what decolonization and the universe have in common. So I'm going to kind of dig right into, and it actually works well with our previous speaker. So what I'm going to be talking about is the epistemological aspects of colonization and the ways in which those things affect the thinking and the broader worldview that we have about life, the universe, and everything. So I have a bit of here to read, and if anyone has any questions about clarifying terms, raise your hand and just yell at me, because I know that some of these are very theory and philosophy based. So if you need clarification, just let me know. The celebratory narrative of the Western frontier is so pervasive, it needs no retelling. What is left out of the triumphant narrative is something called coloniality, that necessary yet invisible dark side, which underpins the rational, technological, and democratic achievements of the conquest of the Americas. The use of the frontier metaphor for space hides this darkness. It reduces the possibilities of the future to only those that can be profitable, not just in the future, but in the present. So then what is this dark structure called coloniality that exists along with the dazzling glow of the modern world? Along with Enlightenment values, of which the scientific method is part technological achievements and secular governments, there's genocide, epistemicide, which is the systematic murder of knowledge systems. So we can think of basically any non-Western, non-hegemonic knowledge system. The expansion of European patriarchal norms to the rest of the world, the development of racism and economically exploitative systems. Neither can exist in their current form without the other. We can't have NASA without having the concentration camps. Simply put, modernity is the emancipating will and genocidal violence, as scholar D'Souza Santos says. Modernity foregrounds European or North American social and cultural and economic norms and declares them as universal. This universalism assumes that all humans use and understand or should accept these norms. Governance is that of the nation state. Distribution of goods is only through the capitalist market, and rationality, including instrumental rationality, science and technologies, are the only ways to think about the world. We even see these in ethical practices, which often come from the European tradition. If this is modernity, then coloniality is the logic that allows for these things to manifest at the expense of the indigenous peoples of America, Africa, and Asia by destroying their socio-cultural, economic, and political forms and relations to themselves and to the earth. These genocidal practices were then absolutely necessary for the development of the current world system. I'm actually going to skip the next part. So what all of this is produces what I consider the cosmic order of coloniality, or the final frontier. This is a celebratory narrative of the American space program and everything that's been done in space since Sputnik. It is the American leadership in space. It is the use of colonial imagery while describing the future in space, while never actually considering the historical inaccuracies in which oftentimes those metaphors are based. When the American government began to plan its permanent space agency, a memo for the president's science advisor wrote, "The exploitation of any unknown area involves two distinct objectives. One is exploration, and we can see that as science, engineering, technology, and control, which is militarization, which we can know that has never really been that far off of space exploration." This was written by Paul S. Johnson in 1958, and this hasn't changed particularly much. The frontier as a site for exploitation is as old as the American nation state itself. the use of the metaphor impacts our understanding of what is possible and what is real. But as historian Patricia Limerick has warned, space enthusiasts have based their idea in the future of a flawed understanding of history. The American West was not all glory. There is no American frontier without genocide or epistemicide. And while many in the space sector cry, quote, "There are no Indians in outer space," the rationale fails to observe the current forms of violence within the space community, whether those are gendered, racialized, or something more cultural. We can think of the 30-meter telescope or industries that support space activities, such as the Amazon employees who have faced terrible working conditions, including recently reports of suicides and miscarriages. Space exploration is meant to benefit everyone, including those who are not directly in the field. Thus, the frontier metaphor is old. It invokes and sustains violence. What it should and can be retired. A new metaphor for the expansion of Earth-based entities into space needs a more expansive metaphor. One does not hide the violence, rather one that celebrates and includes the diversity of this planet, the diversity of peoples, ideas, ways of being and living, so that space is not a frontier for settlers looking for gold and land, but that we, the people of Earth, expect that there is no metaphor just yet for the migration, the expansion into space. That what will occur will be a new metaphor in search for different ways of relating to the universe, not based on coloniality, but rather by embracing the multitudes of ways Earth and its entities relates to the cosmos. So I see we have a bit of time left, and I actually prefer to have dialogue. So if people want to kind of jump in with questions.
Wonderful. We have a couple, and Jay's gonna do that, but we have a couple questions that have been coming in the chat as well. So
yeah, I'm taking a look and seeing, but I don't see one queued with a Q, but certainly one was people would love to get your slides at some point. So if you since you were reading,
I don't have slides. It's
yeah. Oh no,
my document.
Yes, so that they can they can reference for the future. So if you've got a link or something, they would love to have it. That's all. So let us know, or you can share that, or if not, you can always send that to SSERVI later, and we can try to connect that to things. So so I have a couple of questions myself, although Vera's got Vera has her hand up. So if Vera, if you would like to make a question out loud here now, please do so. Otherwise I'll jump in.
Okay. Well, it's for you. I still left my sorry, lower my hand. Sorry.
Yeah, go ahead. Table that for later, and we'll stay on the current speaker for now. So
yeah, I have written my comments already on the chat.
Yes, I got it. Thank you very much. So some of what you were talking about, right, is the fact that we have trying to visualize the futures in space. One of the things I've been looking at for visualizing a different future, right, is in science fiction in terms of Afro or African futurism, indigenous futures. Where else can people look to change their idea of what the future could look like?
Well, I think that's science fiction, and maybe I say this because I'm a nerd, and the Dune trailer just came out yesterday. So, we're all on the same wavelength with that. But really, it's a matter of looking beyond the curriculum, so to speak. Science fiction is a fantastic way of imagining a future, but it also reproduces socio and political norms of its day. We can see that when we look at Gerard O'Neill's use of the high frontier, when he's like imagining the future in space, and it's like, well, that's just the 70s America, like in space. I don't want to live on a suburb in the middle of nowhere in space. I don't want to live on a suburb in the middle of nowhere Earth. So what we need to be doing is then looking beyond the reproduction. And that is in Afrofuturism. It is in indigenous futures. It's in looking beyond what is in philosophy and theory, we would say the Western paradigm. It's if you're only reading white guys from Europe and the Americas, maybe you shouldn't. I mean, I love me some Frank Herbert, but his is, we can retire that. I would love to see indigenous science fiction on the big screen. That would be incredible. And I think it would bring so many more people into the conversation that are necessary.
I'm looking again. And so we have from Colby Merrill, do strategies exist to separate exploration from control?
Not yet. So I recently finished my doctoral dissertation, which is all about this. And that is the next bit of work that I hope to do, is figuring out what does exploration look like without the coloniality involved? And that's the hardest question. And that's where like no single mind can come up with it. This is the world building that everyone needs to be involved in.
Thank you. Okay, Sandlin, unless we've got a question for the last 10 seconds.
Well, and actually, Natalie, there's a comment in the chat, which I'll have you look at, and it starts, it says, in 1999, we published our first moon book, Moon Resources and Future Development and Colonization. We realized the connotation of colonization, and in the second edition, changed the term to settlement. Yes, we were all colonized, and the good thing in the conference our conference is being conducted and understood and interacted in a language that was taught to many of us around the globe by colonists, good or bad. So there's a question I'll have you kind of address in the chat if you don't mind. While we go on to the next speaker, I just want to make sure you saw that. So perfect. Thank you. Okay. I'm going to stop my screen again and introduce our next speaker, Dr. Abby Grace, New Zealand Maori and Aboriginal Australians learning from Indigenous contributions to astronomy and exploration. I will unpin Natalie and let Abby share her screen.
Hello, so I have slides and no video, so maybe between the two of us, we've got everything. So thank you for this opportunity to introduce and celebrate New Zealand Māori and Aboriginal Australian contributions to astronomy and space exploration. As is a traditional way to begin in Australia from where I'm speaking, I would like to honour the Indigenous custodians and traditional owners of the various lands from which we are gathering online and their elders past, present and emerging. I'm going to begin by quickly introducing New Zealand Māori and Aboriginal Australians. According to government statistics, there are currently around 800,000 Māori and the same number of Aboriginal Australians and Torres Strait Islanders in New Zealand and Australia. These countries are perhaps best thought of as sister countries, but the journeys of First Nations people of New Zealand and Australia is entirely separate and different. So it's more by convenience than association that I discuss both groups in one talk. The Māori people of Aotearoa, New Zealand enjoy solid political and social power with a long history of redress for early problems brought by white settlement. National language and cultural programs to honour and strengthen their place are directed by both Māori communities and national entities. Te Tiriti o Waitangi, the Treaty of Waitangi, assures absolute sovereignty of Māori people in New Zealand, and while that journey continues, it is normal to find Māori people in leadership and as subject matter experts across fields. As with many Indigenous cultures, New Zealand Māori once navigated by the stars and used them to predict weather and guide food production. Professor Rangi Matamua is a key academic in this area, who you can watch in the series Beyond Matariki. Two others are establishing a Māori astronomy school. New Zealand has its own Society of Māori Astronomy Research and Traditions called SMART. And Dr. Pauline Harris is another academic dedicated to revitalising Māori astronomy and star lore and helping ensure traditional astronomical knowledge is not lost. The Tauapasa South Māori Land Corporation is working closely with Rocket Lab New Zealand and Mahia to preserve the land and bring cultural values and blessing to the project. Rocket Lab is uniquely placed to send rockets over ocean instead of neighbouring countries, and they've been launching since 2017. So please keep New Zealand and Australia in your minds when thinking about potential collaborations and analogue work, as they're both gateways to desert terrains and Antarctica. Australia has a long history of cooperation with NASA. It's the place that broadcast the first steps on the moon, and it has a long history of deep space observation. Aboriginal Australians have been involved willingly and not, given that they are often custodians of remote land that's great for rocket tests. They identify themselves by the part of the country they belong to, their mob, and their language group. I'm going to come back to this slide shortly. But here's a map of Aboriginal Australian groups to demonstrate that they're not a singular people, but rather each group has its own culture, language, customs, and more. Despite there being hundreds of Aboriginal languages, some common cultural values include valuing and returning to country or the place and people of your origin, caring for your mob, and staying fierce or deadly, as it's called. Associate Professor Dwayne Hammetscher has published a lot of academic work on Aboriginal astronomy, and others like astrophysicists and science communicators Kirsten Banks and Carly Noon also promote Aboriginal perspectives, including the use of dark constellations, where dark areas of sky are used to define the constellation rather than the stars. The Square Kilometre Array in Western Australia is formally partnered with Aboriginal Australians who are the traditional owners of the land, which is a well-established practice in Australia. Commercially, the first satellite ground station owned and managed by First Nations Australians became operational last year, assisting with agriculture and bushfires through observation from space. And also in 2020, the Kaniba Community Aboriginal Corporation partnered with Southern Launch to host suborbital rocket launches. The Kaniba test range became Australia's first licensed launch facility for private use in March 2021. Southern Launch communicates continually with the group and is providing opportunities for community members to develop their expertise and career options, while the community provides local knowledge and cultural guides who are paid for their services in an exemplary reciprocal partnership. The last 2 years have seen a number of initiatives designed to bring public attention to traditional First Nations astronomy knowledge from this region. Both countries' space agency logos reflect Indigenous imagery. There's a link here that shows how Aboriginal constellations make up ESA's logo, including Kura the kangaroo, who last year was introduced by an astronaut on the ISS. Recent coin issues and IAU asteroid namings have honoured Aboriginal constellations, and First Nations individuals and groups with recognised astronomical knowledge, including Elder or Uncle Gilla Michael Anderson, who's pictured here. The New Zealand Prime Minister's Science Communications Prize also went to Professor Rangi Matamua for his work promoting Māori astronomy in 2020. And a new public holiday is beginning in 2022 in New Zealand, celebrating the rising of Matariki, or the Pleiades, that marks the beginning of the Māori New Year. I turned this image of the Earth on its side intentionally to remind us that we're hanging in space with no right way up. And similarly, there is no one right way to explore space and understand it. We do well to value those who hold unique expertise and to embrace and empower people who can provide new perspective on pursuits that represent all of humanity in space. We're planning to take stuff up to the moon very soon and to go in person as early as 2023. So we need to be hearing and valuing the voices of cultural groups who have been focused on sustainability for thousands of years right now. Connecting with Indigenous groups often means going to where they are, taking the time to build trust through relationship, and acknowledging that communal and oral knowledge isn't less true and actually could be more tested and tried than a new publication. People who speak the languages of both modern science and traditional cultural understanding are more, not less, qualified. Also remember that Indigenous children are often protected in the centre of the community, and outsiders should consider approaching their leaders and elders, not just assuming access to the child, particularly in Australia, where for decades lighter-skinned children were actually forcibly removed and became the stolen generations. Something you can learn more about from the film Rabbit Proof Fence, which is based on a true story of 3 young girls who walked 1,600 kilometres, about 1,000 miles, to get back home. This is bravery we can all learn from. I hope this talk has expanded your thinking and given you a good starting point for understanding and valuing the contributions of New Zealand Māori and Aboriginal Australians. In a climate of international cooperation and potentially competition for resources and territory, it's more important than ever that we honour and celebrate the Indigenous cultures of our home countries and beyond. To finish, I've just snuck these two images in, and I really hope they don't mind, as a visual reminder of our next generation of Aboriginal astrophysicists, such as Carly Noon and Kirsten Banks. So I just wanted to thank you for your attention and invite any questions.
Thanks, Abby. That was fantastic. I see there is a comment, I think, related to this one. It says, looking at, settlement and colonial languages, what is valued right now in space discourse and what isn't, and that's directly related to what you're talking about. How can space be made for alternatives? Where are the space dancers in the plans for moon bases? And I was thinking about that in terms of, we see all these great initiatives that seem to be including Indigenous thoughts and ideas, but how much of that is performative and how much of that is actually changing the way we are going into space and the way we're exploring?
Yeah, and I think those are the questions that we needed to be asking for a while and need to continue to ask. I think in a way that's where we're up to. We've done some really good work around connecting with people and honoring people and hearing what they're doing and researching what they're doing. But if we're not empowering them to actually tell us what they want us to know and to use their language and to give them the opportunity to take the lead and to do things their way, then we're missing out on that opportunity. And one thing I wanted to quickly mention is both cultures have fantastic welcoming ceremonies. And I would loathe to land on the moon and just be welcomed with a handshake and a cold drink. If I could emulate something that really is so much more ceremonial and honoring of the opportunity to be up there, that's something I would really love to be able to take with me or send ahead of me, perhaps.
On to you, Sandlin.
Wonderful. We did have a question, Abby, about whether your slides would be available so people could keep track of the initiatives. And so I'll let you.
Yes, I'm more than happy to make my slides available. I have designed them so that the links for images actually mostly go to articles and stories telling a lot more detail about the issues involved. So I'd actually really appreciate it if people wanted to request the slides, and my email address is there if they want to do that right away.
Perfect. Thank you so much. Okay, we'll transition to our next speaker. Okay. So Alexandra Matiela Novak will be talking about resource, public outreach and engagement, storytelling as a way to connect with diverse communities. I will restart my video and restart the clock when you are able to share.
Great, and hopefully you can hear me and you also are seeing
And we're
my...
seeing your presenter view slides.
Okay,
so if you go up and swap displays, we'll be good.
Okay, so let's see. Swap this, oops, share screen. Let's see. If this, okay, how does that look? Are you seeing my full?
Hold on a moment.
It's coming.
Yes, that's good.
Got it? Okay, great. Thank you. All right. So I am going to be driving the slides, but I'm actually going to have a few of my colleagues helping to present this work. And so just really quickly, we're going to be talking about storytelling as a way to connect with diverse communities. We've been working on this for a while now. And by we, I'm including some great colleagues from Howard University, Dr. Dina Khalil and her students, Iman Yassin and Zakia Bengura, as well as soon to be Dr. Tiana Woolard, who is a student of Dr. Khalil's, and she is also a teacher at Prince George's County Public Schools, which is a county in Maryland, and the schools are over 90% Latinx and African American students. So having her perspective and experience here has been absolutely valuable. And of course, our amazing PI for this work, Dr. Jennifer Heldman, for the resource team. So, okay, let's see. So storytelling. So there are two ways to share knowledge. And I feel like the most traditional way for us that we've been using is pushing information out. And what we're going to talk about here is pulling people in with a story and trying to connect people with the science that we're doing through storytelling and empowering their own views on how they can contribute to this science. And there's actually some great research, a paper that just came out by one of our collaborators, Dr. Khalil and Kier. So if you're interested more about the evidence-based modeling that goes behind this work, then please look through that paper. So today we're really going to talk about how we implemented this model in K through 12 lessons and connecting the problems and innovations of the resource team mission with tactics to empower conceptual storylines. And so with that, I will hand it over to Dr. Khalil.
Good morning, everyone. So just real quickly about how we are framing this study. To accomplish our goal of rehumanizing teaching and learning, we conceptualize critical race design as an approach grounded in critical race theory and design-based implementation research. In critical race design, the tenets of critical race theory identifies oppressive inequities, while design principles provide stakeholder strategies to address the inequities as they jointly define problems occurring that they're trying to seek to address, such as broadening participation. For the purpose of today, we'll focus on how we operationalize empowering minoritized students' agency by situating their everyday learning experiences and narratives as epistemological resources for designing curricular materials for the classroom. We found storytelling through culturally relevant engineering design challenges as a way of broadening participation of Black and Latinx students as it serves to counter their erasure by focusing on their assets and funds of knowledge. Storytelling's focus on their potential and impact is important as it helps them identify through mirroring, and it's empowering as it affects their neural coupling and dopamine. So by aligning culturally relevant engineering design challenges with the mission tasks, resource mission task, and Common Core and NGSS, we attended to 3 dimensions: students' interests, social justice issues, and SMEs of color. This provided them opportunities to access the material in culturally relevant ways that were authentic to their worldviews. In the next slide, my colleague, soon to be Dr. Woolard, will be discussing how we implemented this lesson in an 8th grade science classroom, 9th grade biology class, a few classes in Prince George's County Public Schools and DCPS, the District of Columbia Public Schools, and one after-school program. Approximately 30 Black and Latinx students attended, and the majority participated with creating and completing an engineering design challenge. The evidence is clear that the students were affectively, cognitively, and behaviorally engaged with the lesson. So take it away, Ms. Woolard.
Sorry. All right, so we had this idea of storytelling. Now, I am not a professor, an educator, have been for several years. So when we talk about this idea of stories, right, we use stories to make connections. And when we teach stories to our students, we emphasize 3 components: pathos, ethos, and logos, right? The emotion of the story, the ethics of the story, and the logic of the story. So we're actually going to hit on all those 3 components as we kind of go through how we implemented this lesson with these 3 different populations. So the first thing that we started off with was engagement, right? Anytime you're teaching kids or teaching students, their first question is, why do we need to know this, right? They don't care unless you make them care. So in order to engage them, we have to use what we call in education visual thinking strategies to let them know that what they're learning about, what we're talking about, relates to them in some way. So we can use comics, we can use, in the slide here, we use Black Panther, we use a comic here of the old pipes with the water and the dollar sign to kind of get them thinking about what might this mean and how might this affect us. So as students start discussing about what this comic could mean, we then take that discussion to them being able to save the world like a superhero in Marvel's Black Panther. Next slide. So as we get to the engagement piece, we then connect to a broader social justice issue. A lot of times students can be very, very absorbed in their own world, right? So in order to kind of get them aware of the different things that are happening around them, we introduce them to social justice issues. So one of the social justice issues that we introduced in one of our lessons was, should water be a human right? Right? Should people be able to own it, privatize it, and then sell it or then control it? So then we have people who don't have access versus people who have access and control. Is that fair? And do those type of things exist? And of course, we know they do. So kind of getting them aware of what social justice issues are around them and potentially involving them or other members of their community is key. Next slide. So the next part that we talk about is connecting to subject matter experts or SMEs, right? A lot of times, again, students can't connect if they don't see themselves. So being able to show that there are scientists, there are engineers, there are technologists, there are mathematicians who look like you, who are of color like you, they can say, oh, well, I guess maybe I can do that, or they look like me. So not only are they more interested, but they're, they are now positioned to think that this is possible for them. And so we share a story about an SME that is doing work in their community or in a community that's connected to them. Next slide. And then we kind of culminate our lesson with an engineering design challenge. So for this engineering design challenge, we took one of the standards from NASA's resource program, and then an NGS standard. So we used the water cycle from NGSS, and then we use NASA's resource standard for assessing and characterizing resources, specifically sampling and looking at resource utilization for water on the moon. And so we introduced this to them as a prompt, right? The satellite team has been working, they detected ice. It's your job to figure out how to build something to actually move this ice from the moon to your lab station. And then you want to get it before this private company comes in and takes it and, you know, wants to sell it. Next slide. So we have a prompt for the design challenge, and this is the actual prompt that students saw and had to respond to. Next slide. And these are some results of what students actually built. And if you look, they use a bunch of different materials, but these are all materials that they have access to. So that's another important thing that we want to emphasize, especially when we're doing engineering designs. Engineers do have constraints, and we understand that, but what's great about engineers is they can work within their constraints to accomplish their purpose. And there is a short video.
Alex, we can't hear it. It's okay, I think.
Let me start it over really quick.
Okay, so the video essentially was a student explaining how he built his water satellite or capsule, what he used to build it, and then how it works. So again, we're using these components of pathos, ethos, and logos, right? Pathos, caring; ethos, ethics and action; logos is awareness and logic of why we should be aware of these issues. And the storytelling is a pertinent framework for incorporating all these things. Next slide. Jackie?
Oh, this is me. Okay. Good afternoon, everyone. My name is Zakia Bengora. Right. When processing facts, two areas of the brain are activated: Broca's, which deals with speech production, and Wernicke's areas, which deals with the comprehension of language. A well-told story can engage more areas, including the motor, sensory, and frontal cortex. One key takeaway in these lessons: create unique opportunities for a diverse set of students to contribute to NASA's work in exploration and discovery. To point, many students ask various questions such as, are there oceans on other planets? If someone owns water on Earth, could someone own the water on the moon or other planets? Could I bring the lunar ice with me on the spaceship, or would it melt? Is there a cooler on the ship? Can you drink lunar ice? Does water on the moon mean there may be other life forms that are on the moon? They make connections to current events and push us to make the world a better place. Thank you. I believe we'll be accepting any questions at this time.
That was wonderful. Thank you so much. I'm going to have questions go into the chat at this point. We have a couple comments, and I would love for each of you to look, and I guess we'll have some overall wonderful time to talk. And this was such a nice bridge from what we've had. And so I'm going to introduce the next speakers, and we'll keep collecting our questions to do in the panel. And so I just want to make sure that none of our speakers run away, because we do have this collective time that we're going to ask you to participate in this discussion at the end of our session. Wonderful. Okay. I'm going to introduce our next two speakers together. And so the way, because I only have a 10-minute timer, what I'll do is I'll have it go and then I'll have it go again. So I'll have our speakers, so let me stop my video, introduce our next two talks together. And so the first is Oma Williams-Duncan, an overview of phase 3 research about the exploration of the moon and asteroids by secondary students, XMAS program. And Ashley Smith, cultivating student engagement in STEM, exploring scientist, advisor, teacher, mentor, and student team relationships towards student team success in the exploration of the moon and asteroids by secondary students, XMAS program. And so again, I'll run the timer twice for you. So when you see the 4-ish minutes on the second, you'll know that it's time to wrap up.
Thank you so much, Dr. Buxner. Can you all hear me okay? Okay, great. Thank you okay, perfect. So good morning. Thank you for being here. This research presentation that we're going to share today, Dr. Buxner already gave the title. So thank you again. So during our brief time together, we are going to share who we are, along with background information about our research, of course, the purpose, the research questions, the methodology, some preliminary findings of our phase 3 research. And then please keep in mind that this presentation is followed by a second presentation that's going to go into greater detail about those findings. During that second presentation, we're going to share our categories that were emerged, along with examples of the data that went along with those categories. So with that, I'm pleased to start with introductions. I am Oma Williams-Duncan, assistant professor at the University of Houston Clear Lake. I'm joined by my team of researchers, and they're going to share their information now.
Hi, everybody. I'm Sandy Watson. I'm an associate professor at the University of Louisiana at Monroe.
And I'm Ashley Smith. I'm a doctoral student at the University of Houston Clear Lake.
And I'm Yasmin Al-Rashidi. I'm a graduate assistant at the University of Houston Clear Lake.
So this phase 3 research project actually consists of the following partners: the University of Louisiana at Monroe, the Lunar and Planetary Institute in Houston, and the University of Houston Clear Lake. The exploration of the moon and asteroids by secondary students, known as XMAS, is a NASA-funded education program that began in 2014 and provides 10 teams of approximately 5 students each from schools across the U.S. the opportunity to conduct authentic, student-led, open inquiry research with assistance from their teacher and a scientist over an entire year. The program is managed by the Lunar and Planetary Institute, is funded by NASA's Solar System Exploration Research Virtual Institute, also one of the same institutes funding this conference today. The article that you see on the slide here arose from previous research from phase 2 and involved Andy Shaner of the Lunar and Planetary Institute, myself, Maya Bakerman, and Sandlin Buxner, both of the Planetary Science Institute in Tucson, Arizona.
Phase 1 of the XMAS research study was mainly quantitative. Researchers focused on validating the XMAS surveys. In phase 3, we are applying an exploratory mixed methods approach to identify scientist, student, and teacher relationship characteristics. This means we are determining answers to our research questions by considering qualitative data found in emails and in open-ended response sections of the surveys, along with considering the quantitative data found from Likert scale components of surveys. The qualitative data is subjective and adds rich context and background to our study. Without these emails, the voice of the student or scientist participants would be lost. Qualitative data analysis requires us to determine categories of ideas. We refer to singular ideas within categories as units and the iterative process of categorizing ideas found within text as coding. So when we say codes or coding, we don't mean computer coding or programming. In qualitative research, we read participants' statements, or in this case, emails between the scientists, students, and teachers to iteratively group statements within categories. We also agree upon the definitions of the categories, which eventually become, in our case, examples of relationship characteristics that could be emulated or replicated when attempting to duplicate XMath successes. There's little research highlighting mentoring or advising relationships between scientists and secondary students. Such relationships have the power of influencing the STEM pipeline, as students can learn directly from scientists. While initial research sought to determine validity of the XMath participant survey, Phase 3 research seeks to define relationship characteristics between the XMath triads, that is, the scientists, students, and teachers, and generate new knowledge about such science inquiry relationships.
Our study focuses on 4 research questions. We have posted the most salient questions linked with our currently collected data. Additionally, for the purposes of this short talk, we are highlighting the research question that is aligned with our currently analyzed data and its most aligned sub-question. We want to remind you that data analysis is still occurring, so today's talk mainly focuses on the highlighted questions. How did the scientists interact with their student teams while facilitating authentic science inquiry? And what were common advising characteristics or elements between XMath scientist advisors and their student teams?
Currently, our research consists of 3 sources of data: XMath applications, emails, and pre-post surveys. For the purposes of this talk, we are only focusing on data from the emails. As of the date of this presentation, the researchers have collected and collated emails between 7 teams of scientists, students, and teachers. Within the last few weeks, we coded the emails. And again, we don't mean computer coding. In qualitative research, coding is the process of determining those categories by reading, comparing, and sorting text based on their content. So in this case, we read all the emails and grouped similar ideas to generate categories. After working individually, we met to discuss our categories. We normed and defined the categories. We determined that multiple occurrences of similar ideas appearing in a single email should only be counted once. We discussed and compared text within categories. We also agreed that 3 or more occurrences of similar ideas per category and per researcher constituted a category. These practices allowed us to establish what's known as intercoder reliability. Further, after this talk, we will retest our agreed upon categories to ensure we have solid agreement. Given the amount of data we have and the required analysis practices we must employ, our research again is ongoing. The applications and surveys will undergo quantitative and qualitative analysis, where descriptive statistics will be used for the numerical portions of the applications, and surveys and constant comparison analysis will be used for any open-ended response questions. This slide displays the participating teams that completed the 2021 XMath programs. While 10 teams started, only 7 finished and presented their research. As you can see, teams represented a variety of states and cities across North America. Each team consisted of 1 to 2 teacher mentors and 3 to 6 student researchers that were in their 2nd to 4th year of high school. Each team was assigned a scientist advisor. Now that you know who we are, how we analyze the data, and who generated the data, let's learn what these scientist, teacher, and student teams discussed in their emails.
So as we stated, our research is ongoing. We have begun the process of open coding the email exchanges between the scientists and the student teams. We have defined 2 main themes with multiple subcategories within those themes. In our next presentation, we will begin to define the 2 major themes, and we'll explain and provide examples of emails that fit within a sampling of the subcategories.
So at this time, our first presentation, which overviews our Phase 3 research, has concluded. If you have any questions, I think it looks like we have a little time to answer any questions.
Definitely, and there actually is one in the chat that I'm going to read out really quickly. And I think this is something that a lot of people who do this kind of research really resonate with. So I have come across a bias held by scientists. When I try to share qualitative data, they do not think it is real or good enough. What strategies might be used to underscore the rigor of qualitative data? Your methodology is solid and robust, yet I know some scientists will balk because datum could be an idea, not a number.
So I think that that's where the intercoder reliability comes into play. There is a point where you can start to attribute some quantitative numbers or quantitative data to the qualitative process. And again, that's where the intercoder process comes into play. So I think you have to spend some time explaining that portion of the data analysis. I would love for Dr. Watson to maybe share her thoughts as well.
Yes, I agree. It's not as simple as it appears. So for example, in this study, we are about on our 6th iteration of analyzing the emails and identifying themes. And towards the end of that, we get together and we look at each other's classification and we try to come to agreement. And that's where we calculate our intercoder reliability. So at first glance, it might not seem scientific, but it is actually very scientific and takes quite a lot of time to achieve.
Yes, ma'am. So with
I'm going to
that,
go ahead and I'm going to restart your timer so you can go to your second one here.
Okay, so thanks so much. We're going to proceed with this next portion of our presentation.
So this portion of our presentation, our second presentation, is titled Cultivating Student Engagement in STEM, Exploring Scientist, Advisor, Teacher, Mentor, and Student Team Relationships Towards Student Team Success in the Exploration of the Moon and Asteroids by Secondary Students, XMASS program. In this second presentation, we will discuss the preliminary findings and provide some examples of emails that fit into various subcategories. Just as a quick aside, as educators, we were excited to see the level of student engagement throughout the program and through their sophisticated questions and discussions. And you'll see some examples of those throughout this presentation. We will finish with our next steps and future research goals, and then we will invite your questions. So as I said before, we have categorized the content of the email exchanges into 2 major themes. Discussion of the research, where advisors, mentors, and students were asking questions and discussing their projects. And the second theme, communication, which includes subcategories addressing how the scientist advisors interacted with their student teams. Within each theme, we will discuss selected subcategories and provide examples.
So very quickly, here's a list of the subcategories connected to the larger category, discussion of research. Following this slide, we will provide examples of the specific subcategories that you see here in bold text.
Discussion of research showcases conversations between scientists and students or teacher mentors representing their students. The first category, scientists provide resources, is defined as occurrences where scientists provided links to papers, tools, reference materials, images, either solicited or unsolicited by students. This particular slide is an example of 2 different conversations between scientists and student teams, in which scientists provide resources such as images, references, and posts related to, in this case, crater age dating.
The second subcategory, scientists advisors provide content and or clarification, speaks to a scientist providing help with interpreting academic content, facts, or definitions often found in high-level research papers or other sources gleaned by the student researchers. This slide shows examples of how a scientist explains reflexivity and directionality on lunar bodies. As a quick aside, none of the researchers on our team are lunar or planetary science experts. We found the academic content of the email exchanges to be fascinating and learned some cool information ourselves. Additionally, we were impressed by the secondary students. They were able to follow the conversation and engage with the scientists by asking relevant questions, requesting poignant resources, and embarking on unfamiliar data analyses in some cases.
The third subcategory, scientist advisors provide experimental design or scientific inquiry help, speaks to a scientist advising the research process. In K-12 science education settings, we refer to the research practices as including process skills, scientific investigation and reasoning skills, or simply science inquiry or experimental design practices and protocols. This slide represents an example of this category, where a scientist suggests students come up with an NEA plan, a near-Earth asteroid plan.
Here's a list of subcategories connected to the second largest category called communication. Following the slide, we will provide examples of the subcategories that you see here in bold.
This subcategory, scientist advisors address team and/or students directly, refers to any direct conversation between students and their scientist advisor. This type of encounter occurred frequently and also included rapport-building statements. Rapport was created between scientists and teams as indicated by the slide. Here, the scientist took a picture related to her student team's school while driving in her city to the delight of her team. Additionally, scientists shared personal details in an attempt to connect with their team members. Such conversations humanized the scientists and made them accessible.
So in the last subcategory, we want to examine are the email exchanges between scientist advisors and the teacher mentors. We have coined this the adult conversation, or the conversations that students weren't privy to. Because of the way the mentor advisor role was established, the mentor serves as the main point of contact between the team and the scientist advisor. However, about double the amount of email exchanges were between the scientist advisor and the mentor, excluding input from the students. For example, this exchange between the teacher mentor and scientist advisor. The advisor is describing an important research finding and their plan for explaining the implications with the students at the next meeting. My future research and ultimately my dissertation will focus on the scientist advisor teacher mentor relationship and how they work together to facilitate their student teams through this authentic inquiry project.
With phase 3 research consisting of 2021 XMAS data from a single cohort of participants, phase 2 data consists of applications and survey data from as far back as 2014 through 2018. We refer to all the data as the XMAS data cache, and all the data potentially allows for a longitudinal study about the impact of scientist advisors on high school students. Along with the emails we discussed earlier, we will analyze student and scientist responses to an adapted version of the Munich Evaluation of Mentoring questionnaire, and also an additional questionnaire that we've created ourselves. Responses on these additional instruments will allow us to analyze characteristics of the relationships occurring between XMAS scientists, students, and their teachers. We believe that determining and disseminating the positive characteristics of the XMAS relationships can increase their frequency and potentially help replicate the XMAS program and scientist involvement with high school students.
We researchers were very pleasantly surprised and amazed by the level of understanding demonstrated by the high school students. As this slide illustrates, this is a high school student responding to a scientist email. So please take a moment to read the slide. I think you'll be amazed as well.
So I'm going to go ahead and switch the slide now.
So as I mentioned previously, my dissertation will focus on understanding how the advisor-mentor relationship influenced student research and participation in authentic science inquiry.
Here's a sample list of our references. And at this time, this concludes our second presentation. Please let us know if you have any questions. We are happy to share our thoughts or listen to your comments at this time. We just also want to say thank you so much for allowing us to be here. We really appreciate this opportunity to share. And quick shout out about the LPI program, and rather I should say XMAS program. We've included Mr. Andy Shainer's information here on the slide in case any scientists would like to help out in future XMAS cohorts.
So we do have a question in the chat from Jay. It says, these direct scientist mentor partnerships are obviously so powerful, but there are a relatively few number of scientists compared to the number of potential mentees. What can be done to expand or leverage or instead to strategize and target these relationships where most are needed?
I can address that. One of the things that we have on our timeline is we are submitting a proposal to the NSFDR K-12. And what we hope to be able to do if that proposal is funded is to host a conference that we're calling a conversation, where we will include teachers, students, and scientists in the conversation so they can learn more about what each other is doing, so that we can highlight what kinds of similar programs are in place. And so just everybody feels more comfortable with these connections. So we're hoping to get more scientists out of that conference. So that's one of the things we have planned.
Wonderful. Thank you so much for those great talks. I'm going to introduce our last speaker, and then we'll have time for a big discussion. So I will introduce Francis Ju, Artemis CubeSat Kit, a low-cost spaceflight ready 1U CubeSat in educational materials in the public domain. And so I'm going to have one of you unshare your screen so that Francis can share her screen.
Great, thank you. Can you hear me okay?
You sound great. Do you have it? Perfect. Okay.
Awesome. So, hey everyone, I'm Dr. Francis Zhu. I go by Frankie. I'm an assistant professor at the University of Hawaii. I'll present on behalf of my wonderful team on our project, the Artemis CubeSat Kit. The Artemis CubeSat Kit is a low-cost, spaceflight-ready, 1U CubeSat kit that comes with educational materials in the public domain. So on the top right, you'll see a CAD or computer-aided design of the guts of our kit. And on the bottom right is a glamour shot of the kit as built. So we were motivated to create a kit with these three features: that it is low cost, spaceflight ready, and open source. Sorry, just checking the chat. The open source design promotes accessibility, technological progress, and adoption. The low-cost hardware is a solution to the problem of making these kits accessible to more classrooms, as educational funds are historically very limited. The spaceflight-ready hardware distinguishes us from other educational kits and augments the educational experience. We designed this kit to be NASA GEV's and NanoRacks requirements for low Earth orbit, but the kit could also act as a suborbital payload or tabletop demo. So just to clarify that jargon, we designed this CubeSat to adhere to all kind of standards that are in the way to getting into low Earth orbit. The mechanical, electrical, and software components are aimed to be easy to interface. Here is a feature sheet that we give to people who are interested in using the kit. The CubeSat kit has a baseline payload of a small camera, but we want other teams to swap out that payload and fill that about quarter unit of volume with a payload that satisfies a mission of their interest. And for those who are not familiar with CubeSats, this particular form factor, a U or unit, is 10 centimeters by 10 centimeters by 10 centimeters. It's about the size of a tissue box. So we've got 3 different boards in there that control the spacecraft. The BeagleBone Black is one of them. It's our computational workhorse for more ambitious missions. The Pi Cubed is our lower level controller for low power routine functionality. The Raspberry Pi Zero is specifically to interact with our camera up there. We have dynamic sensors like a GPS, an inertial measurement unit, or IMU, coarse sun sensors, and dynamic actuators like torque coils embedded in the solar panels, which are not shown in this anatomical view. Our communications system is a HOPE RF UHF transceiver and a deployable monopole antenna that we've made out of material like tape measure. Our electrical power system includes solar cells on 4 panels and a 50 watt-hour lithium-ion battery pack, outputting 3.3, 5, and 12 volts. The structure that encapsulates all of these electronics is machined aluminum, and the total cost breakdown of the parts is seen on the right. So at cost, we have the CubeSat can be built for less than $2,500. The other aspect of this project is the spacecraft mission design curriculum and course materials. So I personally was very involved in creating this curriculum and online course. It's one of my teaching requirements. So this course was geared towards undergraduates with no prior aerospace engineering experience. So I'm thinking about potentially community college students or lower level undergraduates at a 4-year university. On the bottom, we have a diagram of the progression of the course, starting with context around the spacecraft. So here we have the history and motivation of space exploration, the space environment, orbital mechanics, systems engineering, and then the constituents of a CubeSat or any other spacecraft. So the different subsystems in theory. And then what's unique about this project is the kit augments the theory by providing a hands-on lab. So we weave in between theoretical chapters and then applying hands-on lab modules to apply that knowledge. So we then end on the right side with integration and testing of the spacecraft and the next steps towards launching a spacecraft. Here's a snapshot of the online course material. The guided course materials are all in a Google Drive, where I have a spreadsheet for the progression of course activities and assignments, topics that I'll cover, and a repository for different lectures. And you'll see a snapshot of lecture on the bottom left. The textbook table of contents is given here and is hosted on an online platform called Pressbooks. We've collaborated with our university's Office for Open Educational Resources, or OER, to create this publicly accessible textbook. With a browser tool called Hypothesis, students read and annotate the digital textbook prior to class, and then I craft a lecture with their questions embedded in my lectures, seen here. The lab modules for each subsystem are also in this textbook in procedure form, but we also host a demo and Q&A section for each lab, a section of the structures lab seen here. The lab modules are specifically designed around the Artemis CubeSat kit, so the activity can act both as an educational demo and as engineering analysis towards spaceflight. As a part of this kit, we have open source software based upon the Hawaii Spaceflight Lab flight software called Cosmos. All of our designs, code, and software tutorials can be found on our GitHub, which you can see on our left. And then this software and software tutorials that range from getting your Cosmos environment set up to communicating with your baseline payload is seen on the right here. And I can share these slides if you're interested in getting these links. So finally, I wanted to just touch on our involvement with a broad swath of strategic partners. So we worked with as many strategic partners that were willing to collaborate with us to hear about their needs in a CUBE satellite kit and educational program. We've asked them to attend our reviews, so engineering design reviews, ask questions, give feedback, and when the kit is done, to receive the kit, gather students, and follow along in our open source public domain course. At the end of the online course, we would discuss the effectiveness of the course and kit to make a better revision if funding allows. We originally proposed to collaborate with all of our Hawaiian Island community colleges, seen in this map here, and a couple of institutions in Washington to focus on underrepresented Native Hawaiian, Native American, and first-gen students. We've since then accumulated some space grant institutions from the National Space Grant meeting in February. After advertising this collaboration, we added Oregon, South Dakota, I think Nevada, and North Dakota. So after our kickoff meeting with the Office of STEM Engagement, the Space Technology Mission Director and Chief Economist meeting, the Chief Economist urged us to consider adding these other states that are immature in the CubeSat launch initiative map that you see here, because that office really wants every state to launch a CubeSat. That is all to say that we are trying to be as inclusive as possible and have taken on 4 more institutions that we were not originally funded for to meet the wishes of the Chief Economist. So if you want to work with us or buy a kit, please get in touch. I'll just leave this information for you. So if you need to contact me, this is the email. If you want to see our design, our software, please go to our GitHub. And then if you'd like to check out our textbook, please go to this site. And with that, I just want to acknowledge our funding and support from the NASA Office of STEM Engagement and the Space Grant community. So thank you. I'll take questions now.
Wonderful. I'm going to start with one question that Jay put in the chat, and then I'm going to have all of our speakers join us for our full discussion. And so Jay asks, in my own community college teaching, I found students to imagine themselves unqualified to do engineering since they feel inadequate at math. Many times that's not the case, and they know plenty. Other times they do need some help. Do you find your target student audience, early undergrad students or community college students, already have the necessary math background, or do you have a means to help provide the background?
I think that is a really sad problem, the feeling of like an imposter in qualifications. But in this textbook, all of the fundamental knowledge that one would anticipate knowing coming into the course is linked to many Wikipedia articles, many different other supporting materials that are publicly accessible, such that if you feel that you don't have this background, that you can, bring yourself up to speed in a self-guided way. Thank you for that question. And this project is aimed to get those students involved, to have them feel that they are qualified and that this is as accessible as possible.
Wonderful. I want to thank all of our speakers. We're not done. We still have about 20 minutes for discussion. And so I'm going to have Frankie, I'm going to have you unshare your screen. Perfect. And I'd like everyone who is a speaker to join us so we can see everyone. And again, to the audience, we really want to have a discussion. I'm going to send this over to Jay, but I just want to say you can either raise your hand or put a question in the chat. I will do it, keep looking back at questions, but Jay, I'll let you take it away for discussion.
Great, thank you. Yeah, so I'll keep my eye on the screen here to see if I see any hands pop up, or I'll take a look at the chat. But I wanted to start by making a comment about how stories as a theme, of course, in our work are so important, and how that has been a theme that I see, through all of the talks today. A quick question just popped up for the last speaker. Any restrictions for international schools to have a CubeSat kit?
Great question. So we're working through some export controls right now, but as of right now, we know that if a design is publicly posted online, that it doesn't have any export controls applied to it. So I'm still working through the finer details, but thank you for that question.
And I'm going to paraphrase something I popped up earlier. I'm not going to scroll back to it, but of course, we're meeting jointly with the European Lunar Symposium, and this is a very international audience. And I've been wondering about how the stories we're telling, right, that we're talking about, how do we make these really global? How do we make these really, right, international stories? How do we connect what's happening in people's personal lives to what's happening globally when those are so different? So I'm going to throw that out there as a question to anyone of the speakers to consider.
I'm here too, even if you can't see me, and I'd like to answer that one to start us off, if that's okay. So obviously I'm meeting with you all from a different part of the world. It's 3 o'clock in the morning at the moment. And I found that with the pandemic, the online world has suddenly opened up to people that can't physically travel. But I'm really shocked at how many times during this conference people have talked about how their next opportunity will not necessarily be virtual. And I find that quite frightening, because I've just got used to being able to be here. But I wanted to highlight that, you know, I was saying to somebody, my church has an audience in the building of about 1,000 people all day long, but has an audience of about 150,000 people around the world. And there, when I actually listed it out, there were about 15 different strategies we use to make both groups of people feel equally at home and equally a part of things and not disadvantaged at all. And I just wanted to put that plug in, that having face-to-face meetings does not mean that you need to stop having virtual capacity for people who can't be there. So I just wanted to really encourage that. And I can see Greg's got his hand up.
Abby, I think that's a wonderful comment, and I can't tell you how many conversations we're having about that within SSERVI and in the community in general, because we have been, I mean, you, Abby, and I have talked about this. You know, you wouldn't be able to participate in these things if you had to fly out, right? We're going to have, as we reach out to the disadvantaged community, there's going to be a period of time where there still aren't funds to support a lot of travel. And so for us, one of my top priorities personally is creating as level of a playing field as possible for blended meetings, blended virtual in-person meetings. Now, we don't have the answers yet. We're looking at using AR and VR as well as other technologies, but we're keenly interested in everyone's input on how to do that best. And we're going to be trying some things in the next few months, and then creating a blended meeting next year. And it's really, really important to us in leadership that this be done successfully. So thank you for that comment.
Yeah, and I would like to just honor what Greg and Christina and Jay and others are doing in this space, because I think it's one thing to have that in the back of your mind and think, wouldn't it be nice if we had a solution, or maybe we should talk about that. But as you can hear, that's not this kind of place. And in this place, we hear of ideas and we hear of problems, and then everyone gets together and solves them and takes action. And I think that's something that's very honorable and I'm very appreciative of. So thank you for your work in that area.
Thank you, Abby. That's an incredible compliment. I hope we can continue to live up to the not just saying we're going to do it, but actually doing it thing. That's incredible. Before I derail, change the topic, right? Because right at the moment, we're taking a look at some of this, what is it we're doing now that allows us to reach international audiences with our story? And I'm thinking about the story itself. So if somebody wants to jump in with a comment or question about our methods, do that now. Because I'm thinking about the story. For instance, we're talking about lunar science right now, and like Artemis, say, the Artemis as a story in terms of a lunar program. And no, is that in fact an international story? I have to say, I personally don't think it is. And I think there are some huge problems with it, and addressing what that means for us to try to connect young people to a story, or try to connect young people who aren't, a part of that particular government to that story, and what our problems are with that. So if there's any other questions or comments, and there's also another question here. How do you react to people who think that all this EDI stuff has gone too far? There's a good one. So anybody want to jump in on either of those, please do.
I'll jump in and kind of go through both the has EDI gone too far and stories, because one of the things I think I do in my own work, I'm a theorist, so I felt very scared to come here to talk to you. Like, scientists talk about real things and I talk about ideas. And then Jay, I saw earlier in the comments when you were like, but scientists have a bias against like this sort of thing. And when something is an idea, not a number. And then I was like, what are you talking about? Numbers are ideas. And of course, I don't know if the scientific community is ready to have that conversation yet. But when it comes down to it, we're asking ourselves and the world to be part of this story about being cosmological beings. It's not that we're going to go out there and we're going to explore and find out how we fit in the world. We already fit here. We're already part of this universe. It's a matter of figuring out the multiple relations that we can actually have with the moon, not just staring at it, which I'm sure we all lovingly do, and we do as like the human population around the world. It's saying how else can we relate to it? And we have answers to that, and we see that in indigenous science fiction, and we see it in Afrofuturism. But what we don't see it is in a lot of times the work that's actually being done. And I mentioned this in one of my comments. Where are the dancers in the Artemis program? Where are the storytellers? Where are the people who are going to be like, well, what is it going to look like when we take our pets to the moon? And so it's a matter of opening up, saying, and we all know this from the pandemic. We all didn't just immediately start zeroing in on watching every single thing that the scientists working on the COVID vaccines were doing. We were watching Netflix. We were engaging with art and music and the incredibleness of the world. And so while we need the science, we also need everything else that goes with it. That's actually the life that we are part of. And I think that we can bring people into understanding the story around Artemis and lunar, not just lunar exploration, but space exploration as a whole. If instead of telling people you need to be part of STEM to come with us, we say, actually, whoever you are actually part of this already. And as it relates to the EDI stuff, I think it's interesting because so many people, and I get accused of this. My entire dissertation is on colonial rhetoric in space, and people are like, but you're just reading into it. And I was like, but that's what happens, right? When we say something like the frontier, who does that include and who doesn't it include? And when we say things like, how far does this inclusion and diversity thing have to go? Well, for me, it's like, well, as soon as everybody on the planet, and I know we can't have just global democratic, governance, but when people don't feel excluded, in fact, when people who have historically been in power stop talking and stop being in leadership positions, and we see more people in leadership positions, not just in leadership positions regarding the already existing structures, but new structures and new ways of being and new ideas that come out of both ancient indigenous ideas and modern indigenous ideas, but also, what is it that we have to offer as people living through a climate apocalypse? And so I think all of those things are stories that we get to tell, and we need to connect those stories to everyone, and not just try to bring people into the story we are telling ourselves, but rather how do our story connect to the other stories.
Mm-hmm. Thank you, Natalie. I saw a lot of nodding heads to that around like Alexandra's and Frankie's and Dina's and Tiana's. Do any of you want to comment on that as well?
Yes, I was going to type out my answer, but I'm just going to say it out loud. I think that Lee's question is great. I'm just not convinced that DEI efforts have gone too far until we have at least proportional representation that exists in all STEAM fields. Then we can have a conversation about retention, workplace climate, and promotion. I would ask this person to envision what an unbiased random system would produce if it just generated people who worked in this field. So hopefully that can get at their technical bones, whatever that means.
I want to say that really, Natalie, what you said really resonated with me, and I wanted to share a brief story that Jay has heard before. That my wife Cindy runs a program that's bringing in indigenous knowledge into NASA and the earth sciences. And you know, we both feel equally passionately about this. And one of her goals that she and I have talked a lot about and that she has shared with NASA headquarters is that she feels very strongly that an indigenous person should be at NASA doing what she's doing. You know, that she has only so much capability to understand because she hasn't lived that. So and then I want to say as well, you know, I'm not immediately going to be retiring, but it isn't too many more years away. I'm having too much fun right now, but it's really my intention to you know, to try to get people interested from all different communities in leadership of SSERVI as well, you know, and try to get some good applicants from communities that might not have otherwise considered something like this, because I think that can just be so inspiring to people seeing, as one of you, I forget which one said, someone who looks like them, you know, in that position. So it needs to be, you know, it needs to be someone other than white males. I say this as a white male.
May I say comment as well?
Sure,
I think we are still in a very preliminary phase of changing the society, especially because we are still using the same parameters just now that are reversed to women, and not promoting any woman that fits still the parameters that have so far encouraged male. You know, now you're using the same parameters to enable women to climb the ladder, which is still not completely encompassing all sorts of humans that exist. So I think I like, for example, for me, I lived in the US in the big push of the affirmative action. And at that time, in the beginning, it created a huge animosity between whites and blacks. So that's why we're now having the Black Lives Matters, because we didn't really go to the core of the problem, or, you know, the US or whomever use the same strategy of quotas. Yeah, the core of the problem is that bad schools in poor neighborhoods, and so on. There has not been an equalization of education to all across whichever land. So that's why Black Lives Matters has been the next step of the affirmative action. And I think in terms of enabling women to get to the higher posts, it's still in the affirmative action initial steps. So there's still a lot to be done to be inclusive. Not all women should go up the ladder, you know, not necessarily, you know, because right now the ones I have seen and I have witnessed are those who correspond to the parameters we are hoping to fight against. And this isn't, I don't think we are still in the path of actually being questioning the parameters that are being used that need to be changed. I'm not saying I have the solution right now, but I think this is the step for a more actually equal society globally. Yes, but now we are centered on the European American sort of mindset, really.
Yeah, certainly what we have seen is a lot of initiatives still only benefiting white people, and it just happens that some of those are cis women this time, and it's still just benefiting that particular group and supporting all of the systemic racism that still existed. So
yeah, for sure. Here in Europe, I see a push on a lot of women that sometimes I question their behavior, actually.
Yeah.
Just repeating the same. Bullying and things like that, so.
Well, I think that's where we have to move away from what like the new left would call identity politics. It's not just about the identity of the people, it's about what they reinforce. I like to say we don't need to bring more people to the table, we need to get a new table. It's the table that's the problem. It's not, because we need the greatest minds of the entirety of the planet to figure out the problems that we have. And if we are only ever going to allow people who reinforce extractivism and global capital and patriarchal norms, then even if those people look like me, they're doing something wrong. And I think that's where, in the space community especially, it gets kind of scary, because then we're actually questioning behaviors on Earth, and it's not just about space. It expands the story of space onto Earth. And which is why, when I mentioned Amazon, why is it, I will never say, yay, a white lady went into space. Well, Amazon workers are being treated inhumanely, and people are dying. That's, a win for a white woman isn't a win for liberation. And that's where we really need to question the systems that go into these things, not just the people. And at the end of the day, those things are beyond science. They are, they're ideological, they're social, and they're political.
Right. Thank you. I want to check and make sure there's a lot of folks who are speakers in this session who haven't had a chance to make a comment yet. If they would like to chime in on any of these thoughts or ideas, because again, I see a lot of nodding heads.
I just wanted to, Tiana, I would like you to talk right after me. I just wanted to mention that we did drop a link to Dr. Khalil's research about using storytelling to empower scientists and students to form relationships. So that was in the comment. And then soon to be Dr. Willard, please go ahead and say what you were going to say.
Thank you. So, and just to add on a lot of what you guys are saying, again, I don't have a space history, so I can't speak to all those details. However, I am in the classroom on a daily basis and working with kids in an urban population. So I can say that a lot of, and I'm appreciative for the opportunity that Resource has provided for their broadening participation initiative, because a lot of times you can't even start working on a problem unless you know that it exists, right? And so many times our students aren't even aware of what's going on around them until it's brought to their attention. So I can appreciate the broader perspective, whether it's of space or the moon or even other social justice issues that students just may not even think about, that aren't in their Instagram feed, that aren't on their Snapchat, that they can get exposed to, whether it's within their classroom or in informal opportunities that they're in, to broaden their horizon, so that they can start thinking, and being aware that there's a problem, right? And that problem either affects me and I didn't even realize it, or that it might affect me or somebody that I care about. So, and not only the awareness piece, but also kind of empowering them to know that you can make a difference, that you have other options beside what you have grown up knowing, what you've been just culturally accustomed to. So I think broadening the participation especially starting with the younger ones, it's very, very key, because a lot of students, I run into students 10 years that I've taught 10 years, 15 years ago, who, because of something they learned in science class, or because of, and it may not even be a science class, or a hands-on experience they had in math class, kind of let them know, I do kind of have options than the kind of traditional. So I think being able to continue to bring in teachers, being able to connect scientists to classrooms, being able to kind of get the big picture of what NASA is trying to do and making that relevant to students, so that they not only have an awareness, but a passion for, okay, this is something that I kind of need to be aware of or need to kind of keep on my radar. I think that that opens up opportunities that we really can't even accommodate for now until they kind of blossom into the future.
I just want to let us know that we are at the end of our time for our session, and I want to thank all of our speakers and everyone who came. And we want to encourage people to continue the conversation because it is an important conversation. And so please keep the conversation going and gather town. Please reach out to the speakers. But want to make sure that we have enough time to have a break before we start our talks back up.
And I'm going to say, if you're not already a part of the EDIA focus group, please join our mailing list. We would love to have everyone in this session join and to continue the work and conversations there. We would love that. Thank you.
And then Jay and I are just going to plug one quick thing. I'm going to put it in the chat. Jay will be leading basically a virtual communications workshop for disabled writers. I'm going to put that in the chat for anyone. We are still looking for some SSERVI scientists who might want to participate, and obviously push this out to your communities as well who might want to participate.
I'd like to add my thanks as well. This is the first time we've done a session like this, but it's certainly not the last. And thanks everyone for your perspectives and for helping us move in a good direction. And thanks to the co-chairs.
Are we done? Are we bye? Bye.
Good to see you, Jay.
Yeah. Thank you so much, everyone. Bye.
Thanks, Anlin.
Ricky or anyone else, could I get a quick sound check?
Yeah, your audio sounds good.
Awesome.
Welcome back, everyone. And I'd like to introduce what is always one of my very favorite parts of each of our forums, and just so happy to have our European colleagues here as well. This session honors people who've had an enormous influence on our community through their superb science, through enabling our next steps in human exploration, through leadership in a wide variety of ways, and through service to the community and extending the community to those who need it. Each of these 5 people are incredibly deserving of the awards that they're being given today. I would like to ask that each of the awardees stay for a group picture after the full award ceremony is done. And now I would like to turn it over to Professor Carly Peters to introduce our first awardee. Carly.
Okay, thank you. Well, the first award is the Eugene Shoemaker Distinguished Scientist Medal. It's named after American geologist and one of the founders of planetary science, Gene Shoemaker, from whom we've learned and are still learning so much about the fundamental nature of planetary bodies. The 2021 Shoemaker Medal is awarded to Dr. Paul G. Lucey for his significant contributions throughout the course of his career. The SSERVI Shoemaker Award includes a certificate along with a delightful medal, one side of which contains a Shakespearean quote, "And he will make the face of heaven so fine that all the world will be in love with night," unquote. Now, Paul Lucey received his Bachelor of Science degree at Brown University. This was before my time, actually. And then his PhD in geology and geophysics from the University of Hawaii with Tom McCord. He is now a professor at the Hawaii Institute of Geophysics and Planetology at the University of Hawaii, Manoa. Much of his research in planetary sciences focuses on using remote sensing tools to document and understand the nature of the moon and small bodies, amongst other things. He has accomplished this over and over again. Now, Paul has been an active and productive participant on several missions, including Clementine, the Near-Earth Asteroid Rendezvous to Eros, the Lunar Reconnaissance Orbiter, specifically working with the Diviner and the Lola team. Now, a little connected history, which many of you may not know about for the first 2 of these. Gene Shoemaker was a very primary force behind Clementine. It was originally a DoD instigated mission, but of course had a lot of science that Gene clearly cared a lot about. So he and his colleagues came to NASA asking if they might want to provide a science team involvement. And of course, NASA said yes, and the rest of history. The second example that I'd like to mention is that spacecraft are typically named slightly different from the mission that they're associated with, but spacecraft will have their own name. And for the NEAR spacecraft, it is now known as the NEAR Shoemaker spacecraft. Now, Paul also is currently active as an ANGSTA team member looking at the newly opened Apollo 17 drive tubes and documenting compositional and maturity variations along the length of the core with multispectral imaging and spectroscopy. Paul has received many, has served on many reviews and national advisory committees, including the widely referenced NRC SCEM report. Has been a successful principal investigator with several NASA programs, participated in numerous NASA panels, has served as editor of JGR, has published extensively in prestigious journals, and this is something I'm curious about, is also the co-inventor of a few patents. Now, Paul is very smart and a highly productive researcher, and there are many labels we can list for him. I'm not going to mention all, but there are a few that I do want to highlight. Right from the beginning, when he first went to Hawaii, he became an astronomer and continues to be an astronomer to this day. It's this nice mix of remote sensing as well as instrumentation, which he excels in. Through the process, he's become a very accomplished lunar and asteroid scientist. He is also an instrument developer who sees and then pushes boundaries of design. One of his design, in fact, is to be launched on the NASA ESTO CubeSat in a year, I think. Paul is a master of data analysis, creating tools that are widely used by the community. He's well known now as an insightful expert on lunar polar water issues. He is a professor with broad talents and insights, as exemplified by many former students of his who are now leaders in lunar science. He continues to be a generous mentor for young scientists, and the list goes on. Let me end with one, which is last but not least. Paul is an enthusiastic and energetic colleague and friend to many. Dr. Paul Lucey's significant contributions across many disciplines, from engineering new instruments to insightful and highly relevant science data analysis of the moon and small bodies, makes him an exemplary recipient of the 2021 Eugene Shoemaker Distinguished Scientist Medal. Congratulations, Paul. Over to you.
Okay, can I be heard? Okay, I guess I can. Well, that was extremely kind, Carly. I'm just so honored by everything you said, and of course receiving this award. When Greg called me, I was just astounded. I was just speechless. Well, that speechless is a metaphor because I'm never speechless, but I think you get the point. And when Greg hung up the phone, and I went to see the list of recipients, former recipients of this award, well, I was further astounded. That imposter syndrome thing is quite a phenomenon which I hadn't encountered before. So that was really moving. But every population has wings, and so I'm happy to shore up my wing of the population. I wave at my pal Jack Schmidt on the other wing. But when I saw the list of recipients, there was another aspect that was very special to me. I didn't know Ross Taylor at all. I barely knew Don Wilhelms, but every other person on this list has helped me so tremendously in my career and everything I've done. I want to give special thanks to my really dear friend Jim Head, who a class he taught at Brown got me into planetary science. He gave me an undergraduate job and nurtured me as an undergraduate and has been supported me through my entire career up to this very day. So thanks, Jim, and to Carly, my academic sister, and we shared Tom Accord as an advisor, and she's been an astounding role model for all of us in remote sensing and lunar and planetary science, and it's just so inspirational. And our relationship, I have a sister in real life the age of Carly, and so I'm well trained as a little brother, and I've gotten kind of down to a science the role of the annoying but adorable little brother. And Carly has told me that I'm halfway there with her too, so she's always so encouraging. And I can't fail to mention my office mate of 25 years, Jeff Taylor, who's given me abs of steel from laughing so hard every day for 25 years. And he's recently moved to Tucson, and we really miss him out in Hawaii, but we love seeing him on Zoom. I could go on and on about everyone else on the list, but I want to say a few words about Jean. So, Carly mentioned Jean was instrumental in formulating the Clementine mission, and I had the good luck of working with Jean on that. But there's a couple anecdotes I want to mention. So, several years after Clementine, we were at the LPSC. Used to have a chili cook-off, and I'm sitting with Jean. This is in the Shoemaker-Levy 9 era, when Jean had transitioned from doing planetary geology to astronomy, and with Caroline and Levy had discovered Shoemaker-Levy 9, and which ultimately impacted Jupiter. And Jean was just astounded at his good fortune, given his role in understanding impacts, and then to have discovered an object and then been able to witness an impact on a planetary surface. He just couldn't get over that. And I think what he was saying, what we all say, is we're living in this extraordinary time where, from when I was a little kid, I saw the first picture from the far side of the moon, saw the first picture from the surface of the moon, saw the boot prints on the moon, saw Jack jumping around as I was a teenager on the moon. One day to work with him, astounded. And first pictures of the surface of Mars, Titan, and we just live in this extraordinary time. And Jean really captured that for me. But there was one moment with Jean, and the memory may have dimmed the details, but we'd been in lunar orbit a couple of months with Clementine, getting ready to leave lunar orbit to go to the asteroid Geographus. And it was late at night. The scientists had a little cubicle, Warren, and I was in there by myself. And for reasons I don't know to this day, but for some reason it was very important to select the trajectory past the asteroid. And I don't know why it was so important at that moment. But anyway, so I'm sitting there typing away on Clementine data, and Jean comes in and says, "Paul, you got to come down to the conference room. We got something to do." So I trot after Jean. We get in there. And all I really remember is Jean, but I'm sure like the flyby manager, Tran was there. Maybe Trevor Sorensen was the orbital mission manager, and Don Horan and others. But my recollection is just the scientists, just me and Jean. Carly was back at Brown, and other people were other places. There's a big conference table, and Jean had a big piece at the back of a big line printer, and he had drawn a little peanut. There's the asteroid, and there were like trajectories past the asteroid. So Jean says, "Well, we gotta trade off the imaging, the needs of the imaging, the needs of photometry, and the thermal geophysics, it's an infrared camera. We got to trade these off." And so Jean asked me, said, Paul, what do you think? I said, "Well, I think we need Carly, and I think we need Bonnie Barati, and I think we need Bruce Jakosky." And he just looked at me. And Jean had a little bit of an edge. He just looked at me and said, "They aren't here. You're here. We need to decide now." Well, that when the equivalent of the PI is staring you in the eye and telling you you need to get to work, you get to work. And I'll never forget that. That was quite a moment for me. And you mid-career guys, late career, you're the head of Discovery Mission or whatever. Bring those kids into the room where it happens. Press them for their opinion. they'll never forget it. It could change their whole trajectory. So yeah, so that Jean was great. I guess in these kind of events, the recipient's supposed to, tell the story of their great discoveries and how they came about. And but I'm going to be a little different. I want to say a few words about some of my greatest failures. And my students and former students, you don't qualify for this list. You're astoundingly poorly equipped to be on a list of failures. Now I want to tell you about a couple of events that, yeah, at any rate, so picture this. It's, I'm in the rooftop penthouse of a Paris hotel. I'm sitting out on a little lanai, a little balcony, nothing above me but Paris sky, looking over the rooftops, glass of red wine. And Science Magazine had sent me 3 papers to review. And those papers were by Roger Clark and Carly Peters and her pals, and Jessica Sunshine and her pals. And these were the papers on the discovery of water on the moon. And what a privilege and a great experience it was to be able to read those papers. It was so exciting. But it was also bittersweet, because Ted Rausch at NASA Ames and I, 15 years before, we published a paper called "A Search for Water on the Moon at the Reiner Gamma Formation." Well, we had taken a very sensitive 3-micron spectrometer up to the moon, up to the NASA Infrared Telescope, took data in and around the Reiner Gamma Formation, all the parts, the dark lanes and the bright lanes and the red halo and all of that, looking for traces of water from try to work the comet hypothesis, but didn't see anything. But if we had looked closer to the terminator, been persistent and taken data, a few more observing runs, we would have probably discovered water on the moon in the mid 80s. And probably Ted and I, they probably would have given us a medal, maybe even a medal with a cash prize. Just saying. But that was a case where our dear departed B. Ray Hawk, when the science papers broke, he said, "Oh, Dr. Lucy, you and Dr. Rauch could have done this 15 years ago, but you weren't persistent." And I'll never forget that. You got to be persistent. Yeah, it was just a lack of vision that kept us from pushing through to that discovery. So I had another signal lack of vision. So I had the good fortune of Ben Bussey being a postdoc for me a few years ago. And I was there down in Ben's little apartment. It's kind of near my house in Hawaii. So we're talking, and I'm there, poking at the lone ice cube in the gin and tonic they poured for me. So I'm poking away at that. And Ben says, "Paul, I'm thinking of studying the lighting conditions at the lunar poles. I can model the illumination craters. I can tell what's permanent shadowed, percent illumination. I can do all of that." And so I poked at my ice cube a bit more and said to Ben, "Ben, that's a really dumb idea. I don't see the science. I don't see why anyone would care. This is just a dead end. I don't think you should do this." Well, of course, he didn't listen to me. Fortunately, got his fame and fortune started that way. In that same session, I explained to Ben that Wi-Fi was dumb. He had a printer set up next to his laptop connected by Wi-Fi. This is when Wi-Fi was new. And it was like, well, we have cables. What's the deal here? And then I started telling him why Skype is stupid, because why would we have telephones. Why would we ever want to talk to people on our laptops? It was just inconceivable to me. Another lack of vision on my part. So maybe a takeaway there is, if your advisor is me, maybe you should listen carefully what I say and maybe do the opposite. Now that's a role model. You just have to apply the lesson a little bit different. Well, anyway, so that was another failure of judgment there. But I have another case where I turned failure into success because I didn't want to let a friend down. So I have a whole parallel life as a DoD researcher in instrumentation. And all of you guys, well, anyone in remote sensing knows the name of Stephanie Tompkins. So Stephanie's brilliant thesis with Carly, where she studied the composition of the lunar crust by using central peaks as a probe of the crust, well known. But when Stephanie got her PhD, according to her own plan, she went back to the DoD to pursue, her passion about defending the country. And at one point, she became a program manager at DARPA, the Defense Advanced Research Projects Agency, and she was looking for technologies to apply hyperspectral imaging to military problems. So I went to Stephanie and I said, well, okay, Stephanie, I have this idea. I got a magic lens cap that any platoon leader with a thermal weapons sight, he puts on the magic lens cap, becomes a hyperspectral imager. He can see camouflage, he can see chemical weapons, poison gas, he can do it all. Everything we know we can do with hyperspectral, I can give you this with the magic lens cap. So Stephanie gives me a few $100K and I go back to Hawaii and work the problem. And it turned out the idea I had was just physically impossible. So it just turned out it was never going to work. But, I just, I felt really bad about that because I didn't want to have Stephanie go as a new DARPA PM into the meeting with the director and say, the project that I started with Hawaii was a bust. It can't work. I just couldn't do it. So I went back to the lab and did all kinds of crazy experiments. And Jeff Gillis was there. He was seeing me doing microscope slides on iPhones and doing all kinds of things. But anyway, I stumbled on an ancient technology, the phenomenon we all see in physics class called Newton's rings. Newton's rings, it's an interference phenomenon, strong color. And I realized that any phenomenon that has color, you can turn into a spectrometer. And so we built some prototypes and triumphantly went back to Stephanie and we had the magic lens cap. And since then, I've built almost 40 spectrometers using this technology. It's the one that's going in orbit next year. We're proposing it to other NASA missions. But the point there is that I had hitched my sense of success and failure to my responsibility to Stephanie as not just my program manager, but my friend. I was not going to let her down. Unlike the work with me and Ted, that was just us. We didn't, we didn't have that motivation, but that's a powerful motivator. So I carried this forward to our most recent discovery mission. I see the engineers on this mission. They're so full of hope, and they're depending on the scientists, depending on me to do well. And as scientists, we know that probability of selection is so low. But you don't want to be the elements of that selection that's lets the rest of the team down. So when NASA called, the NASA guy called, said, we're going to give you your scores. I was just, please, not another Cat 4. So category 4 is like an F, and I got one of those in 2000. I didn't want that to happen again. So NASA dude calls me up, says, are you ready? I'm ready. If you weren't selected, well, duh. That's rare. But I wanted to know my score. He said, well, it's a category 2. Well, okay, that's a B. And then I read the reviews, it's like a B+. So, I could face those engineers and we're going to put this mission in again. This time, Parvati Prem is going to have a little more editorial control of the proposal, and we're going to get a Cat 1 baby, maybe a selection, but we'll definitely get a Cat 1. The Goddard engineers, you know, they got an A. They were fantastic. So I guess I'll kind of wrap it up there. You know, I learned, you know, Jean, a little story about Jean is just like, be amazed at what we're doing. You got to be persistent. You know, if you got probe time, or telescope time, or field time, just don't waste it. Just, you can, like Tom used to say, collect the data, you can always throw it away later. Get the data in the can. And don't let your friends down. It's okay to hitch your success to their well-being, because that'll motivate you to succeed. And then finally, for those of you, many of you, I've got lots of students who suffer from this imposter syndrome thing. You know, I've got this thing here. This is the famous medal that Greg and the gang gave me. And here's that great quote. If I can get this thing, you can get this thing. Don't listen to that little voice. You are good, you're good enough, you can do it. So I want to thank the committee again, thank all my beautiful friends who are on that list, and all the other people who have supported me throughout my career. Thanks a lot.
Wow, Paul. That was amazing. I'm kind of choked up here. Anyway, you've left us with some pretty profound thoughts, and all I can say is you're just so deserving of this, and thank you for everything you've done all over the years.
Well, thank you, Greg. Very kind.
So next up is Christina, who is going to introduce the Corradini Award.
Thank you, Greg. And yes, thank you, Paul. That was really inspiring. All right. So I am going to, as Greg said, announce the SSERVI Angioletta Corradini Mid-Career Award. It is given annually to mid-career scientists for broad, lasting accomplishments related to SSERVI fields of interest. Angioletta Corradini was an Italian planetary scientist who has inspired astronomers around the world. And this year, I'm very pleased to announce that Dr. Timothy Glotch from Stony Brook University has been given this award. So thank you to Tim for all your work. I'm going to say a little bit more about you and then hand it over. Dr. Glotch is the professor of geosciences and associate dean for operations and facilities for the College of Arts and Sciences at Stony Brook University. He received his BA in astrogeophysics from Colgate University and his PhD in geological sciences from Arizona State University. He is a co-investigator for the Lunar Reconnaissance Orbiter, Diviner Lunar Radiometer and Instrument, and participating scientist on the OSIRIS-REx asteroid sample return mission. He combines terrestrial analog fieldwork, infrared remote sensing, and laboratory spectroscopy to better understand the composition of the crusts of the Moon, Mars, and small bodies. In addition to all that, Dr. Glotch has been a principal investigator for 2 SSERVI teams and has led an effort of over 50 researchers and students in using state-of-the-art laboratory theory and field techniques to further NASA's science and human exploration goals. He exemplifies the teachers, scholars through the integration of outstanding research and education. Even mid-career, he has already received numerous NASA Group Achievements Awards for his various missions, as well as the National Science Foundation's prestigious Faculty Early Career Development Program Award. He has authored or co-authored more than 40 publications and has served as associate editor for the JGR Planets. So I think you can all agree with me, he's most deserving of this year's Angioletta Corradini Mid-Career Award. And I'd like to once again congratulate Tim and welcome him to share some thoughts.
Thank you, Christina, very much. I appreciate it. It's okay if I share my screen? I prepared a few slides.
Sure thing. Ricky's got control of these, but he'll unshare first. There you go.
Awesome. Let's see here. Can find the right thing. So just confirm you can see my slides and hear me. Thank you, Christina, for that introduction. I really appreciate it. I'm really honored to receive this award. And it's especially gratifying to receive an award named after Angeletta Cordini, who's a gifted and really influential infrared planetary spectroscopist. As many of you know, infrared spectroscopy is a topic that's near and dear to my heart. It's comprised the better part of my career. So that's wonderful for me. I'm also really grateful to be in the company of the past award winners, Dr. Barbara Cohen, Dr. Jennifer Heldman, Dr. Harold Hiesinger, who are all scientists that I respect and admire a great deal. I want to start with some important thank yous. So first, my nominators, Dr. Kelsey Young, Dr. Scott McLennan, and Dr. Dyer. I'm really grateful for their guidance and belief in me over the years. I'd also like to thank the LRO spacecraft, or I guess, the scientists and engineers that have made it the cornerstone of the renaissance of lunar science in the last decade and have kept it going. LRO, and specifically the Diviner Lunar Radiometer experiment, completely changed the path of my career. And so thanks to Dave Page, the Diviner PI, for his continued support of me and my students over the last decade or so. Thanks also to SSERVI, which has been responsible for another major change in my career path. I think the RISE and RISE-2 teams, we've been able to contribute a lot towards NASA science and exploration goals for the moon and other airless bodies. And SSERVI has really made possible a lot of high risk, high reward science for me and students and co-Is on the team that otherwise might have had a hard time getting funded. So I'm really grateful, Greg, Christina, the rest of SSERVI Central for your support, as well as the support of previous director Von Pendleton and associate director Brad Bailey. And then finally, I want to thank my family, especially my wife, colleague, and scientific collaborator, Deanne Rogers. Her support and encouragement since the time we were grad students has been instrumental in whatever success I've had. So leading up to today, I've had a lot of privilege and help to get to where I am. I grew up in a really solid middle-class family with loving parents who encouraged all of my interests and were able to save enough to send me to a really good private university with minimal debt. At Colgate, I was able to interact with faculty who loved to teach, were my first research mentors. And through there, I was also able to secure outside researcherships with Bill Botke and Jim Bell, who many of you know. They both taught me a lot and would go on to advocate for me later in my career. But it's not lost on me that if my personal circumstances had been even a little bit different, that all those opportunities might not have been available to me. I want to focus just for a few minutes, though, on the wonderful fortune I had to work with three mentors who were incredibly important in my journey as a scientist, professor, and as a leader. My PhD advisor at ASU is Phil Christensen, seen here with me at the launch of the 2001 Mars Odyssey spacecraft. And look at all that hair I had. Good. Phil provided me a basic foundation in remote sensing and planetary science and gave me my first opportunities as a grad student to work on missions, sometimes being the first person to analyze new data, coming down from one of his infrared instruments he sent to Mars. And I can't describe what a thrill that type of opportunity is. He also gave me the freedom and encouragement to pursue my own ideas and taught me that better is often the enemy of good enough. And that's a mantra my own students often hear me repeat sometimes. After ASU, I worked with George Rossman, my postdoctoral advisor. He's as brilliant a mineral spectroscopist as there is. He's also one of the kindest people I've had the pleasure of knowing. And working with him gave me the skills and confidence I would need to start my own lab one day. So I do remember, though, being intimidated on my first day when I walked into his office. And for fun, I say for fun, he gave me the mineralogy final exam that he had just given his students while he sat and watched from across his desk. I think I got a C+. But apparently that was good enough because we immediately proceeded across the hall to his lab where he handed me a screwdriver and had me assist his lab tech, Liz Miura, in fixing his micro FTIR. So on day one with George, I learned the valuable lesson that you can't be afraid of your own equipment. And finally, there's Darby Dyer. Incredibly, I couldn't find a photo of us together, so you get this Photoshop tack job. I started collaborating with Darby early in my career at Stony Brook, and she immediately impressed upon me the value of careful laboratory mineralogical analyses, and importantly, making those results easily accessible to researchers worldwide. By the time I'm no longer a mid-career scientist, I hope I'll be known as Darby is as someone who's willing to do the dirty work of fundamental mineral spectroscopic measurements that benefit the Earth and planetary research communities. And I'll close this slide by saying that I've been extremely lucky to have Darby as the deputy PI for both the RISE and RISE 2 SSERVI teams. She's collaboration personified, and I've learned so much from her about teamwork, leadership, and how to make your text fit into limited proposal or paper space. So I encourage you, seriously, after this session, go read one or two of her papers because they're like poetry. It's crazy. Okay, so I think it's kind of become a tradition at these types of talks to offer unsolicited advice to members of the community. So I'm not going to pass up on that chance, but I'll keep it brief. And here it is. Say yes more than you say no. I've benefited a lot from saying yes in my career, and it's helped me to get to where I am now. And I mean this, though, in a lot of different ways. So say yes to collaborative efforts within your subdisciplines, but especially if your expertise can contribute to a cross-disciplinary team. This is where a lot of the fun and exciting science gets done. Say yes to paper and panel reviews. I learned so much from these, especially early in my career. And if you haven't been offered the opportunity, find the right editor, program manager, and volunteer. And there are probably editors and program managers who might be listening right now who I've said no to even recently, but just notice that this says say yes more than you say no, not always say yes. Say yes to public outreach and engagement. You could potentially find yourself on a children's TV game show with a caption under your name that appears to question your very professional identity. But most of the time, you'll be bringing the joy and fascination of our profession to members of the public, inspiring the next generation of scientists and explorers. I'll also say that if you, like me, are a cishet white male, it's especially important to say yes to responsibilities that are traditionally foisted upon women and people of color. This might include, but it's definitely not limited to, certain types of committee assignments, or leadership positions, university and community service activities, and especially EDIA work. If you're wondering how you can get started with some of this, try the SSERVI EDI focus group that's led wonderfully by Jay Greer. You can sign up at this website there. And I can say with confidence that erring on the side of generosity with my time for these types of efforts has never hurt. I'll close here by saying that I get that people have to protect their valuable time and we shouldn't really glorify overwork or long hours in the lab. I've reached a point in my career where I have a reasonable semblance of work-life balance with lots of time for my family, which I'm really grateful for. At the same time, there have been plenty of points in my career where I've had to sacrifice personal time to focus on professional efforts that are also important to me. So I'm sure there will be more of those, and I'll continue to say yes to them if I think they'll benefit me and my research group or my community. Okay, I'd like to use the rest of my time to talk about science and the incredible role that students and postdocs working with me have played in my own scientific development and in furthering the science that I'm personally interested in. And I'll focus here on work related to fundamental spectroscopy, airless bodies, and samples. But if any of my Mars-focused current or former students are listening, I love you guys too. I'm really proud of the work my students have done to develop tools and methods to calculate infrared optical constants over a wide wavelength range. Eli Skloot, who's now at PSI, has put together a HAPI code that uses visible near infrared measurements of minerals at lots of different phase angles and different grain sizes to calculate robust visible near-infrared optical constants. You can try the code here for yourself if you'd like. 3 other former students, Jessica Arnold, Chung Ye, and Melinda Rux, greatly advanced the state-of-the-art for modeling mid-infrared optical constants from oriented single crystals, which is the best way to do it. These include some of the first studies of geologically important minerals with monoclinic or triclinic symmetry, for which both the measurements and the modeling is complicated. I hope to expand upon this in coming years. Eli's recently received funding to do more optical constant work, and I'm working with her on that. And I'm actually going to be looking for a postdoc to help with this. And so if you know someone or you might be that person to help me out, let me know. Give me a call. Send me an email. The whole point of all of that effort we've put into developing methods for calculating optical constants over the last decade or so has been to enable more quantitative analyses of remote sensing data through the application of radiative transfer theory. Jesse Arnold started our work combining T-matrix light scattering methodologies with Hapke theory and other types of radiative transfer models. And Gen Ito, who's now a postdoc in France, picked up that work, 2 papers that demonstrated the application and also improved upon it by including a correction for densely packed regolith, like that's more realistic. That's kind of been an Achilles heel for Hapke, over the years. Earlier this week, you might have seen a talk by Vanessa Lowry, who's a grad student at University of Central Florida, where she used these methods to show that you can explain the infrared spectra of Trojan asteroids without the need for extremely low packing densities or transparent salt matrix, which are a couple ideas that have been floating around the literature for a little while. And it's been really gratifying to me to see others pick up and use these types of techniques for their own applications. Through our work and the work of many others on the Diviner team, including Ben Greenhagen, Carrie Dawson-Hanna, Ian Thomas, and Neil Bowles, we've come to understand that if we want to compare laboratory infrared emission measurements to actual thermal emission measurements of airless bodies, we need to do so in an appropriate environmental chamber. Catherine Shirley made a really tremendous contribution to our ability to do this with a systematic laboratory study of the effects of particle size on infrared spectra in a simulated lunar environment. And she saw trends that are nearly the opposite of what we see under ambient conditions. And so I think these types of data, these fundamental data, will be crucial for further analyses of Diviner data, as well as data from Lunar Trailblazer, and hopefully a hyperspectral mid-IR imager, which absolutely needs to be sent to the moon. I'll also note that a current grad student, Laura Breitenfeld, who I'm co-advising with Deanne Rogers, has used similar simulated asteroid environment spectra to build a training set for a machine learning model to quantitatively analyze OSIRIS-REx Otis data. So I think the successful demonstration of that technique will pave the way for similar models to be built for hyperspectral mid-IR data sets for airless bodies throughout the solar system. And that's something I'm really looking forward to and excited about. I've also made some advances in Raman analyses of Earth and planetary materials. My former postdoc, Mehmet Yesiltas, now professor at Kırklareli University in Turkey, working with 2 former students, Stephen Jarrett and Jordan Young, show that you can use confocal micro Raman instruments and measurements to understand relationships of minerals and organics in 3 dimensions at submicron spatial scales. These are just a couple examples here for class 2 shock basalt from Lunar crater and an ordinary contract meteorite. I think the perfection and application of this technique will be incredibly useful as we've entered the age of returned sample analyses. Trying to move on. Just got 2 slides left. A few years ago, I had a group of students, Stephen Jarrett, Melinda Rux, and Melissa Sims, who have all been interested in impacts and high pressure processes. And if you know me, this is not my scientific wheelhouse at all, but I was lucky enough to co-advise them with other faculty and scientists at Stony Brook and at Brookhaven National Lab. But their mutual interests led to some great collaborations and novel sample analyses and experiments. Melissa, who's now a postdoc at Johns Hopkins, uses synchrotron, X-ray techniques, and Raman spectroscopy to understand impact shock in minerals. She conducted a series of novel rapid compression experiments and analyzed samples in situ using X-ray diffraction. Her work showed that amorphization in plagioclase progresses over really wide pressure range rather than instantaneously. So suggesting that amorphization can be heterogeneous. And these experiments support the idea that amorphization pressures for plagioclase occur at lower pressures than are typically thought of. This has really big implications for our understanding of the pressure and temperature conditions experienced by rocks during meteor impact. Melinda was approaching kind of a similar set of questions from a very different angle. She's fascinated by analyses in the literature of the shock-induced high calcium mineral tisentite in extraterrestrial samples. And so she set about to synthesize it in order to better understand its formation conditions and its potential to place constraints on shock pressures and temperatures. Her experiments used a really novel spike heating protocol that could reach impact relevant temperatures within about a second and approximate the time temperature conditions in a post-shock melt. And her work established that heating for impact relevant timescales isn't really sufficient to completely transform plagioclase to this mineral tisentite. And so it instead forms from an amorphous plagioclase during decompression. So I want to end with some recent and I hope future work that I'm really excited about. I spent the last 5 years or so working with students and postdocs to try to better understand the capabilities of near-field infrared spectroscopy and imaging, or nano-IR techniques for analyses of Earth and planetary materials. We've certainly not been pioneers here, but we've recognized the potential of nano-IR to start addressing a whole different set of questions compared to standard laboratory infrared or remote sensing infrared techniques. Here, former postdoc Mehmet Yeşiltaş has, I think, emerged as a world leader in the application of this technique to carbonaceous chondrite and ordinary chondrite samples. At Stony Brook, Jordan Young, who just graduated, used nano-IR measurements to collect multispectral images and full spectra of this CM2 chondrite in preparation for analyses of eventual returned SARS-Rex samples. In the coming months, I'm really excited that we'll be bringing online a new instrument at Stony Brook that will enable us to do hyperspectral imaging of samples at 20 nanometer spatial scales. And SSERVI has been instrumental in the successful proposal and acquisition of that instrument. So this will, I hope, enable a new frontier in mineralogical analyses and organic analyses of meteorites, Apollo samples, and return samples. So I'll end here, again, with gratitude for everyone I mentioned, and also noting that there's so much great science I couldn't talk about, and that the young scientists I've mentioned have done, and I'm really grateful to have been a part of it. So thank you very much.
Thank you. Thank you very much. That was really nice to hear a little bit about your background as well as the research. And again, you're still putting your students forward. So thank you for that as well. Were you all able to hear me? I just had to unmute myself. Okay. I don't know what Zoom was asking me, but with that, I will congratulate Tim again and hand it back to Greg. So thanks, Tim.
Great. Tim, thank you so much for another inspiring talk. And I want to let people know, Tim alluded to this, but how much we're all familiar with his scientific contributions, which are profound. But he has been a very active leader in equity, diversity, and inclusion efforts. And Tim, I really want to thank you for that. There's nothing more important that we're doing, and your contributions have been profound in that as well. So thank you. So now I have the privilege to introduce the Michael Wargo Award. And before I do that, I'd like to play a video from Mike's widow, Adele Morissette, who I spoke to this last week and who agreed to record this. So Ricky, if you could play that, please. Thank you.
Good morning to you, and thank you, Greg Schmidt, and all of your colleagues who invited me to say a few words this morning. My name is Adele Morissette, and my late husband, Michael Wargo, looked forward to this annual NASA Exploration Science Forum with great enthusiasm. Next week marks the 50th anniversary of the launch of Apollo 15, which explored the moon's surface using a lunar roving vehicle for the first time. How far NASA has come since then. Even since 2013, when Michael was last with us, NASA has accomplished many achievements to be celebrated, including the commercialization of space. Michael would be very proud of all of you who continue the work of marrying science and exploration to continue to push the envelope of space and technology. Thank you again for this opportunity and enjoy the rest of the program.
And thank you, Adele, for addressing us. So the Michael J. Wargo Exploration Science Award is an annual award given to a scientist or engineer who significantly contributed to the integration of exploration and planetary science throughout their career. This is something that is core to SSERVI, of course. Dr. Wargo, who passed away sadly in 2013, was the chief exploration scientist for NASA's Human Exploration and Operations Mission Directorate, and was a strong advocate personally for the integration of science, engineering, and technology. The 2021 Michael J. Wargo Exploration Science Award is given to Dr. Darlene Lim, research scientist at the NASA Ames Research Center. Dr. Lim has spent over 25 years conducting field research programs around the world on land and underwater, where she's piloted submersibles as a scientist and explorer. She graduated from Queen's University and received her doctorate in geology from the University of Toronto, Canada. She's currently the deputy project scientist for the NASA Viper Lunar rover mission, and also leads several NASA-funded research programs focused on blending field science with new concepts of operation for human and robotic teams. She's the principal investigator of the Basalt, Subsea, and Pavilion Lake research programs, deputy PI for FINESS, and is highly involved with the resource SSERVI effort as well, and as the science ops lead. Her field science research programs are focused on developing human exploration tools, technologies, and concepts that serve to directly inform various NASA design reference missions. She's blending field science research and exploration concepts that will enable scientists and future human explorers of the Moon and Mars. She served on a number of NASA Mars Exploration Program Analysis Group committees and is currently serving on the NOAA Ocean Exploration Advisory Board and the NASA Network for Ocean World Steering Committee. We're very grateful that she is part of this program and has done all these things, and her efforts at integrating exploration and planetary science would make Mike Wargo proud. No one's more deserving of this award than Dr. Lim. Please. Darlene, go ahead.
Thank you, Greg. So I just want to say that I've been giving a lot of talks recently, but this one, my heart is going a million miles a minute. I'm gonna like keep Kleenex beside me so that I don't lose it. But I wrote everything down so that, because I had this inkling like this might be pretty emotional. And I just want to start off by saying thank you, Greg. You know, when Greg called me a couple of weeks ago, I was sitting at my tiny desk, the same one I'm tucked into right now. It's in the corner of my bedroom. I had just kind of barely juggled through a very long day. I was taking care of my kids. I had a flaky, home network. I have this dog that seems to know exactly when I press like unmute and makes a ton of noise. Doing all the things like we're all trying to do, take a break, drink water, stand up so our bodies don't take the shape of our desk chairs. It was just a messy day. And then, it's when, like I said, I think everyone on the line can empathize with. It's been such a tough year with loss in so many different forms. So when Greg called me up with the happy news, I was really completely and utterly overwhelmed. Kind of, the same types of feelings that I think Paul and Tim articulated. And his news, it really hit me like a lightning bolt, and all of the emotions of the pandemic absolutely flooded me. And I could only think, Greg, are you kidding? And I can't quite remember if I actually said thank you in the right way. So I am so grateful for, number one, getting a do-over, which is like, not a thing that all of us get all the time. So thank goodness for the do-over today. So I'd like to start off, first of all, by congratulating Paul, Tim, Shwai, and Parvati. And Paul and Tim, your talks were so thoughtful and so touching. And this is exactly why our community is so cool, everything that you guys said and then some. And next, thank you so much, Greg, for your kindness, your support and energy, and the much needed positivity at all turns. And thank you to my nominator, the selection committee, and to SSERVI. I am so very humbled and grateful to be in the company of the previous awardees. First of all, of course, its namesake, Michael Wargo, followed by Clive Neal and Dana Hurley, Lawrence Taylor, David Crane, Wenda Mendel, and most recently, Mark Robinson. This award and what it stands for, the spirit of it, is so very deeply meaningful to me. And I'm so touched to be a part of its legacy. And to NASA, which is my second family, truly my second family, and a huge part of the village that sustains me every day, I am so thankful. Through my time at NASA, I've had the privilege, truly the privilege, of being in service to the exploration and planetary science community alongside so many remarkable souls. There are just way too many names to name. And I do hope that I, show you all the respect and the love that you all deserve, because it's remarkable, just the joy that you bring every single day to life, not only for me, but so many. These people, they are relentlessly committed, they're passionate, they're humble, they're forgiving, and they're eternally curious and youthful in their perpetual optimism that there is a solution and there is an innovation that exists for every single problem, and that we can get there, even if that means sacrifice in so many forms. I have found that their optimism is never misplaced, and each of these remarkable colleagues continue to inspire at all turns. On the matter of these many people, there is an irony here in me being a singular winner of an integration award, because to me, the very matter of integration requires the relinquishment of individual desirements in the pursuit of innovation and fundamentally of the greater good. Working at the nexus of exploration and planetary science is, to me, an exercise in being deeply gratified with delayed gratification, and in knowing, truly knowing, that great work and goodwill are timeless. And integration, like blending families or cultures, it's very hard to do, but when it's done right, it is absolute magic. There's sort of a multiplying effect that is affecting in such a profound and indelible way. And in our science and exploration endeavors, this magic happens when an individual with some profound knowledge is transformed from being the gatekeeper of that knowledge into a facilitator of their knowledge. And at that moment, at that very moment where there is that transformation, there is truly an amplification and a multiplication of the intelligence and the capability around them. And this is the moment when sparks fly and when new connections, new ideas, and new opportunities are created. This magic provides a rush of unbridled motivation that can lead us to surmount any challenge. And I truly believe we need this magic more than ever right now in our lives, broadly in our country and the world over. Integration in our exploration and planetary sciences communities can and should be examined and challenged from within our teams, our projects, our missions, and it should be examined and challenged from without to ensure that we are leading change in our community in a way that represents a more cohesive and inclusive vision of where our society could be in the future. And while this award highlights the value of research and exploration integration, we must as a community also weave social, emotional, and ethical elements into our considerations and into our community's fabric as we engage in exciting new adventures, not only in space exploration, but moreover, as we tackle the many global challenges that will necessitate our current and forthcoming communities, those that are coming online, to innovate at a completely unprecedented rate. For me, integration is a necessity as a means to move forward from surviving to thriving. And on a personal note, it's a couple things I'd like to share. My family immigrated from Singapore, and I was born in Canada, where I straddled many worlds defined by, in some circumstances, how my parents grew up, what their expectations were, how they hoped my sister and I would grow up, and how society demanded that we grow up. So my sister and I, we had to spend a lot of time observing and understanding and integrating between all of these different forces to survive and then thrive very gratefully and innovate a new pathway and a new idea of life for ourselves. And that's brought me to here. It's brought me to the life that I have, to my new family. And I'm going to end with the following, which is that, like so many of you, I've spent the last 18 plus months locked down with my family, and every day, every aspect, each detail of our lives, whether it's school or sports, my work, my husband's work, health matters, everything, they have to coexist, they have to integrate, they have to mix and become something new. Everything is totally and absolutely intertwined. It's messy, right? But then there's such incredible clarity that comes with that mess too. And I was thinking about how even before the pandemic, as working parents and as kids with parents who work, our little family has had to absorb each other's lives and find ways to make it work for us as a whole. And that, to me, that's like the very core of integration. And so as a final thought, in case my kids and my husband are surfing the internet and procrastinating, I just wanted to say something to them. First of all, don't procrastinate for too long on the internet. And next, I am eternally grateful that I get to be embedded in your lives, and I love you so much. And thanks for being there and helping me over so many years to be part of this Wargo adventure. Thank you very much, Greg. Thank you to SSERVI and everybody for your time.
Thank you, Darlene. It's your words are very moving, as are your contributions. You're in so many ways, and I can tell you how much I value our friendship and having you as a colleague, but particularly our friendship. So thank you so much. Anyway, let's move on to the next award, and this is going to be, the first introduction is going to be given by Brian Day from SSERVI Central, and this is the Niebuhr, the Susan Mann Niebuhr Award. And I'd like to also note that I believe Kurt Niebuhr is watching right now. So hello, Kurt, and welcome. So Brian, please go ahead.
Thank you, Greg. The Susan Mann Niebuhr Early Career Award is an annual award given to an early career scientist who has made significant contributions to the science or exploration communities. Recipients of the Susan M. Niebuhr Early Career Award are researchers who are no more than 10 years from receiving their PhD, who have shown excellence in their field and demonstrated meaningful contributions to the science or exploration communities. Susan Mann Niebuhr was a former Discovery Program scientist at NASA who initiated the first ever Early Career Fellowship and the annual Early Career Workshop to help new planetary scientists break into the field. This year, the prize is jointly presented to Dr. Shuai Li and Dr. Parvati Prem. Dr. Shuai Li is an early career scientist who has already made significant, high-profile contributions to the science and exploration communities. Just a few examples include helping to reveal water content in lunar pyroclastic deposits, providing key insights into the formation of water on the moon's surface by studying abundances in magnetic anomalies, finding the first direct evidence of surface-exposed water ice in permanently shaded regions on the moon, and finding widespread hematite at high latitudes on the moon, identifying an apparently novel and very exciting formation process. His research not only appears frequently in prestigious peer-reviewed scientific journals, but has also captured the interest of the general public and has been picked from the journals for coverage by general media outlets, including ABC, BBC, CNN, the New York Times, and many more. As an assistant researcher at the Hawaii Institute of Geophysics and Planetology at the University of Hawaii at Manoa, and a member of SSERVI's ICE-50 team, his research focuses primarily on two different areas: studying water and its associated processes on airless, rocky bodies, and studying the non-icy components on icy bodies in the outer solar system. His research is helping to constrain and quantify lunar surface properties like the composition, retention, and distribution of water ice at spatial scales ranging from micrometers to kilometers, revealing surface processes possibly associated with solar wind implantation, impacting of meteorites, comets, and interplanetary dust, as well as interior degassing. His research on the distribution, variation, and origin of volatiles on the moon and asteroids is improving our understanding about solar wind, volatile delivering impacts, and magmatic and space weathering processes. As an early career scientist who is changing our views of the moon and the formation of the solar system, and changing those views from the perspectives of the planetary science community, the exploration community, and the general public, Dr. Shuai Li is certainly a very worthy and deserving recipient of this year's Susan M. Niebuhr Award. Congratulations, Dr. Li.
Thank you, Brian. Thank you for the so fruitful introduction. I was totally shocked, surprised, stunned as same as previous several awardees. It was like a few weeks ago. I was with my 4-year kid in lab, and suddenly Greg called me. I cannot believe it. Suddenly I feel like I was not forgotten by our community. Because we know, like scientists, we always do science like silently, quietly all the time, right? So suddenly you can feel the warmness from the community, give you, even stronger encouragement and power to work, to continue. So yeah, first I want to thank my nominators, even though I don't know who you are, and also I want to thank the committee of this award for awarding me, and also I want to thank the community, recognizing my work. Without the pause from all of you, I kind of make this achievement. Particularly my graduate school training at Brown University, and also the postdoc opportunity at Hawaii. So I really want to thank everyone for all these kind of supports. One mankind cannot achieve such achievement without support from people around you. So as Brian just introduced Dr. Susan Niebuhr, what she has done to the community, I was amazed, and I hope to contribute more about what she has done to the community, to encourage people, to help people, to inspire people to continue their exploration in planetary science. So I want to share some of my very limited science experience for our young fellows, particularly the senior graduate student and early postdocs. Hopefully you can get something from my experience, and hopefully you can get more products and more fruits from what you are doing or what you want to do. So can I share my screen? Okay. Oh yeah, great. Yeah, so I will jump the introduction part because that's what Brian has introduced already. Like I said, I want to introduce some of my very limited experience with our senior graduate students of early postdocs. So based on my experience from graduate school to now, like 5 years after a PhD, I feel time in the last 2 or 3 years of 1 year graduate school and first 1 year or 2 year postdoc time, the time is relatively sufficient in comparison to as you become senior and senior in a career, because you're going to make more commitment to a service, not only research. So I would say if you can try to pick 1 or 2 projects, like high risk and a high return project to do. At this point, I want to say, like as Paul and Tim and Darlene mentioned, encouragement at this time is particularly important, because as a early career or like a senior graduate student, you do not have much experience in research. So it's like, you definitely need encouragement from people from you. But at the meantime, I also encourage you to trust your own scientific intuition and also your own innovation, because sometimes, like, you are the experts in your field, and sometimes people around you cannot understand what you really want to do. So you have to trust yourself. Trust yourself. Sometimes you don't have enough support, but you have to trust your scientific intuition, so you can gather more and more evidence for what you want to do, and also trust your own vision. And you may want to take the risk to try, because as I said, this time could be the most sufficient period. Time is relatively sufficient at this period. Otherwise, when you pass this period, you may not have enough time to do what you want to do. But even though you have a high risk to fail, you will gain more or less. So trust me. So yeah, so take the risk to try, trust yourself, and eventually you will gain more or less. So I have two examples about my research to share. The first one is about the discovery of surface exposed ice on the moon. So first, after my thesis preparation, I have some free time to do research myself. And at that time, I feel like, I don't want to waste the time. So I just pick up a topic that interests me. Well, this is inspired related to my PhD thesis. I want to know whether there is ice on the moon. And then, they pick up a topic, and then you can review literatures. So this is like reviewing those literatures will give you confidence to what you want to do. So like, then I also help you to assess like major unsolved problems. So for example, for my case, like, I just read roughly like 400 papers. And finally, I did a summary of the table. You don't have to go through it in detail, but the short sentence is like, any surface exposed water ice in lunar PSRs where the temperature is cold enough. So from all the paper I've read, it tells me yes, probably, or sometimes even no. So like it's not a confirmative answer. You cannot get it from it. So that's the problem. That's the question you want to address. And I want to address at that time. And then I choose, or you want to choose approach or data sets or experiments to solve your problem. So for me, I choose, at that time, I have the data set in my hand, like the moon mineralogy mapper data, because it measures reflectance and also scatter light from PSRs in the spectral range from 0.4 to 3 micron region. And as we all know, water ice showing very diagnostic absorption features at the visible to near region, as I showed in the left plot. The black curve, this is the global average M-cube spectrum. You can see it's redden. It's relatively featureless, maybe very weak 1 or 2 micron absorption feature. And 3 micron feature is due to hydroxyl. And the blue curve is the pure water ice. You can see these features. It's very unique diagnostic compared with the typical background. So then I decided to use this tool to search for ice on the moon. And it turns out the spectra in PSRs are totally different. You can see from this movie, I collect some data. You can see it's quite very noisy actually. It's almost like a random noise. But I didn't quit. As I said, at that time I have some time and I want to do something. And also, I really want to know the data set, how the instrument performs in the PSR, like very dark regions. And I checked this kind of data for 4 months. I'm not sure you can believe it or not. I'm not sure Carly still remember. It's a great fortune to work with the PI of the instrument in the same institute. So at that time, I sent tons of emails to Carly to ask her, like, what do you think of this spectrum? All weird spectra to her. And I almost got the same answer, artifact. So like she sent me back tons of emails saying artifact, but I didn't forget. I didn't quit, and until I found something I showing on the red figure. It's like, even though it's noisy, but you can see the trend, and in comparison to the pure eyes. So the dashed line is kind of smooth or average. You can see like the trend follows this well. And when I sent this figure to my postdoc advisor, Paul Lucy, I think he was shocked too. I still remember the email he sent back. So, but you know, this is not enough to convince, still not enough to convince a lot of people. Like, you know, even though I saw this kind of patterns tons of times, but a lot of people still were not convinced until I got this figure. This is like all pixels put together. So like raw data without any processing. And then in comparison to pure water ice, this looks like, you know, almost identical. And then suddenly like all my co-authors and people around me, they were convinced, and then came out of this work. Yeah, so I agree with what Paul Lucy said. You know, you want to insist what do you want to do, and you should trust yourself. And even though, you know, you cannot find anything, like I have a friend, he told me, hey, examine white noise for like a few years. But at least, you know the data. After your work, you know the data. You know how to identify white noise. At least, you know, after you spend much time, so you will gain more or less, even though it's high risk. Another example is I want to advise our young fellows, like you want to be sensitive to your data and or your approach or experiments. So for my case, it's like, you know, my data. You wanted to record or frequently revisit the anomalies. So I mean, the anomalies is something that doesn't make sense to you. So you don't have to know the answer at the beginning, but you wanted to record and frequently revisit those anomalies, because as we know, new discoveries are commonly associated with anomalies. And this is one example. So this is the M-cube spectrum. This is one spectrum raw data from the polar region. When I saw this spectrum, I feel it doesn't make sense to me. I'm not sure any like a lunar spectroscopy can tell, like, you know, why this doesn't make sense. I want to, you know, point you to these two bands, like two features, because normally we don't see this feature. And for this feature is normally near 1 micron, but this is too short. And also you can see the strong suppression in the visible part. So as a spectroscopist, you can tell immediately there could be like indicating like a strong charge transfer. So, you know, at that time I don't know what's going on, but you know, I often revisit what this data and I compare it with like a global average. It doesn't match for sure, right? Because as I said, it's anomalous to me. It doesn't make sense. And then I compare it with for sure it's not mineral. We know it's not like a typical pyroxene, olivine, or plagioclase. And then I compare with the glassy components. So you can see it also doesn't match either. I feel okay, there must be something new, because it doesn't match with other, you know, the animators we know on the lunar surface, until I compare with the pure hemidata spectra in the database, as the blue curve shows. And after continuum removal, you can see the feature that almost identical, match very well. So it's indicated the presence of hematite. And then we came out of this hypothesis about the hematite formation. So when the moon was in the Earth magnetotail, the magnetotail helped the moon shield tons of over 99% of the hydrogen. But at meantime, the solar wind can blow oxygen from the Earth's atmosphere onto the lunar surface. So it's provide a relatively oxidizing environment to oxidize iron on the lunar surface. It's still a hypothesis. I will need more work to demonstrate. Yeah, so that's my two experience. So hopefully you can, you know, get some inspiration from it. Well, very limited, so I have to share more. But you know, if you have any questions, please contact me. And I wish you best luck to your adventures in science exploration. That's it. Thank you.
Thank you so much, Wai. And wow, you have an amazing career ahead of you. It's it's just such a privilege getting to work with you through SSERVI. So thank you so much. and congratulations. So,
Thank you, Greg.
So the next and last talk of this session in awardee I'd like to introduce right now, and that's Dr. Parvathy Prem for the Susan Mahan-Niebuhr Award, the second awardee. Parvathy has done a lot of things in her still relatively short career. First of all, as you all know, she served as the SOC co-chair this year, and I'll be mentioning her contributions when I do thank yous later. But she really, she and Carolyn both really, I think, rewrote the rule book on how great SOC chairs can be. She's a science team member of NASA's LRO mission and SEAL payload. She's co-investigator on 2 SSERVI teams, both LEADER and ICE-5O. And her research focuses on applying computational methods to study solar system bodies and their interactions with the space environment. Her current investigations include modeling the origin and transport of volatiles on the moon, and developing radiative transfer models to aid in the interpretation of remote sensing data at radar, IR, and optical wavelengths. Her modeling is helping us gain a better understanding of how comet impacts on the moon could have delivered water and other volatiles to cold, permanently shadowed craters near the lunar poles. And she also serves as the lead of the Friends of Lunar Volatiles focus group for SSERVI, which is one of our very active focus groups. And on a personal note, we had a chance to get to know Parvathy well when she was spending a lot of time at SSERVI Central. She was still working at APL, but she was doing this when her husband was at Google. So, and then lastly, I really want to mention her efforts in equity, diversity, and inclusion. She is really a community leader in that, and this is something that I personally and a lot of us really appreciate. So, Parvathy, please take it away. Congratulations.
Thanks so much, Greg. Let me share my screen. Does that look okay?
It does.
All right. Well, good afternoon, good morning, good evening, everyone. It really means more than I can adequately express how much it means to win an award like this. It's an honor to share the limelight with Shuai, who is one of the finest scientists I know. I have an amazing mission concept, which involves sending Shuai to the South Pole to just wander around with a spectrometer. Definitely category 1, Paul. It's also a tremendous honor to receive an award that's named after Dr. Susan Mahan-Niebuhr. I never had the pleasure of meeting Dr. Niebuhr in person, but I do know that she was an incredible person and that she is much missed. When I first read the words of Susan's that are on this slide, I was so struck by just how precisely someone else could express what it is that I wanted to be in my professional life. And one of my main motivations for writing a dissertation was so that I could start it with these words of hers, that all that survives after our death are publications and people. So look carefully after the words you write, the thoughts and publications you create, and how you love others, for these are the only things that will remain. It's been a tougher year than most for most of us, and I know enough of you well enough to know that many of the best people that I know sometimes feel rather inadequate. And I think the power of Susan's words is that they remind us of what's really important, which is that there are times when people, including yourself, will try to measure your worth by metrics that don't matter. The only thing that matters is that we do our work with integrity and that we take care of the people around us. And as long as we do those things, it will always be enough, and none of us will ever be inadequate. I wanted to spend a slide talking about some of my many, many people. I have the incredible privilege of being able to open up the participants list, go down and tell each of you how you've influenced my life. But in the interest of time, I'm not going to do that. Wouldn't look good as SOSD chair and everything. In the center there are my parents and my tiny little brother. On the right is my favorite and only husband with one of our cats. They are the center of my universe, and I wouldn't be anywhere without them. I would not have got my PhD if I hadn't had the best advisors that I think anyone could have had. Philip Varghese is the taller gentleman, and Dr. David Goldstein is on the other side of me in that photo. Not in this photo is Dr. Larry Trapton, who was my third excellent advisor. Grad school was incredibly tough on me, and I wanted to quit several times. The only person who told me in no uncertain terms not to quit was David Goldstein. And I'm so glad I listened to him. And, you know, words fail me when it comes to thanking David, so I'm not going to try. I didn't get most of the postdoc positions that I applied to. In fact, I only got one, and that turned out, again, to be the best that anyone could possibly have had. Ben Greenhagen, Dana Hurley, and Wes Patterson gave me a chance that I didn't think I'd get. They hired me to work in the Planetary Exploration Group at APL, which consists of the best colleagues that anyone could possibly have. They are exceptional scientists, and they are incredible people. And APL is an institution that really and truly values its people and acts out that belief. I could give a whole other talk about SSERVI, which has been a fixture in my life since I attended my first Lunar Science Forum in 2011. But the only thing I will say is this, that it is not a small thing. And I say this to Yvonne and Greg and all the rest of the team. It is not a small thing to have built an institution that contains just so much warmth that I think all of us who come into contact with SSERVI come out of it being kinder people and better scientists. And what a great thing that is. LRO launched about a year before I started my PhD. I never in my wildest dreams thought that I would get to be part of the LRO team. And as far as I'm concerned, this will always be the most incredible mission to go anywhere in the solar system. So much thanks to John and Noah and all the rest of that incredibly large and incredibly awesome team. Lunar volatiles are the lens through which I got to know the moon and the rest of the solar system. And so I wanted to spend the next few slides giving you a big picture overview of lunar volatiles. The story of volatiles is really the story of the moon itself and of the Earth-Moon system. We know that volatiles were present in some shape or form when the moon formed around 4.5 billion years ago, and the nature of that primordial water and other volatiles remains the subject of ongoing, interesting, very active research. Over the next few billions of years, when the oceans formed on Earth and life began to take hold in those oceans, the moon and its neighbor, our own planet, were bombarded by asteroids and comets, some of which delivered volatiles to the surface. Between around 3.8 to 1 billion years ago, mare volcanism set the lunar surface all aglow. Those eruptions carried water and other volatiles from the interior to the surface. And I think one of the most exciting mysteries that we will likely learn more about in the years to come is what happened to those volatiles and what traces of them remain behind. And even today, by the time we get to the dinosaurs and all the way to today, the lunar surface appears to be relatively quiet, but the volatile cycle is dynamic and it's constantly active. Micrometeoroid impacts send little bursts of water vapor into the exosphere where we can sniff them with our mass spectrometers. And then there's that incredible magic that takes place with solar wind bombardment. It never ceases to amaze me that sunshine falling on rock can create H2O. It's magic as much as it is chemistry. Around 1 or 2 weeks into my PhD, I was seriously worried that all the science seemed to have been done. I'd been reading a whole lot of papers, and I was worried that there wasn't really anything left for me to do. And so in case anyone else is in the same boat, I want to reassure you that there are so many mysteries left to investigate, and there are so many ways to do that. And so whether you want to build instruments, analyze data, build models, run experiments, there is space in the science of lunar volatiles for all these ways of doing science and for all of you. So pick your question, pick your method of choice, and I can't wait to hear what you find out. I majored in aerospace engineering with a focus on aerothermodynamics and fluid mechanics. And so it might seem like a strange career choice to spend most of my time studying worlds that have exceptionally thin atmospheres, but it does make sense, at least to me. Some of the most interesting atmospheres in the solar system are those that are barely there. What drew me to gas dynamics and thermodynamics was really just the things that molecules in motion could do. And to see what molecules in motion can do and how they can shape the worlds that they inhabit, all you have to do is look all around you across the entire solar system. You can characterize solar system atmospheres in terms of their mean free path, which is the average distance that two molecules travel before they collide. On our beautiful home planet, that distance is on the order of 100 nanometers. It's even smaller on Titan, which of course has a thicker atmosphere. And then we have Mars, Triton, coming back in a little bit, Io, Callisto, and then we have our moon, which is our closest example of the thinnest and most tenuous class of atmosphere in the solar system, which is the surface-bounded exosphere. But the really fascinating thing about the moon is that at various times in its past, it's traveled along this continuum. There were times in the past, there may have been times when the lunar atmosphere looked more like that of Io, Jupiter's volcanic moon. And so one of the science questions that's the closest to my heart and the one that I hope to be working on for several years to come is that of how the lunar atmosphere has changed over time and how that history is preserved. And critical to that is understanding how the contemporary lunar volatile cycle operates. Science to me is ultimately about storytelling, and it made me so happy to hear that message come across again and again in one of the sessions this morning. It's critically important that the stories we tell include everyone and speak to everyone. And I think we don't always do that. When we talk about space, when we talk about space exploration, sometimes the stories we tell about those things don't include everyone and they don't speak to everyone. We have to be better about that. Discovery and adventure don't always have to mean conquest and colonization. That's not a new idea. There are people among those that we share this planet with who have lessons learned over thousands of years in how to inhabit new worlds and live with them rather than subjugating the land, and in how to voyage in a way that respects relationships with the land, the sea, and each other rather than bringing oppression. There are communities that carry on those traditions. For example, the Polynesian Voyaging Society, from whose website I borrowed this photograph of a crew member on the Hokulea voyaging canoe, navigating by the light of the stars, which are still visible despite the bright quarter moon that you see here. It's also important to me personally to do my science with a sense of place. This concept of a sense of place refers to the intrinsic characteristics of a place, but also the meaning that people give to it. And it's a concept that brings with it a question, which is that of how do we choose to relate to worlds beyond our own? And this is something we're constantly doing as planetary scientists. We do a job in which we do a job that consists of building relationships with places, learning to understand their stories, sometimes visiting them. And I wanted to tell you a story of two unique microenvironments on two neighboring worlds, each of which has so-called resource potential, but also stories of their own to tell. The Serpentine Barrens are not too far from where I live in Maryland on Piscataway and Susquehannock homelands. And they're called the Barrens because, of course, when the European colonialists arrived, they saw this land, they tried to grow timber in the soil, which is extraordinarily manganese rich. There's chromite ore, that's the resource. But they found that the timber wouldn't grow in that soil. And so they called this land a barren. But of course, if you look at it, you'll see that it is anything but barren. It is this incredibly rich grassland. And that strange singular soil means that you have wildflowers that grow nowhere else. And you have the entire ecosystem that sustains. It's an intensely alive environment. And I think another environment that is just as intensely alive, though in a very different way, is the microenvironment of the lunar poles. What gives this environment its life is the ebb and flow of shadows over that terrain that's soft and sharp at the same time, punctuated by the intermittent patter of micrometeoroids, and then in the shadows and in the sunlight, radiation and electricity build fairy castles out of dust. It's beautiful. And there is nowhere like this in the solar system. And so I think the lunar polar microenvironment, in fact, the lunar environment as a whole, has so much more meaning and so much more value, so much more worth than the value that it might have for commerce or for science. I think it's just as incredible and important a part of our collective heritage as anything we could put together with our minds or our hands. This is me in another place that's close to my heart. This is the beach near where I grew up. It's a vanishing beach as the sea levels rise, but it's a lovely one still. I grew up in Kerala, which is on the southwest tip of India, right here. I spent some of my childhood in England, came back to India for middle school and high school, went to Singapore for undergrad, traveled all the way to Texas for grad school, beautiful Texas, which is Austin, Texas, the city that I've lived in for the longest. We moved around a lot when I was a kid, and I can tell you firsthand that the stars at night really are big and bright in Texas. And then I came to Maryland, where I live and work now. And I've lived on Turtle Island long enough that I identify to some extent as Asian American. And I think what that means to me was best expressed by Professor Daryl Maeda, who pointed out that Asian American doesn't so much describe our personal identities or our family histories, in as much as it expresses an idea. And that idea is that as Asian Americans, we have to work together to fight for social justice and equality, not only for ourselves, but for all the people around us. That is what Asian American means to me. And I wanted to leave you with this. I love my job, I really do. I love sitting in front of my computer, writing code, writing words, even though I do that slowly, working with all the amazing people that I work with. But that is not my real job. My real job was expressed by the incomparable Professor Toni Morrison, who told us what she told her students, that when you get these jobs that you have been so brilliantly trained for, and all of us here have been brilliantly trained for our jobs, just remember that your real job is that if you are free, you need to free somebody else. If you have some power, then your job is to empower somebody else. That's the realest part of my job, and I hope to continue doing that and everything else to the best of my ability with all of you for as long as I possibly can. Thank you all so much for listening.
Thank you so much, Parvati, for yet another incredibly inspiring talk. And per your last point, I wanted to note that Elizabeth Fisher put something in chat and said what a role model you have been to her. And you're making lunar science a fun and inspiring place. So you're doing exactly what Toni said. So already. So thank you so much for all you've done and all you're continuing to do. And it's just such a privilege to work together and to have you as part of SSERVI. So thank you. I'd like to now have our group photo, and then we will go ahead with the final two talks of this forum. So if I could ask all of the awardees to turn their video on, and I'd like to invite Carly and Brian and Christina as well. And then Ricky, if you could get us all together using your magic, that'd be great. And Tim, I know you're you're on the way to pick up kids, so thank you for hanging on. Christina, are you?
I am here.
Great, very good, very good. Okay, so Ricky, whenever you are ready.
Did I get everybody? I just want to make sure I'm not missing anyone.
And let's see.
We are missing somebody.
Yeah, Tim is that.
Oh,
Tim is.
Wait, I got. Here I come.
Yeah, I think
There we
that's.
go. Yeah.
I think
Okay,
that's everyone.
3, 1, 2, 3. Great, thank you. Got it.
Awesome. Thank you all so much, and congratulations. So I'd like to ask Mahesh to join me. Mahesh and I are co-chairing the final session of this year's meeting, and Mahesh is going to be introducing the first of our two final session speakers.
Thank you very much, Craig. Can you hear me?
Yes.
Okay, yeah, great. Wow, what a tough act to follow. Yeah, fantastic session that was. Sadly, we are approaching the end of the meeting, but don't go yet. I think you have two wonderful presentations coming your way. Will certainly, leave you with such deep thoughts. I hope that you will ever remember this meeting. So Jim, are you ready?
Let's see, I am ready, but somebody has to stop screen sharing so I can start screen sharing.
Okay, so when we as an organizing committee were actually discussing how should we actually end this conference, we decided that actually we would like to hear from a couple of speakers about things that we have learned in the past and looking towards the future, something that actually leaves us with a lot of inspirational thoughts, and we couldn't have been luckier to end up with Jim and Lindy. So I'm going to introduce Jim, who is going to be talking to us about the Apollo, celebrating the past and inspiring the future. And Jim, you have 15 minutes. I will try to give you a reminder at just 5 minutes before finish time, if that's okay.
No problem. Thank you very much.
Okay,
so it's a great pleasure to be here. And I think, congratulations to all the awardees. It's so great to see not only the people who have accomplished so many things to be rewarded, but also the younger generation as we move into the future, which is indeed with Artemis and beyond. So we're in the middle of celebrating the 50th anniversary of the Apollo program. And this is really incredible when you think about it, that we have, it's been 50 years since we made all those incredible accomplishments. I'm a great fan of Mark Twain's, who is purported to have said, history doesn't repeat itself, but it rhymes. So obviously we're not going to do the same thing again, but what lessons can we learn from this as we go forward to the moon and on to Mars together with Artemis and beyond? So really, it's interesting to go back and think about what we knew pre-1959, prior to the time of the interest in the moon and the human exploration program. What do we know and what didn't we know? Well, we didn't know much of anything, actually. We didn't know its origin, its age, whether it formed hot or cold, what actually the nature of the surface was. Were we going to sink in when we landed and disappear in the dust, as Tommy Gold thought? We didn't know the nature of the Mariana Terra, the age of the surface, or the origin of craters even. We didn't even know whether these were impact or volcanic, hotly debated at the time. But when you really think about it, we didn't even know what the other half of the moon looked like. Think about that a second. I mean, really incredible what we've learned in the last 50 or 60 years. So what is the legacy of the Apollo program? What can we learn from this? What lessons can we carry forward that rhyme and that can help us in the future? Well, first of all, we got an incredible legacy. We have fundamental insight. If you look at the history of the planets as a clock, the Earth only reveals really well the last 10 to 20% of its history, but the moon and other planets really have unlocked the history of Earth's missing period. And also we learned that from the Apollo program that the moon actually formed from a Mars-sized impact into the Earth. So this is really pretty amazing, and it's a fundamental, the moon and the Apollo program results and the legacy is the cornerstone of our understanding of the rest of the solar system and even exoplanets. So I arrived at NASA headquarters in early October of 1968. I hadn't finished my PhD thesis. I had to write it at night, but I started working immediately on the Apollo program, and I worked on all of these missions from Apollo 7 to 17. Now, there were 11 Apollo missions in 4 years and 3 months. Think about that pace, and I shudder when I think back about it. How the hell did we do that? I really don't remember, but we did it, okay. So what were the missions? We had 4 precursor missions prior to Apollo 11, and then we had 4 missions, 11, 12, 13, and 14, which really set the stage. We learned how to explore the moon. And then the last 3 missions, 15, 16, and 17, were scientific expeditions to the moon. Absolutely scientific expeditions to the moon in both surface exploration and orbital exploration. So that's one of the lessons here that I think we all need to learn about the evolutionary aspects. So science and engineering goals to enhance science exploration return. A key lesson from Apollo is in fact science and engineers working shoulder to shoulder every day. I worked every day with engineers, and these engineers were interested in helping us accomplish our scientific objectives, and they really enabled us to make our scientific dreams a reality. Every mission. The first mission, we landed safely on Apollo 11, deployed experiments, collected rocks and soils. On 12 through 14, we increased stay time on the lunar surface. We increased the number of EVA periods to 2. Alan Bean, Pete Conrad demonstrated pinpoint landing right next to the Surveyor 3 spacecraft, which opened up the rest of the moon to our exploration, provide equipment for transport of tools and samples on Apollo 14. And then we come to the first scientific expeditions to the moon, which all of these things enabled us to do. Without these 4 missions, we never would have been able to do this. Each time, the engineers helped us to get better and better and better. So the first scientific expedition to the moon, we enabled orbital plane change to access high latitudes. We increased the number of EVA periods to 3. We provided mobility to reach distant targets. And as you know from Jack Schmidt, synogeologist as a member of the surface crew, we actually had plans to send roving vehicles from one landing site to the next in between the missions. Lots and lots of activities. So let's take a quick look at the first scientific expedition to the moon of the J missions, the Apollo 15 missions. This was 6 months after Apollo 14, and it was targeted to the Embrian Basin and the Hadley Sinuous Rill at the edge of the Embrian Basin. Now, one of the first things that had to be done is to get to there outside of the free return zone, so to speak, and the ascent and easy rendezvous with the lunar module and command module, we had to change the plane. This is not trivial. All of a sudden, it's not easy to lift off here and rendezvous with the command module. So that's a really major accomplishment. Not only that, we're at the edge of the Apennine Mountains. We had 5 different goals and objectives: Embrium Impact Basin ejecta, the deep ejecta, Embrium Mare Plains, were they impact melt, were they volcanic, how old were they, how did they compare? Hadley Rill, what is its origin? Was it a river as originally thought? The North Complex, source vents, construction like Marius Hills, and secondary crater clusters. How can we date craters from other regions which threw ejecta into these areas? 5 complex goals and objectives. Now, to get to these, we had to land between Mount Hadley and Hadley Delta and the Sinuous Rill. Well, you know, that was a little complicated because in order to do that, the astronauts had to do a very steep descent, steeper than any one they'd done on previous Apollo missions. Dave Scott, the commander of the mission, said, okay, we'll do a couple of simulations on that. Went into the flight simulator, ran a few simulations for a steep descent and said, we can do that. Good to go on that site. That's where we went. So these were 14,000 foot high mountains, Hadley Rille 900 feet deep. I mean, this is not trivial here. We also needed mobility to get to these goals and objectives. Astronaut operated lunar roving vehicle. The idea of having a car on the moon. What a concept. Okay, how did that happen? Well, science and engineering synergism. Really, really incredible engineering at Huntsville and other NASA centers, et cetera, really incredibly came through with this. Believe it or not, a lunar roving vehicle on the moon operated flawlessly on all 3 of the J missions. And even, believe it or not, we landed on Apollo 15 and 20-meter resolution images because we were confident. We knew what the Mare looked like. This is where we wanted to go. Dave could do it. And indeed, we landed at 20-meter resolution images. I mean, you know, that sends palpitations into the heart of Matt Gollenbeck and anybody else who's planning planetary missions. I mean, it's like, what? 20-meter resolution? That's like about 4 times the size of the width of the lunar module. Nonetheless, the engineers were confident. They wanted to achieve the science goals, and that's what was done. And of course, the roving vehicle was absolutely incredible. Here's Dave Scott mounted up with the geological field maps, this traverse maps here, ready to go, anxious to have Jim get back in, Jim Irwin get in, and off for the exploration. And they did one stand-up EVA. What's a stand-up EVA? Before they left the lunar module, they opened the hatch on the top, got suited up first, of course, opened the hatch on the top, and Dave stood on the top and looked around to see, as a geologist would do, what the lay of the land was. And why was that? Because we had 20-meter resolution images. You couldn't see any boulders. We thought they were there in certain places. Dave described them, and that helped us plan the next 3 EVAs. They got a 7-kilometer radius from the lunar module, total traverse of over 30 kilometers, in an excess of 75 kilograms of rocks and soils. And of course, everyone knows all the details of the Apollo 15, the first scientific expedition to the moon. Genesis rock. Dave spotted plagioclase twinning from about 6 meters away. He says, Houston, I think we found what we came for. He recognized that. Gary Lofgren had showed him detailed field blocks of plagioclase and anorthosites, and Dave recognized that plagioclase twinning, for crying out loud. He also discovered, listen to the transcripts, Dave is, Houston, there's glass, there's green glass, it's incredible. This green glass, of course, almost 40 years later in our lab at Brown, Alberto Saul, in fact, discovered water in the glass beads, which revolutionized our thinking about the moon and revolutionized our thinking about how the moon formed. It didn't dry out, the impact didn't dry out all the ejecta, but something else had to be the case. Maybe multiple impacts, maybe a lateral cloud. Lots of interesting discussions about that. And of course, rock layering and outcrops in Hadley Rille. You can see Jim Irwin here sampling the rocks at the edge of the rill here. And indeed, we could get, with a 500 millimeter lens, describe the sequence here and help understand the geology of thermal erosion and the formation of Hadley Rille, indeed. And on the way back from one of the EVAs, Dave Scott, Houston is saying, Apollo 15, time to get back to the rover, getting low on oxygen, et cetera, et cetera. Yeah, we're on it. We're on our way back. And Dave spots this vesicular basalt just sitting there all by himself. And we had talked a lot about volatiles on the moon and why it was so important to sample the volatiles. You know, what are they? You know, could they be water? Could it be what? We don't know. Dave spotted this, said to Houston, Houston, I'm having a problem with my seatbelt. I need to get off and fix it. Oh yeah, it can't be. Yeah, remember, you got to get back to the lunar module, but fix the seatbelt. Dave got off, fixed the seatbelt, well, picked up the rock, which is now known affectionately as a seatbelt basalt, and brought it back. And it's been an amazing set of discoveries associated with that as well. So there's what Dave calls the commander's prerogative. He wasn't disobeying mission control, but the commander has the local prerogative. So again, this really was critically important for the evolution of scientific expedition to the moon on the surface, and in the other J missions as well. And this is what we need to think about when we're talking about Artemis 2. We need mobility and we need sample return in excess of tens to hundreds of kilometers. So to pass this prologue, let's talk a little bit about forward to the moon and on to Mars. Clearly, as I mentioned, scientific synergism is the key. I see not enough of this at the present time. Find the engineers, get shoulder to shoulder with them, tell them your dreams, ask them how you can accomplish it. The Apollo approach, evolutionary, every step of the way. Mobility, human robotic partnerships. This is really the road to success, okay? People don't know that there were 21 robotic missions prior to Neil Armstrong setting foot on the moon. 21, okay? And they can be really incredible precursors, postcursors, scouts, etc. And it's critically important for human robotic partnerships to be developed in the future. We have some lessons from 50 years of human robotic exploration. One of them is that we really know how to do robotic exploration now with all our Mars exploration, and we've honed that to a fine art, so to speak. The bad news is that we're dealing with humans here, but that's the good news too. Sergei Krikalev, one of the greatest astronauts of all times, is the Soviet-Russian cosmonaut, wrote a paper on essentially basically creativity versus determinism. He pointed out that in the International Space Station, we've lost the capability to do creative exploration, such as you see with the Apollo, with the Apollo astronauts. We need to regain that. There's a big reset we need to do here. And in fact, we have the people to do that. Here's the 21st astronaut class, an incredible group of people. I still work in astronaut training, and I was very proud to have them present me with this patch when I did my last briefing there. And you can see what it is. Here's the International Space Station. They're not interested in just going to the space station. They want to go to the destinations and explore the planets. Keep that in mind. They are super individuals, extremely bright, highly motivated, and great students. So let me say something about the promise and tyranny of technology. We need to develop new tools to help the astronauts real time look for olivine, look for key minerals, etc. But there's a tyranny to that too. We'll be thinking we want to avoid having the astronauts being treated as, in fact, just robots. Okay, you really need to keep that in mind. When Dave Scott went to the moon, he said, Jim, when he got back, he told me, he said, Jim, I was having so much fun doing the geology that I didn't even know I was in my spacesuit. I was in the zone, like sports figures in the zone, like unbelievable. That's how we need to be. These astronauts are really critically important. We don't want to load them up with tasks, but we want to appreciate that they are the ones that have the situational awareness on the moon. And we want to follow the Apollo credo of T cubed, train them, trust them, and then turn them loose. This has big implications for ConOps, et cetera, and astronaut training. Lots of work needs to be done here so that we don't interfere with them, but that we assist them. And of course, infrastructure is critical for full lunar access. Let me just close with 2 points here. One of them is diversity and inclusiveness. It's easy to pull down the statues of the past. The hard part is actually solving the problem. The hard part is constructing a firm foundation on which to build a better future, as this is an activity that Greg Schmidt is passionately pursuing. So instead of retroactively demonizing the Apollo program for not being more inclusive, let's adopt a different perspective. Look at what the Apollo program accomplished with the talents of well less than 50% of the American population. Just think what we could accomplish by including the talents of a representative majority of the entire population of the United States. Don't just erect new statues, instead do the hard work of building a new inclusive foundation that leaves a solid legacy of accomplishments in science, technology, and national leadership that transcends Apollo by at least 100%. That's your challenge. And if you don't think you can do it, remember that the average age in mission control during Apollo was in the 20s. So the last point I want to make is international leadership and cooperation. Let's step outside of the United States and look back inwards at ourselves. The era of American dominance in space is coming to an end. Wonderful community of countries is exploring the cosmos. It's just so great to see. It's incredible. To our credit, we have inspired and assisted many nations in exploring the cosmos and using the soft power of space exploration and accomplishments to build their national pride, how they view themselves, and their national prestige, how others view them. Most of you in this meeting probably don't fully appreciate that the Cold War was a purposeful alternative to a hot war, a nuclear holocaust from which no one on the planet survives intact. So thankfully, we're all still here. And this is in no small part due to Apollo, to Apollo-Soyuz test project, to Shuttle Mir program, and an International Space Station. So why don't we try to take a page from this history and think about what, in fact, we can do for the future. The population in the United States, one of the most diverse on the planet, still accounts for only about 4% of the total population of the world. China, on the other hand, accounts for about almost 20% of the world population. It also has a very robust space program with a recent, very successful landing of the Tianwen-1 Zhurong rover on Mars, the Chang'e 5 return of critical samples from the moon, and the taikonauts in the Chinese space station in Earth orbit. Why doesn't the United States take a page from our own space exploration history with the Soviets and Russians and reach out and engage China? Now, why don't we just ask China to join the Artemis Accords? Most of you are probably thinking, how do we do that when the Wolf Amendment, a US federal law, prohibits NASA from collaborating with China or spending NASA money on collaboration efforts with China? Careful reading of the Wolf Amendment shows that exceptions can be granted by petition to Congress, as has already been done, and multilateral cooperation and collaborations are specifically permitted. So I challenge you to be creative with your solutions, emphasize coordination, find a solution that permits engaging China in coordination, an approach permitted by the Wolf Amendment. We're at a major turning point in international space exploration. Quo vadis, where do we go from here? Learn from the past, the future is in your hands. Thank you.
Thank you very much, Jim. Fantastic. So much food for thought there. We are so lucky to have you, with us, and keep hearing. Every time I actually listen to your talk, I learn something new. So thank you very much for sharing all those, wealth of knowledge with us. I was pretty struck by your point number 9 and 10 when it actually appeared. And if anything, what we have discussed in this, 4 days of meeting, that gives me a lot of encouragement, actually, that going forward, those your bullet point number 9 and 10 are probably going to be addressed in some shape or form. I know we are running a little bit behind time, and this is not a typical conference talk, so I'm not going to invite questions. But of course, people are free to express their feelings about this talk in the chat window. So thanks once again, Jim. And I'm going to hand everybody over to Greg, who will introduce our next speaker. Greg, over to you.
Great. Thank you, Mahesh. And Jim, I want to add my own thanks as well. Thanks for your decades of leadership, your decades of outstanding science, your decades of mentoring some prominent members of the community. As Carol Stoker said in chat, what a resource you are personally. I love your perspective on equity, diversity, inclusion. We're on the road to bringing in an incredible talent that we just haven't had access to. That's what this is about, in addition to fairness. And your point about international leadership is so well taken. That's what this conference is all about. Mahesh on the one side, Christina and me and others on this side, working together for this amazing future. So thank you so much for your fabulous perspective. So we are so lucky to have had not just one, but two rock stars for our final speakers. And I have the great privilege of introducing our second. And given that Professor Lindy Elkins-Tanton is the PI of Psyche, and Lindy, I'm sure I'm not the first to say this, you're probably more in the category of the heavy metal rock star. So Psyche was selected in 2017 via Discovery. Lindy has been PI of this. I haven't had the privilege of participating in the meetings, but I do hear about them through Sarah, and I know Sarah just loves serving as your program scientist for that. Lindy is also vice president of the ASU Interplanetary Initiative. Her doctorate is from MIT. She is a two-time National Academy Kavli Frontiers of Science Fellow, 2009 Outstanding MIT Faculty Undergraduate Research Mentor, 2020 National Academy Arthur L. Day Prize in Lectureship Award winner, and a lot of other honors and awards. I take up all of her time just listing them. I want to add too, and I shared this with Lindy via email this last week, that I heard her talk about her management philosophy with Psyche, and it was, to me, very inspiring, about inclusiveness and about bridging science and engineering. And I think that we can all learn lessons from the way she does things. So Lindy's talk is on the Interplanetary Initiative. So it's an honor to have you with us, Lindy.
Thank you so much. It's lovely to be here, and both a great pleasure to follow my friend Jim, and also intimidating because I've got a totally different thing to talk about. And let me just also say, absolutely love having Sarah Noble on the Psyche project. And so we keep begging the moon not to take her away from us completely, but I know I'm talking to the wrong audience here. So nice to see so many friends here. So let me share my screen and talk to you about something that in fact is very future facing. And I'm going to be really curious to see what you all think. Does that look good? Can you see it? Excellent. Okay, so here's a piece of art from our Interplanetary Initiative, and you can see what we're talking about. We're talking about how we're becoming an interplanetary species. And this is a really special challenge, and it connects to these management concepts and also to what Jim is saying about including everyone and about trying to connect to other countries as well as to groups of people. And so let me show you, this is how I think of our current space landscape. I'm imagining on the left-hand side, I've drawn a little astronaut. I'm imagining that as NASA and ESA and JAXA and SpaceX and Blue Origin and people sending people into space. It's the engineering, the hardcore engineering, the traditional kind of spacefaring activities. Then there's a vast barren landscape, and on the far right, visionary futuristic sci-fi writers. And so in 2016, our ASU president, Michael Crow, called me into his office, and it was one of those funny moments where I had appeared on my calendar, you know, Michael Crow's office, and but no agenda, which is worrying when your president calls you in. And it turns out he wanted to talk to me about this problem. He said, look, we are becoming an interplanetary species, but all voices are not being heard. And something that we are pretty good at, or at least that we work hard at ASU, is being interdisciplinary in a really genuine way. And he said, I challenge you to bring all the disciplines to bear. So that's what we're trying to do. We're trying to create a community thinking about our interplanetary future that populates that landscape with all the different disciplines of humankind that are needed, artists and writers and philosophers and psychologists and everything you can imagine, policy and law, all the things that we need to be a complete human species as we become interplanetary. And so that is what I've made into an Interplanetary Initiative. And I want to talk to you a little bit today about what it is that we're building and what we're trying to do with it. And as ever, our motto is everyone is invited all the time. And so we have plenty of public events and also things like our quarterly meetings. And when we think up new pilot projects that we seed fund, everyone is invited. So anyone who hears this talk and is interested in participating, please send along your email. We'll put you on the mailing list and you are invited. So we have a vision statement. An interplanetary future built upon cooperative and inclusive new structures, systems, and perspectives. And so you can see from this vision statement that we believe that to create this kind of interdisciplinary planetary future, we actually do need to create new structures and new perspectives and new processes. And I'll talk a little bit about what we've been experimenting with so far. We also have a mission statement. We deploy new ways of building teams and solving problems at scale. I think it has to be at scale or it's not even worth our time right now. We're in a little bit of an urgent state as humanity on our planet. Partnered across disciplines, sectors, and cultures to shape an inclusive and sustainable interplanetary future. So that's our mission. That's what we try to tie what we're working on to. And so we imagine ourselves as connecting the private sector, government, and ASU and other universities. And so we're very much outward facing at the university, and therefore an unusual structure. What we are is a pan-university initiative. We do not sit in the School of Earth and Space Exploration. In fact, I report directly to the provost and the executive vice president for research with this project. And even from our first year in 2017, we had over 50 units and centers across the university involved and 20 outside partners. And we continue to try to work that way as a networker. as a new idea bringer. And so we think about our work in terms of two different pillars. This is how our projects and communications point to our vision. The first one is empowering individuals to see themselves as interplanetary and take an active part in creating the space future they want. And I think of this like not in a kind of a, I don't know, really futuristic or kind of detached or idealistic kind of sense. I think about this in a very, very pragmatic sense, that as humanity, we are facing climate issues primarily, also obviously pandemic and many other issues that threaten everything about the things that we do, including our lovely exploration of space that we love. And one of the things we need to do is learn to look up from our dusty feet and see our place in the solar system and in the universe in order to get the perspective we need to work together and create these changes. So then our other side, our other pillar is ensuring broad societal participation and consideration in creating these structures and systems. So on the empowering individuals side, what we've mainly been working on in the last 4 years is experimental learning programs that teach agency, initiative, and problem solving. So much of standard education in our world today is still passive. It actually trains people to be passive. What we're trying to do is train people to be active thinkers, to take agency, to notice what needs to be solved, to have confidence to move towards solving it. So we've launched a new major, the technological leadership major. We just launched it during COVID last August, a year ago. I'll talk a little bit more about that. We have a very bold new project called the Open Citizen Project, and we just have pilots right now, and we are doing a big launch this fall. This is basically a structure, a process, a scaffold for training people how to identify a problem they want to solve, do the research that's necessary, synthesize that information, choose an action or an outcome, and actually execute on that action and outcome, the kind of actual path to change that is seldom taught as a process. And this is can be done in groups, in schools or outside of schools, in community centers, libraries, in companies, whoever is interested. So that's Open Citizen Project that's just launching right now. And now we have a planned online master's for scientists and engineers who are now leading large projects. And I might here be talking about myself, but I spent 10 years in business before I came back to the university and research world. And that information that I learned, you know, never did become an expert in 10 years, but I learned a lot about leadership and management, or at least I formed a lot of opinions that have been very helpful working with Psyche. And so this is a master's for people who are doing this. So we had got 50 undergraduate majors in our first year with technological leadership, and we have 5 Open Citizen Project pilots. That's where we are right now on the education side. Now on the societal side, our biggest work is internal ASU seed-funded pilots to jumpstart critical work in preparation for external funding. And I'm going to tell you how we do this because we've been developing and continue to develop and experiment with a quite unusual way to put together teams such that they are interdisciplinary from the start and move outside of the idea space of an individual person into the idea space that the whole group finds to be important. We have an interplanetary lab space, which I'll give you a little information about because it is specifically for space exploration projects that are partnered with outside partners. And then we do a lot of public-facing things. First of all, we have a special by invitation only convening about space futures, where we bring together people from government, private sector, and universities around specific problems. This fall, we will launch our Open Citizen Gathering, which is about student-centered and project-based learning experiences. And so if you have an interest in that, you might want to join us at this gathering, let me know. We have a podcast, and we do a lot of lectures and panels. So we've done 26 seed-funded pilots over 4 years. So far, they have an 8 times return on investment. So through our pilot project process, we give them a small amount of seed funds. So far, they've been able to get 8 times that amount of money in external federal and philanthropic funding that follows up. So we feel that's a good measure of success there. We've had over 25,000 people at our live and virtual events and 1 million social media impressions, and we have 10,000 monthly email subscribers. So we're trying to reach out and see who we can find. So what is learning in the information age? What is this technological leadership major that I'm talking about? I do maintain that content is now everywhere. And so content is not the thing that you go and beg the university for. It's the only place you can get that content at the university. Unless, of course, you're coming to talk with Jim Head, in which case it is a unique source of content that's hard to find elsewhere. But in general, there's a huge amount of content out in the world. And what people need to learn is how to find it, how to decide what its quality is, and what to do with it. So we're trying to teach processes. Companies seek candidates with transferable skills and hard skills, and almost no undergraduate programs explicitly train and measure transferable skills, but we do. So our major consists of 4 parts that is designed, and it's designed to be completed in 3 years. On the far right-hand side, you'll see internships. So we have 2 summer internships that are required to get people into that kind of job mindset. We have a series of foundational classes: English, calculus, programming, physics, stats, positive leadership theory, conceptualizing learning, that's cognitive science, and problem solving through strategic thinking. And then every semester, every student takes a thinking course and a making course. And these are both student-led problem solving courses. The ones that I've really been creating and working on now for 6 years are the thinking courses. This is what's called open inquiry, where the students select the goal that they're trying to go for, and then we train them in how to find, in fact, in our case, peer-reviewed research papers, whether they're freshmen or 5th-year graduate students. They all read peer-reviewed papers, synthesize their information, decide on their next questions, assess how well they're proceeding. And one of the interesting things about this is we've developed over time a rubric for scoring the excellence of someone's research questions. So we can actually help them in a quantitative way to improve the research questions that they're asking. Some of this work is also happening at our tech startup, Beagle Learning, that does a platform that allows this. So this is the major with 50 undergraduates, and where it's all an experiment. So far, so good. So then how do we speed up and target research? What am I talking about with these pilot projects? First, a tiny bit of news about the lab. It's a nice big lab, 6,000 square feet. It opened right before COVID. And it's available for users now, staffed by engineering students, very well trained, and we have support for projects. It's really a space, hardware, and software build, test, and fly lab. We've got oscilloscopes and signal generators and all the stuff we need on the electronics side, printers, this kind of thing. And then we also have a vacuum chamber, thermal chamber, drill presses, attitude test beds, things that we can use for CubeSats. And so that's one thing that we've got to play with, and that we invite you to develop projects with us for. And then this is how we've been building teams. And for these pilots, before I walk through this, I just want to say, I'm very inspired really by the way that a good mission team works. It's quite different than what we normally do in academia, although I think it's a lot more like the SSERVI teams that you all are working on, where many different disciplines are at the table together. You know, think about a traditional university capstone engineering class. They'll say it's interdisciplinary if they have an electrical engineer working with a mechanical engineer. And in my world, that does not count as interdisciplinary. You know, for the real world, you have to have the engineers and the scientists working with graphic designers and UX UI people and marketers and schedulers and budgeters and with project managers. And you need to get all those kinds of expertise at the table. You know, maybe you need sociologists, maybe you need psychologists or economists, getting people used to really working in an interdisciplinary team and listening to one another. So we do not invite proposals for these projects. What we do is we get together, and on the far left, you can see brainstorm the biggest questions. The first time we did this, we had about 50 people in the room. We had a couple of deans, we had faculty, we had graduate students and postdocs, we had undergraduates, we had staff from all around the university, and we had people from the community, just like friends off the street, frankly, and we had people from private sector companies. So really broad set of thoughts. And the question was, what are the most important things for us to solve, for us to have a positive human space future? And we started getting some great questions up there, like how do we get the general public to support space exploration? Or how do we prepare the next generation of space explorers? And then we had more technical questions too. We get all these questions up on the board, then we vote on the most important ones. So this is a very important step. We're not coming in with the individual disciplinary leaders who say, I want to do this research question because it's the next obvious research question in my world for my subdiscipline. We want to get away from that. We don't want to be incrementalists anymore. I'll show you in a moment just the title of an essay that I wrote for Issues in Science and Technology. It just came out this week about should we say goodbye to our heroes? So I think of this as the hero model of academia, where you have one, hair doctor professor who owns a pyramid of resources that include other faculty positions and staff and all kinds of lab space and money and resources, and they own the topic of their research as well. And so this creates, of course, tremendous progress, which we've had, but also a kind of a hothouse for harassment, exclusion, bullying, which cannot always be stopped by people from the outside of the pyramid, and also incremental research. Unless those heroes are visionary, they make increments of research by adding little strips of real estate to the feet of their mountain. So I think we need to get away from that. So we vote on the most important questions. We volunteer into teams right on the spot. And on the spot, people are challenged. Decide on 1-year milestones. What could you achieve in 1 year to get toward this giant aspirational question you're trying to solve? Then we choose a leader, not till then. Then we send them away for 2 weeks. And if they can come back with all the missing disciplines they need for their project and a budget, then we place them under professional project management, and we give them seed money. This is how we put together these pilots. It's worked incredibly well. This year, I think we've had 4 pilots through COVID, but last year we had, I think, 8 pilots. We have about 100 team members and about 20 external partners working on this. 3 examples are the Earth Operations Center, which is a collaboration between ourselves, NASA headquarters, and MIT to create a big decision theater around climate information about planet Earth. And it's going to be both virtual and in Cambridge. We have Port of Mars, which is a project that is led by a professor of theater in collaboration with professional game designers and sociologists. And the plan here was to collect usable social science data on how people in 2 competing settlements on Mars will behave toward each other in the form of a fun multiplayer game. So we've done this. They've published a paper on it in a peer-reviewed journal with the information they got, and another one's coming. Then 5 senses in space. The idea is to bring back from space the things that a human would experience in space and load it into a holodeck so that people on Earth can have the space experience. It can be for lab work or for teamwork, or it can be just for experiencing this. And so we've got a lot of like AR, VR set up already, but a really cool aspect of this is that the teams have figured out how to reproduce smells from any organic molecules. And so one thing they've been doing is capturing the smells of moon dust and also of organic meteorites and reproducing that in the space so that you will smell what you would really smell. So those are some of our pilots. And this is the essay that I just published, Time to Say Goodbye to Our Heroes. And really what we're trying to do is create a much more egalitarian research future that moves faster toward important targeted outcomes, includes all voices, and prepares humans for our interplanetary future. And so finally, I just want to share, this is our Twitter handle and our website. Sorry, there's a typo there. I obviously didn't completely delete the Psyche website you see at the beginning, but it's interplanetary.asu.edu. And just a thought, be bold and be kind. And thank you so very much for inviting me to speak. And I hope this was an interesting kind of future looking one alternative to end on today.
Wow. Thank you so much, Lindy. What a privilege to hear about this. I can't imagine a better conclusion for this conference. We're going, I mean, we saw earlier this week the Blue Origin flight, right? I mean, it's very clear we're going back to space in a big way, in a different way. And I guess where you're leading us is the right way to do it. So I will confess, all of your slides make me want to go back to school. So
that's really kind. And it's so nice to see these lovely messages, how supportive you are of each other. And now I'm receiving it a little in the chat. And so great to see so many friends. Thanks so much for this. It's really a great opportunity.
Yeah, thank you. Thank you so much, Lindy. We really, really appreciate it. Thanks for the perspective. So So what we would like to do now, first of all, we'd like to share a few thank yous for this forum, and then Mahesh and I have some closing comments. So so in terms of thank yous, Mahesh and Christina and I and Carolyn van der Bogert and Parvati Prem, we met every week, sometimes a couple of times a week, not always easy with the cross-Atlantic collaboration, but what an incredible experience that was. And I want to start by thanking Carolyn and Parvati, and Mahesh, feel free to interject in at any point, of course. But I really, they've kind of set a new standard in terms of SOC, and I want to thank the rest of the SOC as well. I'd like to thank all of our great session chairs who did just a fabulous job, particularly the next generation chairs. This is, like I mentioned, this is a permanent part of our meetings from now on, to give young people a chance at this, a chance for a little visibility and experience. I, of course, want to thank all of the speakers, the leadership from both ESA and NASA headquarters that were at the panel this morning. The community, I want to thank the ASL interpreters, and then I'd like to thank SSERVI staff, and we have a slide that shows everyone here. Some particular notes: Ricky Guest, who I think so many of you know from all of the various conferences that he's supported during the pandemic, certainly going well beyond SSERVI in such an expert way. Ashkan and Maria, who were the architects of GatherTown, who have been our experts on sorry, I knew this was going to happen. It's okay. It always does, on the web and everything. And Teague, who makes sure everything sounds good, and Jen, who makes sure everything looks great. Brian, of course, for all his myriad of contributions, and all the rest of our staff. And of course, I'm saving the best for last in a way, and that's Christina, my partner with all of these things here. You know, I can't tell you how much I personally appreciate. Sorry, what you've done. And let me just get my composure here for a second. Particularly in the difficult time I had earlier this year with my own personal loss. But anyway, so thank you, and thank you to anyone that I might have missed as well through this. So Mahesh, maybe I'll turn it over to you right now. And oh, I'm sorry, I want to thank you, Mahesh. I forgot for a brief second. I just can't tell you what a pleasure it's been working with you on this, and working with you the last 13 years on making this great thing that we do, a truly international endeavor. So so if you want to have if you'd like to say a few things, and then I have a couple more, feel free.
Sure. Thanks, Greg. I mean, you have covered everything, and I think ultimately what matters most to both of us is what we do for the community, and seeing everybody coming together this way. and sharing their thoughts. I always feel that every year we think that actually we can't do it any better, but we just surprise ourselves. And I think this year we have surprised ourselves massively. And I really want to thank you for entertaining my crazy idea of combining the two conferences, despite the time difference in the time zones, etc. As you can see, just outside my window, it's just about to get dark, even though it's almost 9 o'clock. And colleagues, further east from me, they have obviously, much later at night, and yet they are still with us. And I think we have achieved something very special this year. I told you right at the beginning that let's take this as an experiment. And if it doesn't work, then it's my fault. But if it works, then I think it's all Christina and the SOCs who have put so much effort into this, that they just ensured that this just couldn't have gone wrong at all. And I'm just so grateful to Parvati and Carolyn. I tried to keep track of everything. We met every week. But they were just on top of everything, that by the time I got to grips with things, they had already sorted things out. So I think they were superhumans. And so we can't thank them enough. And together with Christina, we were just rest assured that things would go very smoothly. And with Ricky at the helm, with Ashcon and the rest of the teams, I had absolutely no doubt. But having said that, I do hope that in the next year or so, we do get a chance to meet in person, if not everyone, but at least those who can. And I very much look forward to welcoming the participants of this meeting to a European meeting on European soil, so to speak. Not that, I'm not overjoyed with the success that we had, but I think going forward, I can see that we would like to have a mixture of two approaches. And I'm really looking forward to what future holds for us. I've been truly excited by all those presentations from early career researchers and the graduate students, the level at which they engaged with this meeting. I just felt that it very much looked like a complete meeting, not just a conference, but a conference that actually had an emotional touch to it. So yeah, I can go on, but I think I must finish and hand things over to you, Greg, and just say thank you to everyone who joined us earlier this week and who is still together with us in this meeting. So thank you.
Thank you, Mahesh. And Ricky, I wonder if you could bring up that moon image, please. This is a picture that Sarah Noble put on Facebook. And if you haven't seen Sarah's work, I highly recommend it. It's gorgeous. Her education isn't just science. For those who aren't aware, she has an art background as well. And to me, this was just incredibly inspiring. And seeing this on the last day of the forum, I just thought, wow, I mean, this is where we're going. We're going back to the moon, or forward to the moon, as Carly so aptly says. And this image, this beautiful image, Sarah just captures this so well. I think that we're moving in some great directions. We're bringing in people that haven't had a chance to participate in ways that Lindy, so wonderfully articulated in the last talk. We have a lot of challenges ahead of us. As Mahesh mentions, we're all looking forward to seeing each other. I think there's going to be an awful lot of hugs, in the coming meetings. But what we also want to do is make sure that we retain a level playing field for those who can't be there in person, and that's going to be a big effort at SSERVI in the next months, is figuring out how to do blended virtual and in-person meetings. But quite frankly, with this amazing team, it's going to be figured out, and with your help, we're hopefully going to be doing it right. So So with that, I want to close with the two words that that Paul brought up of Gene Shoemaker's, and that's be amazed. We live in amazing times, and be amazed. What a wonderful thought. Thank you all so much for joining us these past days, and what a privilege to have worked with you, to have heard your talks, and to have this great community and great friendship with you. Thank you so much. Bye-bye.
Goodbye, everyone.
Bye, Mahesh.
Thank you, guys.
It's been awesome.
Thank you so much for the great experience. Greetings from the Arecibo Observatory in Puerto Rico. It was outstanding.
I'm so glad you joined. And yeah, and Dave, good to see you, and thanks for all the great comments. Thanks, everyone.
You guys killed it. Greg, we're going to talk soon about this whole blended meeting thing. This is the future. This meeting right here was the starting point. Right here.
Excellent. Next week.
Go relax. And then we're totally here. I felt you, Greg. We're totally here for you. You're getting me all for Clint too. But this is what this community is about.
Yeah. Well, it comes from a place of love, right? You know, I
totally.
Yeah.
You can't fake this.
No.
You can't fake it. No, all of you, Parvati, all you people who made this conference what it was, Mahesh, everybody, you have earned a serious weekend. So I hope you have a serious weekend. If you need me to write a note, from the chief scientist office, they have the weekend. Just let me know. Well, you got
yeah, this is from Dr. Draper here.
That's right. Because everybody listens to me. It's hard. I'm finding myself having a really hard time pressing that leave button, because this is when we would be milling around, job well done, it's over, man. What are you drinking, son? This is the time to start all that. And I felt the same way at the end of every LPSC. It was on the one hand, I couldn't wait to lie down and just crash. But at the same time, man, it's like, this has been so great. I don't want to see it come to a close. It's like a good book.
I know. It's that's for sure. That's for sure. Yeah, Christina, are you there right now? I see your name. Christina is just yeah. I knew that when I thanked you, it was. You didn't have to be on camera, though. Anyway.
Well, this is what there are things that have come out of this pandemic that we couldn't have gotten to any other way. I'm not sure we paid a high price, okay? We're still paying it. But there have been some things that have come out of this that couldn't have happened any other way. There have been some equities that have been, let me put it this way. Our ability to really identify where the inequities are, the bright spotlight has been shone by this thing, but be able to find some of these new ways to do things we couldn't do before. We cannot let this opportunity slip away to improve on it.
Yeah. I feel 100% that way, Dave, and that's really right now. The institute, it's already fabulous scientifically. I don't really need to move the rudder on that. What we do need to do is